Hey everyone, welcome to my Python for Beginners course. In this course, you're going to learn everything you need to know to start your programming journey in Python. In this video, I'll briefly explain what programming is for those who are new to it, and we'll install the apps and tools necessary to create Python apps. We'll then move on to the basics of Python and continue our way up. If you're a beginner to programming, don't worry. I'll go over everything step by step so you can understand all the necessary concepts. If you're not new to programming and just want to learn another language, you can use this course too. Python is the most popular programming language in the world right now, and it has a huge community of people working on all sorts of things. Python is used for many things, from automating tasks, making apps and websites, to even creating AI. Programming, also known as coding, is the process of creating instructions for a computer to perform specific tasks. It involves writing and organizing sets of commands, algorithms, and logic that a computer can understand and execute. These instructions are written in programming languages, which act as a medium of communication between humans and computers. Everything you do on a computer was programmed by someone. All the apps you use, the websites you visit, your operating system, and so much more was created with a programming language. Each programming language does slightly different things. Python is a general purpose one, so that means it can do many different things. But on the other hand, for example, SQL is not general purpose. It's only used to manage and manipulate databases, which are just large collections of information. No developer knows how to do everything, meaning no one knows everything about programming. Also, it's good to note that there are thousands of programming languages and no one knows them all. In this field, you have to choose your niche. For example, that could be back-end web development, which is essentially what goes on behind the scenes in a website. Or you could choose to create games or anything else. Of course, you don't have to choose your niche right now, since you haven't even written your first line of code. If you're new to programming, Python was a great choice because it's general purpose and it's the easiest to learn. So you don't have to choose your niche until you become proficient in the language. In addition, this course will not be set on a specific niche. Instead, I will go over everything you need to know to become proficient at Python, so you can choose your niche afterward and do what you like best. All you have to know for now is that a programming language is like teaching a computer how to perform tasks. Learning programming has become an essential skill in today's technology-driven world. It empowers you to become more creative, analytical, and efficient in problem solving. You can build websites, create mobile apps, analyze data, design games, and even automate repetitive tasks, making your life easier. Computers don't understand human language. They only comprehend binary code, a series of zeros and ones. To communicate with computers effectively, we need to use programming languages, which act as a bridge between human instructions and machine execution. Binary code is extremely hard to use because it's impossible to read like a language, and it takes a very long time to use and especially learn. In fact, binary is not even a programming language, it's just a way to convey information to a computer. Programming languages are just sets of rules and syntax that allow us to write code and communicate with computers. They come in different flavors, each suited for various tasks. Now I'm going to explain to you some various programming words to know. You do not have to memorize these. So you might have heard me say syntax, and syntax just refers to the grammar of a programming language. It just defines how code should be formatted and arranged to be valid and understandable by the computer. Each language has its own syntax, so syntax is just what makes a programming language. Writing code with correct syntax is crucial because even a minor error can lead to the program not functioning as expected or even not running at all. For example, the syntax to put hello on the screen would be system.out.println hello in Java, and it would be print hello in Python. Of course, don't memorize any of these, I'm just giving examples. In programming, data refers to any piece of information that can be processed, stored, or transmitted by a computer. Data can take various forms. Statements are the individual instructions we give to a computer. Each statement tells the computer to perform a specific action, like printing text on the screen, calculating numbers, or making decisions based on conditions. If you enjoy programming and working with computers, programming will probably be fun for you because of the fact that you can choose your niche. If you've always wanted to build a website, try doing that instead of another field of computer science that you find boring. You'll have to solve problems, but once you solve them, your goal will be achieved. Depending on what you do, programming could look different for you. In addition, you're always learning. In your programming journey, you'll eventually encounter new things like other languages, scripting languages, and more. You don't have to learn them all, but if one of them has to do with your niche, then you can learn it if you want, but it's not required. However, don't let all of this intimidate you, because you don't have to know everything. There's always more to learn about your specialty, and as more technology comes out, there will be even more, but that doesn't mean you have to learn all of it. If you're ever confused on how to do something, don't be afraid to look it up and ask someone, because a lot of programming is just looking things up, since it's impossible to know everything, like I said. So now let's understand what Python is and why it's so popular. It's powerful, high level, and it's general purpose, known for its simplicity, readability, and versatility. Python's design philosophy emphasizes code readability and an easy-to-understand syntax, making it an excellent choice for beginners and experienced programmers alike. It's widely used for building a variety of applications, from web development and mobile apps to machine learning and the creation of AI. In this course, I'm going to assume that you're a complete beginner to programming, but if you have programmed before, like I said, you can still use this course. You'll start at a beginner level and build your way up. To get started with Python, you'll have to go to python.org and download Python. You'll hover over Downloads and download the one for your operating system. First, I'll show you with Windows. At python.org, hover over Downloads and click on the big button that says Python and then a version number. Then click on the download once it's done and keep clicking Next until it installs. It's pretty straightforward. If you're on a Linux-based operating system, it sometimes comes pre-installed, but if not, then just look how to install it for your specific operating system, which is pretty easy. For me, I'm on Ubuntu, so I'll look up Python 3 Ubuntu install and go to a website and copy the commands. Since it's Linux, it's really easy to do, so there's not much else to say. On macOS, hover over Downloads, hit the big button with Python and the version number, and choose to save the file. Once it downloads, click on it, and keep clicking Continue until Python gets installed. Once installed, you can click Close and move the installer to the trash. Before you get started coding, I suggest getting a good text editor, because while you can write Python in any text editor, it's a good idea to have a text editor that's made specifically for coding, like Visual Studio Code, also called VS Code. That's because there are a lot of great programming tools, auto-suggestions, and more included in code-specific editors. In this course, I'll be using VS Code. Down in the YouTube description are timestamps so that you can click on them throughout the video to jump to different sections if you'd like. Hello everyone, and in this tutorial I'm going to be talking about 4 basic data types in Python. So you should open up your text editor now. It doesn't matter which one you get, but if you aren't familiar with navigating applications like code editors, I suggest getting Visual Studio Code so your screen will look like mine. A lot of other tutorials go into print statements first, which output text to the console. The console is this window down here, but I think that to fully understand the 4 data types, it is best to explain them in detail before we start more complicated programming. That way it'll all make sense when you get further into your Python journey. So before I get into data types in Python, I'd like you to know what data types are. I know it sounds obvious, but think of data types as the type of data we store in our computer's RAM or memory. When we create a variable, which you will learn in a minute, the value gets stored in the computer's RAM. That's how all programs work. Each piece of data is separated into its own category, and each category is called a data type. For example, if we stored a message, the type of data would be text. Now don't worry too much about all this just yet, because you haven't even created your first variable. I just wanted you to know a bit of background information before we jump in. I just created a file called tutorial.py. All Python files have the .py extension, and you can name the file whatever you want, but mine is tutorial. So just make sure that if you're writing a Python file, it ends in .py because that means it's Python. So in this file, you can start writing your first Python program. In this section, we'll dive into the world of variables and data types. Understanding these concepts is crucial to know for every Python programmer, so let's get started. Variables are containers that hold values in our programs. They're stored in the computer's memory or RAM while the program is running. Think of them as a box that's labeled tools. You have a wrench in the box, but you can take it out and put a hammer inside it instead. While the tool has changed, the box labeled tools still contains a tool. That's very similar to a variable in computer science. Let's look at an example. We can set the variable message equal to hello world. Hello world is the traditional first program written by beginners of any language. In the next videos, we'll show you how to make your program say hello world. But for now, we're just setting a variable equal to it. So in this example, we've created a variable called message, and we've assigned it to the string hello world. If you don't know what a string is, don't worry yet, because I'll explain that in a second. So if you're confused about this assigning a variable, think of it as this. The label message is equal to the value, which is hello world. So there are some rules with variable names. First of all, you can't create a Python variable that is the name of a Python keyword. Python keywords are words like if, and, else, elif, or, true, false, str for string, int for integer, bool for boolean. You don't have to memorize them all, because if you ever try to type one as the name of your variable, your code editor, for me, VS Code, will change the color of the word. So for example, message is not a Python keyword, so I can make it a variable. But if I wanted to make the word true a variable, with a capital T, you can't name this a variable because true is a Python keyword, and you can tell because it is a different color than other variables. Besides that, here are the three main rules for Python variables. Variables cannot contain spaces, variables cannot start with a number, and variables can't use any special characters except for underscores. Don't get too hung up on this, because if you don't follow one of these rules, Python will just give you an error and tell you what's wrong. Let me show you. If I created a variable with a number at the start, like one message, the error would be, once we save the file, make sure you save the file before running it. Click Run in VS Code over here, if you're using VS Code, and it is invalid decimal literal, which means that it's trying to get a decimal number because it thinks that we're referencing some kind of number here. So it would tell you the line, so right now it's line 3, and it's pointing directly at where the problem is. So now we can change our message to message 1. Now let's say all of our variables were correctly named. When we save this and then run it, we get no output. Output is the result or response that a computer program generates when it's executed or run. It is the information or data that the program produces based on the instructions you've provided. With this program, we have not provided any instructions to do anything with the variables. We've assigned them, and for a short amount of time that the program was running, the variables were stored in our memory. But we didn't tell Python to do anything with these variables besides assigning them. Python read the file from top to bottom and has reached the end of the file and did not put anything because we didn't tell it to do anything. But that's okay. We'll add output in the next video. There are also some conventions for variable names that don't necessarily have to be followed, but it's a pretty good idea to follow them. Variable names should be meaningful. Don't name a variable R or a bunch of random letters because it's not meaningful. Instead, be descriptive by saying message instead of just saying something like M. Your meaningful names should be words and generally not abbreviations. Python also uses the snake case convention. Snake case is a type of variable naming convention where when you want to express multiple words in your variable name, you separate them with underscores. Since you can't use spaces in your variables, we need to use something, and in Python, most people use underscores. So if I were to make a variable that's called this is the message, you know that it's going to say that this is not defined, and it would stop here and it would give you the error. We need to have indication that this is all one variable, and so Python will only read this as one variable if we put underscores in between it. And now this is snake case, where each word is connected by an underscore. There are also other programming languages that have the camel case convention, which is like this. As you can see, each word is capitalized except for the first one. But in Python, it's suggested to use snake case because that's what most people do with Python. If any of what I just said is confusing to you, don't worry because you'll get the hang of it. As long as you follow some conventions, you'll be fine. The variable message is equal to a string, so the type of data or data type that is stored in message is a string. Hello world is the string. So what is a string? A string is a sequence of characters. Strings can contain pretty much any character that we can type, and they're always surrounded with quotes. These can be double quotes or single quotes, and there are a few more like triple double quotes and triple single quotes. But these two aren't used very often, and we're not going to deal with them right now. In Python, the type of quote that you use doesn't matter, as long as you use the same type of quote for the current string. Meaning you can't have the string hello world starting with a double quote and ending with a single quote. So if I created another variable that was equal to hello world, but just used single quotes instead, there would be no difference in the functionality of your code. Right now you know one data type in Python. You know strings. But now I'm going to teach you what integers are. Integers are whole numbers without any decimal or fractional parts. In Python, you can work with positive and negative integers. Let's explore some examples. In Python, you can assign an integer value to a variable. For example, we can set age equal to 25. Right now, Python has evaluated 25 as a number, the number 25. The difference between strings and integers is that, for example, if we set another variable equal to age 1 and it was 25 over here, this is evaluated as simply text, while this is evaluated as an actual number. What I mean by this is if we added 1 to this number, it would be 26 if we returned this value to the shell console. But if we added 1 as a string to this, it would be 251. You'll learn about returning this to the console in the next video, and it'll all make more sense. But anyway, integers support various arithmetic operations, allowing you to perform calculations. Let's look at some of the common operations. Addition is performed using the plus symbol, like I just showed you. Subtraction is used with the minus symbol. Multiplication is with the asterisk symbol, and division is with the slash symbol. So we can set two variables. num1 is equal to 10, and num2 is equal to 5. Addition result is equal to num1 plus num2. The output, if we were to return this to the console, would be 15. If I copied this code and just made a minus sign and changed this to subtraction, we have two variables now. One of them, addition result, is equal to these two numbers added together. Subtraction result is equal to num1 minus num2, which would be 5 because 10 minus 5 is 5. Multiplication result is equal to num1 times num2. This would return 50 because 10 times 5 is 50. Division result is equal to num1 divided by num2. 10 divided by 5 is 2, so division result is equal to 2. When you're dividing in Python, it returns the answer of this as a float. So now you know strings and integers. The next one is float. Floating point numbers are simply integers but with decimal places. A float can be 1.56 or it can be even 1.0. As long as it has the dot here, it is a float. So every division in Python will return a float. So as you can see, here are the outputted values. Python provides two additional operators for integer calculations: integer division and the modulo operator. Integer division uses double forward slashes like this to divide two numbers and return the whole number result, discarding any remainder. So if we had num1 equal to 10 and num2 equal to 3, we can have division result, instead of it being num1 divided by num2, we have num1 with two slashes divided by num2. The output would be 3, with not a floating point number. The module operator, denoted by the percent sign, like this, returns the remainder of the division between the two numbers. So, when you ever see a percent sign in Python, it means remainder. So if we had num1 divided by num2 with a modulo operator, we would get 1 because the remainder of num1 divided by num2 is 1. So instead of division result, it would be a better idea to name this remainder. In this section, we explored integers, which are whole numbers in Python. We also saw some floating point numbers as well, and we saw how to assign integer values to variables, perform basic arithmetic operations like addition, subtraction, multiplication, and division, and we learned about integer division and the modulo operator. In the previous section, we explored integers, and we did a little bit of floats. Now let's dive completely into floating point numbers, and they're just known as floats, and in Python they're also represented as float. Floats are used to represent numbers with decimal or fractional parts. They provide a way to work with numbers that are not whole. Let's take a look at some examples. In Python, you can assign a floating point value to a variable. For example, pi is equal to 3.14159. If we returned pi to the console, the output would be 3.14159. If we had a temperature that was 98.6, this would also be a floating point number. Similar to integers, they support the various arithmetic operations, allowing you to perform calculations. Let's see how to use these operations with floating point numbers. You can use the same operations we saw earlier: plus symbol, minus symbol, multiplication, division. So if we had numbers here, we had num1 is equal to 3.5 and num2 is equal to 1.2. We can have a variable called addition result equal to num1 plus num2. If we return this to the console, we would get 4.7. We can also have subtraction result. This would be 2.3. If we multiplied them, we would get 4.2, and if we divided them, we would get 2.91666666 repeating. In Python, when you get a repeating float, the end of the float does terminate, so it doesn't go on forever or anything like that. The output would be 2.9165, and it rounds. So Python data types can only store a certain amount. Floats can only store 64 bytes of memory. So that is around 15 to 17 decimal places. But don't worry about this for now. Like I said, it's important to note that floats have a limited precision, so depending on the calculations performed, you might encounter some rounding errors. For example, let's try dividing 1 by 3. The result would be 0.3 repeating. As you can see, the result's an approximation due to the limited precision of floats. The last data type I'm going to teach you about in this video is booleans. Without learning about conditional statements in Python yet, it might be a little bit hard to understand at first. But once you get into if statements, which check to see if certain values are true, booleans will become more prominent in your coding experience. Python represents boolean as bool. So we can have a variable named boolean, and it'll be fine. Just don't name it bool, because that's what Python does. So we can set boolean equal to either true or false. True and false have to be capitalized. You can't have a variable equal to false, because then it would try to get false as a variable, or true, because it would try to get true as a variable. It has to be capitalized like this. A lot of times your code editor will highlight true and false, or any other keyword to tell you that it is a keyword. So if you don't see the keyword for true and false, then you probably didn't type it correctly. For example, if I accidentally put 2 L's in it, you would see that's not correct. So Boolean values are to say that something is true or not true, like they imply. So if I said, is student present? So like, did the student show up to school? We could say true, because the student came to school. Eventually, somewhere in our program, we could have a conditional statement that checks if the student was present. Now you know these 4 data types. Pause the video and create 4 different variables, one with a string, one with an integer, one with a float, and one with a boolean. But the string variable, concatenate 2 strings together. For the integer variable, add 2 numbers together or subtract them or do whatever you want. With floats, do a different operation than you did with integers. And for the boolean, just do true or false. Alright, hopefully that went well. For strings, I'll do string 1 is equal to hello, space, and then plus world. The reason I'm putting the space here is because when we concatenate these 2 strings together, it will equal hello world instead of hello world without a space. If we didn't have the space, this is what it would look like. Int 1 is equal to 10 minus 6, for example. Float 1 is equal to 2.34 times 5.36. And then boolean 1 is equal to false. So this is what your code should look like similarly. Obviously not the same values or variable names, but it should look something similar to this. If you're able to do that, good job. If you weren't, maybe look back on this video and practice a little bit more with those before continuing with the next videos. If you remember the last video, we created a variable called message, and we assigned it to the string hello world. As I said in that video, it's traditional to output hello world into the console as one of your first programs as a programmer. Currently, if we run our program, we get no output. In this video, we will fix this and also learn a lot more about strings. For now, I'm going to delete this variable. In Python, to print text to the console, we can first type print, and then 2 parentheses, opening and closing. Now if we run our program, instead of getting no output, the output is just a new line. Now we have to get the print statement to write some text instead of a boring new line. We have to give our print statement an argument. An argument in programming is a way to pass in information to a function. In our case, it's a print statement. So print statements, by default, print a new line. We need to give our print statement more information because if we don't provide anything, it won't output anything. To give our print statement an argument, we simply type the information between the two parentheses. Think about what we're trying to print. Text, right? If you remember the previous video, raw text, or a sequence of characters, is called a string. If you remember, we write strings with quotes. So now, we can pass in any string to this print statement. Let's type hello world. Now, we can save our program and run it. As you can see, we have successfully printed hello world to the console. Now, pause the video and make the print statement say something else. You pick what it'll say. Alright, hopefully that went well. Simply change the text within the quotes. I'll make it say this is a print statement. Now we can run this, and as you can see, the text is changed. Now what if we wanted to print multiple lines? There are a few ways to do this, but for now we can write another print statement below the previous one. So if we wanted to print hi world instead of hello world, we get 2 lines of output, hello world and hi world, both in separate print statements. Let's say we wanted to print I'm using Python. We get a syntax error. You know why? Python thinks we ended the string at the quotation mark in the word I'm. To fix this, we could change from single quotes over here and over here to double quotes, and now it works. Also, note that if you're using a code editor like VS Code, for example, the colors will get messed up when you write a bug of this sort. With a correct string, every word in the string will be the same color. If you notice different colors within the same string, you'll get an error. Because as you can see, the letter I is tan and the rest is white. Now when we do this, we get the 2 lines. Now let's say we wanted to print something with both double quotes and single quotes. If we put this in our string here, you can see that first of all there's an incorrect color here, but second, if we were to just change these double quotes to single quotes on the sides here, it wouldn't work, because there's both double quotes and single quotes inside the string. To fix this, we can tell Python that it should count the quote as part of the string, with something called an escape sequence. Escape sequences are denoted with a backslash. So if we were to escape the problematic quote, which is this one right here, we would simply put a backslash in front of it. Don't worry, it will not be printed to the screen. Rather, Python will skip over it in the string. So what this is essentially doing is it's telling Python, hey, the next character after this backslash isn't supposed to be evaluated as an actual quote. It's just part of the string. So now if we save this and run it, it says, he said, I'm hungry, and everything's correct. You just typed the quote escape sequence. We can also have an escape sequence that symbolizes a new line. By typing \n in any string, a new line will separate whatever came before it and whatever came after it. So if we run this now, it says hello world on 2 different lines, but from the same print statement. So if you want to print multiple lines, it's generally a better idea to use the new line escape sequence, which is this, than typing multiple print statements like this. Another escape sequence that you can use is tab. So to symbolize typing the tab key, you can do \t. So if we put it in between hello and world, a big space will appear in between the 2 words. By the way, what I said before about everything in the same string being a certain color, usually escape sequences are a slightly different color than the rest of the string. So if you have an escape sequence, that's completely fine. A lot of you might be wondering how to actually type a backslash. Because if you know, typing a backslash will not work correctly because Python's thinking that this is an escape character. If you wanted to print a backslash, you'd simply type 2 of them. With 2, you're escaping the escape character, or escaping the backslash. This is because, as you know, Python treats backslashes as escape characters. So now, you're telling Python that the next character should actually be printed, so now we get 1 backslash. To print 2 backslashes, you'd simply type 2 more backslashes. Remember the message variable that was set to hello world that we created in the last video? Pause the video and think about how you'd use a print statement to print the contents of a variable. If you're confused, just keep watching. To print the contents of a variable, we type print, and then the 2 parentheses. Unlike what we did before, we'll actually not type the quotation marks. This is because we're telling Python to print a variable, not to directly print a string. So we can type message in here, and it would print the variable message. So when we save our file and run it, we now print hello world. You could still do hello world in quotes, but if you type a variable, the value can be dynamic. Depending on where you are in your program, message could equal something different. If I reassigned the variable message and set it equal to hi, and then we printed it, it will print hello world and then hi. This is because here, message is equal to hello world. At the time of printing, message was still equal to that. But after that, we've reassigned the value to hi, and at this time, it's equal to hi. So if we put the print statement above the reassignment down here, we'd run this, it would say hello world twice. Likewise, if we took these both and put them below the reassignment, and we ran this, it says hi and hi. The value hello world was never used in this program. It was just reassigned right after being assigned. In this section, you're going to be learning more about string concatenation. I did talk a little bit about this in the previous video, but I decided to also add it to this video and add a little bit more to this video so that you can learn more about it. So what string concatenation is let's say you had a string and it was hello, my name is. And let's say name was equal to Joe. If we wanted to print this, if we wanted to make it say hello, my name is Joe, what we would do is we could do string plus name. And so what this would print is hello, my name is Joe, right here. Another way to do this is we could completely just get rid of these variables and print hello, my name is Joe. So you can see what's going on under the hood here. Hello, my name is Joe. So you're doing this string plus this string. So remember, when you add strings, it just smashes them together. So we do this. Now the reason you would do this isn't just to add two strings together, there'd also be something in between here. So let's say that name was actually a variable, so we can set name equal to Joe. And over here we do plus name. Okay, so we see, hello, my name is Joe. Let's say we wanted to add a period at the end of the sentence. Well, we can't just do this, that's not what we do. We add a plus, and then just a period. And then we run it again and it says, hello, my name is Joe with a period. So what it did is it printed, hello, my name is plus the string Joe, which is contained in the name variable, and then plus just the string period, so that we have a period at the end of it. In the next section, you're going to learn about string formatting, which does this in an easier way, and you'll see why it's easier. But there are some other points in Python where you're going to need to use string concatenation instead. So let's say we had a bunch of variables, like age, he was 21. So we could say, we could print a new line after this, like you learned with escape characters. So we'd say /n for new line, I am, and then put a space, make sure you put a space, because if you didn't put a space, actually, this is what it would be. So, hello, my name is Joe, with no space, so that's why I added a space there if you're curious. I am, with a space, plus age, and then plus space, years old. So what this should do, you'll see why I said should in a second. Hello, my name is, with a space, so there's a space, plus name, and then new line, I am, space, 21, space, years old. Okay, this should work, right? Or doesn't it? It does not work. There is a type error, because like I said in the previous video, you can't add an int to an str. They're incompatible types. But if you wanted to do this, so for example, let me just get rid of all this so that it's easier to explain. Let's say we wanted this to just say I am age years old, right? You can't just add age. If 21 was a string, then it would work. It would say I'm 21 years old. But if we wanted to do mathematical calculations with this, like for example later in the program, add 1 to age because he gets older every year, so we do age equals age plus 1. So what this is just saying is you're adding the integers like we did in the previous video. We're doing age equals what age is currently, which is 21 plus 1, so age would now equal 22. So if we wanted to do something like that, we can't just do a string there. What we'd have to do is we'd have to convert this to a string. So in Python, ints can always be converted into strings. So in Python, if you want to convert an integer to a string, you just do str and then whatever the int is inside it. So str is a function, just like print. Print actually prints stuff to the console over here, but the function str doesn't print anything. It returns something. You'll learn more about that later in the course, but all this does is, for example, you can say print and then the string version of 1. So if we save this and ran it, oh sorry, I should comment this out. We run this and it says 1. So actually you didn't really notice a difference here. So if we did string, so here we go. So it says 1 string. If we didn't surround it with str, it would give us that type error, right? So when we put str around this, it's now a string. So with age, we could do the same thing. We could do str age. And now we can say, I'm 21 years old. Because age, just for this print statement, is a string. It doesn't actually change the value of the variable. It just returns the value so that you can print it. So right now, if we printed age, it would be an integer. So we can say age equals age plus 1. This would not work if it was a string. It would do the type error, but we didn't get an error, so it's completely fine. Similarly, you can do the same thing with integers, but we can get into that with advanced integers. This is a string video. So in this video, you learned that you can concatenate strings. So right now, I want you to create a variable called name, and it's your name. I want you to create a variable called age, and it is your age. And then here, you will print, hello, my name is your name, and then I am age years old. So pause the video and unpause it when you're ready. Okay, so here we are. We can say I am plus name. Name is a string, so we can add it here. And then plus period, space, I am, and then age plus years old, with space here. And then make sure that you convert this to a string, because age cannot be concatenated to a string since it's an integer. Now, we would just say Bob, and then over here, we just do 34, for example. And now we can print this, and it says, I'm Bob, I'm 34 years old. String formatting is a powerful technique that allows us to create dynamic and formatted strings by combining variables with text. There are 2 types of string formatting. The older method, known as percent formatting, involves using placeholders. We'll learn how to use the percent operator to format strings using variables and values first. Then we'll learn the second method. Here's an example to illustrate the use of percent formatting. We can set name equals John, and age is 25. We can set message equal to my name is, and then percent symbol s. You might notice a color change in percent s since you're replacing this section with whatever we were replacing it with. And then you say, and I'm percent s years old. And then here we put percent after the string. So after the string, we put percent, and then if you have one value, if you have 1% s in your string, you don't need parentheses. So you just type name, for example, if there's only 1. But we have 2, so we're going to have parentheses, and we say name, comma, age. So this is saying my name is percent s, and I'm percent s years old. Or my name is name, which is John, and I'm age, which is 25 years old. And how do I know what order this is going in? Well, over here, whatever order these percent s's show up in our string is the order that the values will be. So the first one is name, so the first percent s in the string is name, and the second one's age, so the second one is age. If we print message, we get my name is John and I'm 25 years old. As you can see down here, it looks completely normal. No percent s's are in the actual statement. It just says my name is John and I'm 25 years old. Another example of this is pretend a user has inputted the number 5, and we wanted to say you typed the number and then percent s. So here we do percent and then input. So this is the same as doing what we just did before, which is message equals and then this. And of course, you don't need parentheses since there's only one value here, 1% s. It's the same as doing this, except we're just putting it in the print statement over here. So we're printing the string, you type the number percent s and replacing the percent s with input. That's all it's doing. Now, what you could do is concatenating strings in this case, which would be pretty simple. Instead of doing this, you just do, you type the number and then you do plus input. So this is what you do if you don't want to use string formatting in this case. But a lot of times string formatting is more clean and it's easy because you don't have to keep putting like plus and strings and then plus and then a variable. You just have to put one string, that's it, and then just designate where you want to replace it with, and that's it. Now you know percent formatting. Pause the video and complete this code. What I want you to do is I want you to fill in name with your name. I want you to set age to your age, and then print I am, and then your name, and I am, and then how old you are. If you're stuck, just keep watching, and you'll find out. Alright, hopefully that went well. We can do my name is %s, and I am %s years old. Now, we can do %, and then in parentheses, here, we would type name, comma, age. Name, comma, age. So what this is doing is it's saying my name is %s. Okay, where is this first %s located? Name. So my name is, and then we would fill in name. So for example, John, like I did last time. And I am, okay, so this is the second %s, years old. So for age, we fill in age. Let's say he's 40 years old. So now if we ran this, it would say my name is John and I am 40 years old. Now let's explore a more modern and versatile method called f-string formatting. F-strings allow us to embed expressions inside curly braces within a string, making the code more readable and expressive. We'll see how f-strings simplify string formatting and make it easier to work with variables. Here's an example with f-strings. We could say name is equal to Bob, and his age is 30. We can set message equal to, and then we type f, my name is, and then in curly braces, name, and I'm age, years old. What this is doing is when Python sees this f right before a string starts, it knows that it's doing f-string formatting. And so this is f-string formatting. So once it sees this f, it goes through the string, and then the first time it sees curly braces, it says, okay, let's replace this with the variable that's inside here. So this is name, and I'm age, years old. And it's a lot simpler and more modern than percent formatting. It's really just a matter of preference on which one you use, but I think you should use f-string formatting if you're new to Python because it is more readable and is also modern, like I said. So now we can print this. And once we run this, it says, my name is Bob and I'm 30 years old. Next, what we can do is we can actually simplify this, take this piece of code, replace it with message, and just delete this variable. And so now we have a more concise piece of code. We are just simply printing the f-string. F-strings are also more concise, as you can see, because before, what you would have had to do is you would have had to do this. And then over here, you'd have to add a lot more code, which would be name, and sorry, this thing keeps popping up again, and age. So it's a lot more easy to read and it's more concise, but it's your preference. Alright, now I want you to pause the video and do the exact same thing that you did before with percent string formatting, but do it for f-string formatting. So make a variable for your name, and then make a variable for your age, and then use f-string formatting to print it. Alright, the way you could do this is you can say name is equal to Jack, age is equal to 45, and then you can print f for f-string formatting, and then we go my name is name, and I am age, years old. Now we print this, and you can see that it works. Now, for example, if you had the variables reassigned later in the program, the difference would be here that, for example, let's say they changed their age, so a year went by and they actually turned 46 instead. You can reprint this again, and then the second time, it would be 46. We didn't need to update the name again, because his name still stayed the same. He got older by 1 year. Hello everyone, in this video we'll explore the concept of string repetition using the multiplication operator in Python. This allows us to create multiple copies of a string quickly and efficiently. By multiplying a string with an integer value, we can create multiple copies of the string. Let's look at an example. If we set message equal to hello, and we had another variable called, let's say, repeated message, and that was equal to message times 3. So what this is doing, let's take out times 3 for now. Right now, this is just saying repeated message is equal to message. So message is equal to hello, so this value is hello. But if we added the times 3 back, it's equal to message, but 3 times. So it would be hello, 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 like this. And so we can see this if we did print repeated message. And there we go. Here's another example that showcases how string repetition can generate patterns. We could say pattern is equal to the @ symbol, repeated pattern equals pattern times 6. And then we can print repeated pattern, and when we print this, we get this. This can also be applied to other types of patterns that aren't just one character. We can have this, so it would print this 6 times, which is another pattern. We could actually have this if we wanted, and this would be like this. Or, we can have any type of pattern that we wanted. We can even have this giant long thing, and it prints it 6 times. Here's another example. We can set name equal to John, and we can set formatted name equal to, we're going to use f-string formatting here, name, and then name, and then we'll add a new line, and then we'll just add a dash times 10. So what this is doing is we're using f-string formatting to replace this section with the variable name, and then we're creating a new line, and guess what this does? It prints the dash 10 times, so it'll look like this. Now we can print formatted name, and now let's run it. We get name John with these under it. Now these dashes could be useful, for example, if we were adding a new line and then saying age, and then let's say we had an age variable, I'll just say 34, and we can say house equals 1, 2, 3, 4, 5 street. If we had this, we've got his name, and then a separator, and then all of his information. And so if we had multiple people, so for example, if we had name 1, and then we had name 2 equal to Josh, we could copy formatted name and reassign it to name 2 over here. And if we printed it now, we get this person plus their info. And then if we printed this, we get, this is what we get. We would get name is John. And then actually we could probably just add a new line before this. Okay, so name is John. His age is 34. He lives at 1, 2, 3, 4, 5 street. And then name Josh, and then whatever info we have here. String repetition can also simplify code by reducing redundancy, because whenever you're coding, you don't want to type things more than once, because that means you can do something more efficiently. For example, we can set greeting equal to hello, and then we can print greeting times 3. And notice here, you don't have to put times 3 in the print statement. You can also put it over here. It doesn't matter which one. The reason you would put it in the print statement is if greeting was just equal to hello, and you could use greeting somewhere else, but right now we just want to print it times 3. And so when we save this, we get hello, hello, hello. This is also a shorter way of doing formatted greeting, and that's just equal to hello times 3. So that's just a shorter way of doing this, and it gives us the same output. Now I want you to set a variable equal to your name, and I want you to print your name 3 times using string repetition. We can do name is equal to Bob, and we can print name times 3. So Bob, Bob, Bob. And here's one more thing. If we wanted to add a new line in between this or any character, first we'll just do a space to show you. You'd have to surround this with parentheses, because with the order of operations, it multiplies first. But now that this is in parentheses, it adds name to a space. So now, if we did this, it would be Bob, 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 because it's multiplying this whole thing by 3. If we didn't, it would just print the space 3 times. So instead of this, if we wanted, we can do a new line. And now we get we open this up, we get Bob, Bob, Bob. And the last time we get a new line because they're all added with a new line over here, so there's one extra line. Hello everyone, in this video we'll explore the fundamental concept of conditional statements in Python. Let's begin by understanding what conditional statements are and how they help control the flow of our program. In programming, conditional statements are used to check if a condition is true or false and execute different code blocks accordingly. In Python, conditional statements are called if statements, which is the term we'll be using from now on. If statements are often associated with the term control flow. So if you ever hear that term, just remember that if statements control the flow of your program. In this video, we'll cover the syntax and structure of if statements to understand how they're written in Python. An if statement consists of the keyword if, followed by a condition, and then a colon. After the colon is indented code, known as the if block, and that is executed if the condition is true. In this video, we'll also explore the use of comparison operators, such as equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. In if statements, these can be used to check the status of different values. So for example, you can have two strings and they could be, is this one equal to this one? Or is it not equal to this one? Let's start with a basic example of an if statement. So we'll set age equal to 18, and under this we can write the if statement. Type if, all lowercase, and then a space. Here we can type the condition. Within this if statement, we want to check if the age is greater than or equal to 18. We type age because we're saying if age is greater than or equal to. So if age greater than sign, equal to sign. If it's greater than or equal to 18, and then we put a colon. Now we hit enter. Depending on your code editor, you might notice it indent. If it's not indented, just hit tab. Everything inside the if statement is indented. So if we didn't indent it, it wouldn't count the code as part of the if statement. This is because Python is very white space oriented. So here we can print, you are eligible to vote. So in this code, we set age equal to 18. The if statement is checking to see if the age is 18 or older with the greater than or equal to sign. If they meet the requirement, we print you are eligible to vote. If they're not, no code executes because there's nothing below this if statement. So if we run this, it says you are eligible to vote because age is 18. Now, we could put something below this if statement. This would be run no matter what. Whether age is 18 or not, this would still be run because this isn't part of the if statement. So if I ran this, it would say you are eligible to vote and hi. But if we changed age to 3, it'll just say hi. Because no matter what, this is still executed, but this is only executed if this is true. So what's going on under the hood here? When you type a condition, in our case it's the greater than or equal to 18, Python either evaluates it as true or false. Right now, since age is 3, Python evaluates this as false and doesn't execute this code. When we change this to 18, now Python evaluates this expression as true. When age meets the requirements, since it's true, it prints this, otherwise it's false and it doesn't print anything. So in simpler terms, if it evaluates to true, the code will run, and if it evaluates to false, it will not. Now it's time to learn about the else statement, which allows us to specify an alternate block of code to execute when the condition in the if statement is false. The else block is executed only if the if condition evaluates to false. Let's see an example. We can set age equal to 16, and we can have an if statement that checks if age is 18 or older. We used this exact same expression in our previous example. Now we can type else, and if you type any expression in else, you'll get an error because else is only for every other possible scenario. So you can't put an expression in else. Else is just everything else that could happen. So if it's not greater than or equal to 18, this will happen. So we can say you are not old enough to vote. First, the code checks to see if age is 18 or older. If it evaluates to false, then we don't run this. And now that there's an else here, when it evaluates to false, it prints you're not old enough to vote. So if we run this, it'll say you're not old enough to vote. If we change this to 34, it would say you're eligible to vote. And even if we said 5,000 here, it would still say you're eligible to vote. As long as it's greater than or equal to 18, this evaluates to true. Now we'll introduce the elif statement, which allows us to specify multiple conditions to check in a sequence. The elif block is executed if the preceding if statement is false, and this elif's condition is true. Let's see an example of an if elif else statement. We can set age equal to 21, and now we can say if age is less than 18, then we can print you are not old enough to vote. And now we can say elif age. Make sure you unindent this, because if you click enter, it's going to stay indented. Just undo that. And then do elif age is greater than or equal to 18, and age is less than 21. Print. So when they're greater than 18, but they're less than 21, they are old enough to vote, but they can't drink. So this is just based on the voting law and the drinking law. So here we go with you can vote, and then you cannot drink. Now else would be both of these. So if we copied this and just edited this here, you can just remove this, you can drink. So here it says if age is less than 18, you're not old enough to vote or drink. If it is greater than or equal to 18, and you learn about the and operator later in this video, but this is just making sure both of these are true, and age is less than 21, then they can vote, but they can't drink because it's less than 21, but also older than 18. And then else, which is everything else besides this. So we've covered everything all the way up to 20. So now, if it's 21 or older, you could have done elif age is greater than or equal to 21, but a lot of times it's better to just do else in our programs. So now it's safe to assume that their age is greater than 21 because we've covered everything else. So now, since age is 21, we're going to get the else statement printed out. Here we go. You might also notice that instead of saying age is greater than or equal to 18, we could just say age is greater than 17. In this case, both of these do exactly the same thing. When you run into things like this, it's just a matter of preference in code readability. For me, it's easier to just read greater than or equal to 18, because then, oh, where'd 17 come from? I thought the law was 18. Even though it is greater than 17, that still works, or greater than or equal to 18. Here's another example. We can set message equal to hello world. And now we can check if message, and then we can use the equal sign, and then say hi, for example. We can just do code here for a second, but first I want to tell you, make sure that when you're doing an if statement, the double equal sign is used, because that's different from assigning a variable. When you're creating a variable, you set equals with 1. But if you're checking if a variable equals something, or something equals something, right, you use 2, because otherwise it'll think you're trying to define a variable here, and it'll give you an error. So if message is hi, then we can print you said hi. And now we can say elif message equals hello world. Make sure you put the colons after these, by the way. Then we can say print you said hello world. So this checks if the message is equal to the string hi. And right now it's not, because it's hello world. And this elif statement checks if it's equal to hello world, which it is. So now we can add another elif, because you can add as many elifs as you want. So we can do elif message equals what's up, then print you said what's up. As you can see, the two equal signs checks if a value is equal to another value. This works with all data types, including strings, integers, floats, etc. This is unlike the greater than, equal to, and all those signs. You can't do greater than for a string, or greater than or equal to, that type of thing for a string. They only work with numbers, so think integers, floats, etc. The only two of these operators that you can use for strings is the equal to and not equal to sign. Let's change our statement to not equal hello world. If message is not equal to hello world, we can just say you're supposed to say hello world. And now if we say else, we don't need any elifs because we're just doing else. You said it. So here it's checking if it's not hello world. And now it's saying you're supposed to say hello world. And if it is hello world, because else, then it says you said it. This is the same as doing this. That's the same as doing this if statement. Although it's different code, in this case they're the same thing, but there are many uses for these, and they are very different. Now let's look at logical operators. In one of our examples, we use the AND operator. In this video, we'll learn about two of these logical operators, and OR. First, we're going to learn about the AND operator. Logical operators can be used inside if statements to check if more than one value is true. Let's create a variable called num, which holds the integer 12. Now we can create an if statement that checks if the number is greater than 8, but less than 11. We can use the AND operator to check this. If num is greater than 8, and num is less than 11, we can print your number is correct. So what this is doing is it's saying if number is between 11 and 8. So if it's greater than 8 and less than 11. The statement only evaluates the true if both of these are true. This makes sense because the word is and, which implies both. So that's one of the reasons why Python is so easy to read compared to other languages. In this code, no output will go to the console because num is 12, which is not greater than 8 and less than 11. It is greater than 8, but not less than 11. You can also include more variables. Let's add another variable called num2 and set that equal to 10. We can add another and after the 11 to make sure that num2 is equal to 10, and num2 is equal to 10. The statement will still evaluate to false though, because everything has to be true, and num is not less than 11, so it's not true. But we do have 3 expressions in here, and I just did that to show you. So if we ran this, we'd get no output because, like I said, this isn't true. Now we're going to learn about the OR operator. Let's set a variable called num and set it to 10. Now we can create an if statement that checks if num is equal to 8. If it's equal to 8, we can just print u passed. What if both 8 and 10 were correct? We could add an elif statement to do num is equal to 10 and then print u passed. But this uses more code space and is less efficient. Instead, we could type OR after the 8 and type num is equal to 10. So this is asking if num is 8 or it's 10. So as you can see, the operator makes the statement evaluate to true if one or more expressions are true. So if only one was true and the other was false, it would still work because it's called OR, so that's kind of implied there as well, just like AND. But note that OR just needs one to be true, but multiple can be true as well. With the and OR operators, you can make as many conditions as you want. For example, you can check if a message is equal to yes, no, or maybe by using 3 expressions like this. If message is yes, or message equals no, or message equals maybe. Now we can print just okay, for example, and then if it's not any of these, then we can say print sorry, didn't understand what you typed. Please type yes, no, or maybe. So pretend this was just, user's input, then they typed yes. It checks if it's yes or no or maybe. Right now it's going to say okay because the message is yes, and that is exactly the same as this string right here. But if it's not any of these, then it says I didn't understand, please type yes, no, or maybe. Now we'll explore nested if statements, which are if statements placed inside another if or else block. Nested if statements allow us to handle more complex conditions in decision making. Let's see an example. Age is 18, and is citizen is equal to true. Now we can check if age is greater than or equal to 18. Then we can print you are 18 or older. And then down here we can also check if is citizen is equal to true. Now we can print you are eligible to vote. And now we can say else inside here, print you can't vote. And now in going back to this if statement, we don't have an else for this, so we can add an else if we wanted to. Else print you are too young to vote. So this might look a little confusing, but remember, code goes from top to bottom. So first it checks if age is 18 or older, and then it prints you're 18 or older if that's true. Then only if age is greater than or equal to 18, then it checks if citizen is true because this is inside the if statement. So this is only run if age is 18 or older. If is citizen is true, then it prints you're eligible to vote, and if it's not, then it says you can't vote. And in here, this print, this will print as long as you're 18, no matter what, whether you are a citizen or not. So it prints if you're 18, whether you're a citizen or not, but only this prints if you are, and this prints if you're not. It says you are 18 or older, and you are eligible to vote. That is because they are 18, and this is true, and all this says checked out, and it's correct. If this seems too complicated, don't worry about it for now, because once you get familiar with normal if statements without nesting them, then nesting if statements inside if statements will make sense. Hello everyone, in this video we'll dive into the world of string methods in Python. Let's begin by understanding what string methods are. String methods are built-in functions that allow us to manipulate and transform strings in various ways. There's functions that can be applied directly to strings to perform specific actions or transformations. String methods are called by typing a dot and then the function. So for example, you can see that we have the string hello world, which is calling the dot upper function, which makes every letter in the string uppercase. First, we'll start with case transformation methods, which allow us to change the case of a string. The methods we'll cover include dot upper, dot lower, and dot capitalize. These methods will help us convert strings to uppercase, lowercase, or capitalize the first letter, respectively. Let's see an example that demonstrates the usage of case transformation methods. So we can set message equal to hello world. And I didn't capitalize H for a reason. It's just so that I could show you all of the methods correctly, because otherwise you won't really notice anything if it was capitalized. So we could set uppercase equal to message dot upper. We could set lowercase to message dot lower, and then we can set capitalize to message dot capitalized. So when you're calling these functions, you put a dot and then the name of the function followed by an opening and then a closing parenthesis. For dot upper, you just do dot upper, and then the same goes for all three of these ones. So this variable is equal to hello world in all caps. Lowercase is equal to this string, but all lowercase. So as you notice, W is uppercase, but it will not be. Capitalized makes sure that the first letter is uppercase and that everything else is lowercase. So H would be capital and everything else would be lower, including the W that's already capitalized. So capitalized only does the first letter in the entire string. So if we printed each one of these, we could print message, and then we can also print uppercase, and then we can also print lowercase, and then we can also print capitalized. So now when we run this, you can see that we get the original string, which is message. Then we get hello world in all caps, which is uppercase. As you notice, it only changes the letters to all caps. It doesn't really do anything with these symbols, since they're not letters. You can't just capitalize them. The lowercase, as you can see, it lowers every single letter. And then capitalize makes the first letter capitalized and nothing else. Now let's use this in a more real-world example. Let's say we prompted the user to answer with either yes or no, and they said yes with a capital Y. And we wanted to check which one they typed. They could have typed, the answer as yes, or they could have typed it as yes, or they could have typed it as yes or yes with, any range of capitalization. There's no way of knowing which one they're going to type, and there's a lot of possibilities, and we don't want to type every single one. So if we set an if statement that was if answer equals yes, or answer equals yes, or answer equals yes, every possible thing, that's not a good idea. Instead, what we could do in our if statement is do answer dot lower is equal to yes, and this would evaluate to true. So now, if we save this and run it, you can see that it says you said yes, because yes, lowercase, is equal to yes. So instead of having to do or for every possibility, we just do dot lower. Note that applying this dot lower does not actually change the value of the variable. So if we printed this, after we did that, it would still be capitalized. We didn't actually change the variable. If you wanted to change the variable, you could just do dot lower here, and that would change the actual variable because answer is set equal to it. Or later in the program, you can say answer equals answer dot lower, and this would change the value to the lowercase version of answer. Let's see an example that demonstrates the usage of string validation methods. We're going to be doing two of these in this video. We're going to be doing isNumeric and isAlpha. These methods help us determine if a string consists of only numeric characters or only alphabetic characters. So here's an example. We can set age equal to the string 25 and name equal to John Doe. Notice I'm not doing a space in here, and there's a reason for that. And then we can say is age numeric equals age.isNumeric, and then is name alpha equals name.isAlpha. So isNumeric and isAlpha don't return any string manipulation. They actually return a Boolean value. So if you remember, Booleans are true or false, and these can be used in if statements. So if we were to say something like if is age numeric is equal to true, then we can do something. But also, since this just returns true as well, you could just say if is age numeric, because it's already a Boolean, so you don't need to say equals true or anything like that. This is a Boolean returning function. So without doing this for now, we can just print is age numeric and then is age alpha. And here we say true and true, because is age numeric checks if the string can be easily converted into an integer. If we had letters in here, it would return false, because you can't convert this into an integer. Is alpha is returning true because John Doe is all alphabetical characters. And if we put a space in here, it would return false, because a space is not an alphabetical character. So watch out for that. A real-world example that I would use this in is if I wanted to easily check if a string could easily be converted into an integer, so that I wouldn't have to deal with errors and stuff like that. Because if someone entered their age and they entered in a letter by accident, I could check if age.isNumeric is true, or just not have the is true part, because it's the same thing, and we don't need these variables anymore. So if it's numeric, continue with program, and then if I did else, meaning it's not numeric, we could just do something like, whatever the code is for re-prompt them. So if you're not familiar with pass, by the way, this is just a way to not type anything in an if statement. So over here we can just continue, and over here we can re-prompt them if it's not numeric, because we want to evaluate their answer as an integer and not a string. Now let's explore whitespace manipulation methods, which allow us to move leading and trailing whitespace from a string. The methods we'll cover include strip, lstrip, and rstrip. These methods help us remove any unwanted whitespace characters. Let's see an example of how whitespace manipulation methods are used. So here we could say text is equal to Python for beginners with a bunch of spaces at the front and back. Now we could say trimmed text is equal to text.strip. And so what this is doing is it's setting a new variable equal to text without the front and back spacings. So if we printed trim text, we would get Python for beginners with no spaces at the ends. Now what we could do is we could remove the back of it only, which would be rstrip, because it's the right side of the string. So if we ran this now, we would get this with no space, and then you can't see the spaces in here because it's just a terminal window, but you get the point. And then lstrip does the exact same thing, but removes it from the front, and so theoretically there are some more spaces in here, but you can't really see them because this is just a terminal window, but there are spaces here that Python has evaluated. So now, what this is doing is it's simply just removing unnecessary white space, and it only removes it from the front and back. And normal strip also just removes it from the front and back. It doesn't remove any in between at all, so you don't have to worry about that. What this could be useful for is if a user has inputted something and they just typed a space or something, and you just wanted to make sure that it was evaluated correctly. Now, just like before, doing something like this, like printing text and then dot strip, will not change the value of text. It just prints the version of text with dot strip applied to it. So you're not actually changing the variable. If you wanted, you could apply dot strip here, and it would remove these white spaces, and it would actually be applied here. And if dot strip has nothing to do over here, you won't get an error. It just won't do anything because it has nothing to do. So don't worry about using any of these methods without any need to, because you can still use them and be redundant with them if you have to for whatever reason. But this does not change the value. Only doing this changes the value. Or setting text equal to text dot strip, which also would do the same thing because you're reassigning text to the strip version of text. So if that sounds a little confusing, it's just how Python works. The string methods don't actually change any values, they just return the values. Lastly, we'll explore the replace method, which allows us to replace specific portions of a string with new values. This helps us modify strings by replacing occurrences of a substring with a different value. So if we had a sentence, and it was equal to Python is awesome, and we had modified sentence, and it was equal to sentence, see, we're setting a new variable equal to this variable, but modified with the dot replace. And in these parentheses, this is the first time we're typing something in the parentheses in this video. In these parentheses, we have to give this two arguments. In Python, arguments are separated by commas, so we can say argument 1 is separated by the comma, and then argument 2. And obviously, arguments don't have to be strings. I don't know why I typed them like that. You can set variables, whatever, but they're separated by commas. And so in this dot replace over here, we can replace awesome with amazing. So here we have modified sentence is equal to sentence dot replace, and the first argument is what we're replacing, and then the second one is what we're replacing it with. So it makes sense. Awesome is being replaced with amazing, and like I said, these don't have to be strings. So if you had a variable called new substring, and a substring is just part of a string, by the way, and you can say amazing, you could just set this to new substring, and it would work the same way. And so modified sentence is equal to this, and just like before, dot replace does not change anything with sentence. If you ran sentence dot replace on this, right? If we replaced Python with something like Java, for example, it wouldn't actually change the value of it. When we printed sentence here, it would just simply type Python is awesome, because we've never actually changed this value before. So here we can just print modified sentence, and here we get Python is amazing, because we replaced awesome with amazing. And if you didn't have this substring, so if we just type something random here and we ran it, it just wouldn't change anything. So this is useful because you're not going to get an error. If you're worried about getting errors, do not worry, because this, if it can't find anything to replace, it just won't do it. So we could just replace the exclamation mark with a period, for example, so we can say Python is awesome with a dot instead. And so I know I've been going a lot into saying how this doesn't actually change the value, right? If we just ran sentence dot replace and then just replaced awesome with amazing, I just want you to know this, because you might eventually run into this problem and be thinking, why isn't it working? Why isn't it working? You just have to set, if you're trying to change the variable's value, you have to set the variable to this, not just run the function here. So if we did sentence equals sentence dot replace, then it would change the value. But over here, if we just printed sentence again, it wouldn't change it. Python is awesome, and Python is awesome, and this did nothing, except Python read it, but it did nothing in functionality. Hello everyone, in this video we'll be diving into while loops in Python. Before understanding what while loops are in computer science, you need to know what loops are. Loops are a fundamental concept in programming that allow us to execute a block of code repeatedly. In Python, we have different types of loops, and one of the most commonly used ones is the while loop. Loops are also a form of control flow. So now let's talk about while loops. The while loop allows us to repeat a block of code as long as a certain condition is true. While loops are particularly useful when we want to iterate over a set of instructions until a specific condition is met. They provide flexibility and control over the flow of our program. Before we explore examples, let's understand the basic syntax of a while loop. It consists of a condition and an indented block of code. The condition is evaluated before each iteration, or movement through the loop, and if it's true, the code block is executed. After each iteration, the condition is evaluated again, and the loop continues until the condition becomes false. Let's start with a simple example to illustrate the usage of a while loop. Suppose we want to count from 1 to 5 and print each number. We can achieve this using a while loop as follows. We can set count equal to 1, and we can say while count is less than or equal to 5. Then we can print count, so we'll print the number, and then we will add 1 to the count. And if you remember, plus equals is the same as doing count equals count plus 1. It's just a shorter way of doing that. Remember, plus equals just adds 1 to an integer. So in this, we set count to 1, and then while count is less than or equal to 5, we will print count, and then we'll increment it by 1 until, and obviously until it's greater than 5. So let's run this. And as you can see, we get 1, 2, 3, 4, 5. Here's another example of a while loop. We can set count equal to 0, and we'll say is loop done is equal to false. And then we can say while is loop done is equal to false. Then we will increment count by 1, and then we will print count. And then down here, we will do if the count is greater than or equal to 5, we will set is loop done to true. So this might look a little bit complicated, but just bear with me. So we set count to 0, we set this boolean to false, so it is the loop done, it's not done yet, it'll be done down here, but so while it's not done though, while it's false, we'll add 1 to count each time, then we'll print it, and then in this while loop it checks to see if count is greater than or equal to 5, and then if it is, it sets this to true. So this is a little bit more complicated form of the previous example, but the previous example used the count variable in the actual while loop, and you don't have to do that. So if we save this and ran it, we would get 1, 2, 3, 4, 5. You may notice that in these while loops, we always have something that will break the loop, like the count variable, which I've used for these simple demonstrations. If you don't have something that'll eventually stop the loop, it'll go on forever until we stop the program. So if we remove this if statement over here, it would just keep going on until someone stopped the program. So let's see this in action. The number keeps going up over and over and over until we stop it with Control-C. While loops can also be terminated before the condition becomes false, using the break statement. To use the break statement, let's create an infinite loop. There are many ways to do this, but the most common one is to type while true. The while true will go on forever because if you remember, typing a boolean in a condition, so this is just a variable, so we can name this whatever we want, var. So typing a boolean in a condition is the same as typing the boolean equals true. It's just a simpler way to type it. This also applies for while loops, and so in the while true loop, we're essentially saying while true equals true. And true will always equal true, so it'll go on forever. You could also do this by putting 2 equal strings like hi and hi, because this will go on forever as well, because hi will always equal hi. But it's a lot more conventional to say while true, because everyone knows that while true is an infinite loop. So in this infinite loop, we will need a way to stop it. Let's create a count variable above the while loop. Now after every iteration of this infinite loop, we can make the count get higher and then print it. Now we can check to see if the count is greater than or equal to 5. And if it is greater than or equal to 5, we can just break. So just type break. And so you might notice that you could just say if count is equal to 5, but in loops it's just more conventional to do this, greater than or equal to. And so what this is doing is we're iterating through this loop. Every time it increments count by 1 and then prints it. And then if the count is 5 or greater, then we will break out of this loop and we'll stop it. If we didn't have this break, it would just go on forever. It would keep adding and adding and adding and adding. So this infinite loop isn't an infinite loop once we have this break statement here. So to sum it all up, we just used a while loop with the condition true, creating an infinite loop, and inside it, we make the count get higher by 1, and then if it is, then we stop. Now let's talk about continue statements. Continue statements let us skip the rest of the loop and start back from the beginning. I'm going to show you with our previous example. As you can see, when we run this, it prints 1, 2, 3, 4, 5. What if we wanted to still count all the numbers correctly, but not show the number 3 to the user by printing it? So we want to count everything correctly, but just not print number 3. Well, we could use a continue statement. Let's create an if statement that checks to see if the count is equal to 3, and then it continues. Above print, we will say if count is equal to 3, then we'll type continue. And this is pretty simple because it adds 1 to count every time, and then if it's 3, it continues. And so what continue does, like I said, is it just skips all this and just goes right back to the beginning of the loop. So continue, after continue, it goes back to the beginning, checks if the condition is true, and then it does everything else. And then in here, if it's not 3, it won't continue. It'll just print it and then go through here. So this will print 1, 2, 4, 5, like this, because it just skipped everything else once it was 3. Hello everyone, in this video we'll learn about lists in Python. Let's begin by understanding what lists are. Lists are a versatile and fundamental data structure in Python. A list is an ordered collection of elements, and each element can be of any data type. Lists are represented using square brackets and elements separated by commas. Lists can contain integers, floats, strings, and even other lists, pretty much every data type. Now let's learn how to create lists in Python. To create a list, simply assign a variable to a sequence of elements using the square brackets. Our first list will be called numbers, and it'll contain integers, going from 1 to 5. When you're writing lists, as long as they're separated by commas, you should be fine. So you could even write your lists like this without spaces, but I prefer to have spaces just for readability purposes. Our second list will be called fruits, and it'll contain some fruits. We'll start with apple, and then banana, and then orange, and then grape. So as you can see here, the first list contains numbers, and the second list contains strings. Note how these are each individual strings, and I'm not just assigning one giant string with commas inside it. Make sure you actually have a bunch of strings. If we printed our numbers variable, you can see that it prints out our list just like this. That's pretty much exactly how we wrote our list. If we printed out our fruits list instead, we would get the exact list. So in the next section, we're going to learn how to pick out specific items in the list. Once you have a list, you can access its elements using indexing. Indexing in Python starts from 0, so the first element has an index of 0, the second element has an index of 1, and so on. If you're new to computer science, this might be tricky for you at first, but just remember that the first item in the list has an index of 0, and it goes on. So in this example, we can start printing our specific items in the list instead of an entire list. So let's say we wanted to get the first item in our numbers list, where we would print numbers, and then in square brackets, 0. So over here, let me just take this out of our print statement so I can show it to you here. When we're referencing an index, you are not doing an equal sign or assigning anything, because this is assigning it to a list containing the integer 0. You put it right up against the name of the list, and that's where your square brackets go. So square brackets in Python aren't only used for lists, they're also used for referencing indexes of lists, so make sure that you're careful with this. And so number 0, we can actually just print this by putting it in our print statement. And so this will print the first item in our list, so it'll print 1. Now if we wanted, we could print numbers and then a different index, so we could put 2 here. So this would print out 3, since it's the third item in the list. The third item has index 2. Lastly, we could just print something from fruits. So over here we will just do 3. So it will print grape because it's the third one. So 0, 1, 2, 3. So when we print this, it says 1, 3, and grape. Now that you know how to access certain items in the list, it's time for you to know how to replace items in the list with other values. With our example, we can change items in the list. Let's delete the last 2 print statements. So let's say we wanted to change the second item in our numbers list to be 6 instead of 2. Well, we could do that simply by referencing the item by its index. If you remember, the second item in the list is actually index 1. So here we will set numbers, and then we'll say square brackets, and then we'll type 1. So we're referencing the index 1. And then we'll just say the first index now equals 6. And so if we printed this after it, what this would do is it'll print numbers. So it'll print 1, 2, 3, 4, 5. And then after we assigned a new value to 2, which is now 6, it'll print it again. So now it'll say 1, 6, 3, 4, 5. And so when we save it and run it, we get 1, 2, 3, 4, 5. After we changed it, now it says 1, 6, 3, 4, 5. Note that with this method of changing items, if you try to change an item that doesn't exist, so for example, index 9, you'll get an error because it has to be an item in the list. If you want to learn how to add items to the list, you'll learn that in one of the next sections. Python allows you to extract a sublist from a list using slicing. Slicing is done using the colon operator, and it returns a new list with the specified elements. In Python, slicing is just getting a section of a list. So for this example, I'm just going to add another one over here. It's just going to be strawberry. I just need a little bit more items in the list so I could show you this example. So let's say we wanted to slice fruits into a new sublist. So we can create any variable name. I'm just going to call it sublist, and we'll set it to fruits, but items 1 through 4. So we're referencing with indexes, but we're putting this colon here, which is actually saying we're going to go from 1 all the way up to, but not including 4. So this will return 3 items. It'll return banana, orange, and grape. But it won't return strawberry, even though it has 4. This is the 4th index. It goes up to, but doesn't include this one. It does include 1, but it doesn't include 4. If we printed fruits and then printed sublist, we would get 2 different results. We would get the full list that we just have over here, and then we would get sublist, which is banana, orange, and grape, which is the 3 items that we referenced over here. If we decided to change the values of fruits 1 through 4, we could do just that. So with this, we could actually just say fruits 1 to 4 is equal to, and then a new set of items like pineapple, watermelon, and then lemon. And now if we printed fruits, we would get something different. Instead of it being apple, banana, orange, grape, strawberry, now it's apple, pineapple, watermelon, lemon, strawberry, because we changed these 3 items with these 3 items. You could also replace 3 items with 1 item. So instead, we could just change this to pineapple, and it would shorten our list, but you can replace items with a different number of items, and you can also do this with more items. So pineapple, watermelon, lemon, and then we could also just do blueberry, and it would actually add more items to the list. And that's fine too, because it doesn't matter how many items you're replacing it with or replacing. Now it's time to learn how to get the last element in a list, because if you remember, we did do indexes, but I didn't show you how to reference the last item in the list. We could just print the last item in the list by doing print, and then fruits index -1. And so we wouldn't do 0 because that's the first one. We wouldn't do 1 because it's the second one, but -1 is the last item. and the second to last item would be -2, and so on. So we printed -1, it would get the last item in the list, which is strawberry. Similarly, you could also get a sublist of the last 2 items in the list by typing -2 and then a colon. So unlike before, when we had 2 numbers separated by a colon, this time we only have 1 on the left side of the colon and nothing on the right side. This is because when you don't put a number there, it just signifies onward, as in, I want to reference index -2 and onward, which will give us the last 2 items in the list, because it's -2 and then everything else. And so as you can see, we get grape and strawberry. Lists in Python come with several built-in methods that allow us to modify, add, and remove elements. Let's explore some of the most commonly used list methods. The len function returns the number of elements in a list. So let's remove our numbers list and our print statement here. And now we can use our len function to find the length of our list. So if we did length, we set a new variable equal to length, and we do len fruits. So this is setting length to the length of fruits, which is a list. So the len function will return how many items are in the list. Simple as that. And so if we printed length, we would get 5, because there's 5 items in the list. The append method adds an element to the end of the list. So we could just append an item by doing fruits.append, and then we could just append another grape. And if we now printed fruits, we would get this whole list, but then with grape at the end of it, because we have actually changed the list by adding 1 item to the end. The remove method removes the first occurrence of a specified element from the list. So if we had our new list, we could actually just add one over here called grape if we wanted to. And now we can just use fruits.remove grape. And so this will not remove both instances of grape. It'll only remove the first one. So we're going to get apple, banana, orange, strawberry, and grape. Not this one, because we removed this one. So when we print this, we get what I just said. This whole list without grape in the middle. The insert method inserts an element at a specific index in the list. So over here we could just do fruits.insert, and then we specify the index that we want. So if we wanted to insert it right in between apple and banana, we would insert it at index 1, and then for the second argument of this function, we would just put what we wanted to insert. So we could insert grape in between here. If we print this, we would get apple, grape, banana, orange, grape, strawberry, grape, because we inserted another grape in between apple and banana. The pop method removes the element at a specific index. So over here, if we just did fruits.pop 1, and then printed fruits, we would remove banana. So if we ran this, we would just not see banana anymore because we removed it. We get apple, orange, grape, strawberry, grape instead of apple, banana, orange, grape, strawberry, grape. And by default, pop just removes the last item. So if you don't put an argument here, it will just remove the last item, which is grape, so we don't get that anymore. The clear method removes all elements from a list, making it empty. So over here we have fruits, and we could say fruits.clear, and then print fruits, and we would just get an empty list, which is just 2 brackets like that. And if you ever want to create an empty list, by the way, just create your variable name, and then just put these 2 brackets here like that. And that's useful for when you want to just use the append function later in your program and append items to your list based on what happens in your program. The count method returns the number of occurrences from a specified element in a list. So if we wanted to create a new variable called count and then grape, we would set this to fruits.count, and then we'll count the amount of times grape is in our list. And this would return 2. So if we printed this, we would get 2, because there are 2 grapes in our list. If we removed one of them, it would return 1 instead, because there's 1 grape in our list now. The reverse method reverses the order of the elements in the list. So over here, if we did fruits.reverse, and then we printed fruits, we would just get strawberry, grape, and so on, because it would just reverse it. So there we go, we have just reversed everything in the list. The sort method sorts the elements of a list in ascending order. So if we had, I think this would be easier to explain with numbers. So if we had a list called numbers, and we set this equal to 3, 1, 4, 2, and 5, we could now just sort this list by doing numbers dot sort, and then printing numbers, and we would get 1, 2, 3, 4, 5, because it has sorted the list in ascending order. Lists can be concatenated using the plus operator to create a new list with elements from both lists, just like you do with string concatenation. We can set two lists, list 1, and we can set that equal to 1, 2, 3, and we can have list 2 equal to 4, 5, 6. We can have a new list called combined list, and have that equal to list 1 plus list 2. And this would give us both of those lists combined. So if we now printed this, we would get 1, 2, 3, 4, 5, 6, because it added them together with this plus operator. Welcome back, everyone. In this video, we'll dive deeper into list slicing in Python. We'll explore more advanced techniques and use cases for slicing lists effectively. Before we dive into advanced list slicing, let's do a quick recap of basic list slicing covered in our previous video. Basic list slicing allows us to extract a sublist from a list by specifying start and end indices. Here's an example of basic list slicing. We could set fruits equal to banana, apple, strawberry, pineapple, and grape. Now down here, we can say sublist is equal to fruits 1 up to 4. And if we print sublist, we will get apple, strawberry, and pineapple. This is because we're starting at index 1. So remember, the first item in the list is index 0. So we start at index 1, which is apple, and then we go up to, but not including 4, which is the 5th item. So grape. So we only get apple, strawberry, and pineapple because it doesn't include 4. It includes 1, but not 4. So now let's explore more advanced list slicing techniques that can make your code more concise and efficient. By adding a third parameter called the step, we can control the spacing between the selected elements. To do so, we add another colon. So I have this list over here with 10 different fruits in it. By the way, if you ever are in a list, you can actually create a new line if it goes off of the page, so you don't have to scroll. Just after a comma, just enter, and then you'll be able to have it on multiple lines. Python will read it the same way. But anyway, we can set sublist equal to fruits. Start at 1, stop before 9, and now we add a second colon and type our step, so we're going to do 2. So when we print sublist, you get apple, pineapple, watermelon, and raspberry. This is because we go from 1, which is apple. We stop before getting to 9, which is the last one. So right now we've got all these. But now we go by a step of 2, which means that we get every other one. So we get this, we get this, we get this, and this. And the reason we don't get this one, like I said, is simply because of the fact that we stop before getting to 9. If we had this empty over here, it would be 1 onward, like I showed you in the previous video, and then it would go by a step of 2. So that would include peach. But we have a 9, so it stops before getting to it. So that's why we get this. Did you know that you can use negative indices for list slicing? This is another way to reverse a list. The other way was shown in the previous video, where we used the .reverse method. Negative indices count from the end of the list, allowing us to perform reversed slicing. So here's an example of reversed list slicing. So we could set sublist equal to fruits, and then 2 colons, and then a -1. So this is essentially saying, well, we don't want to specify a start or end, so remember doing this would just be the entire list, because we're not specifying a start or end. So we don't want to specify a start or end, which means we want everything, and then we go by a step of -1. If we didn't want to go by a step, we would just not type a step here. That's because the default step is just 1. But if we want to specify it, we just add another colon and do -1. You would not do this. This would be completely different. You just do 2 colons and -1 to reverse the list. And so if we were to print sublist, we get everything reversed. So you see how it starts with peach at the end, and it goes reversed, so that's the reversed list. List slicing can also be used to create a copy of a list. Let's explore the difference between assigning a variable to a list variable and assigning a variable to a copied list. So here's what I mean by that. So let's just, I only have 5 here, because we don't need all these ones for this example. And so in here, we could do a full list slicing. So to copy the list with slicing, we could just do copy 1. And this is the first copy, which we'll do fruits, and then referencing all indices, we could just print copy 1. And as you might expect, it's everything in the list because we just copied it with every one of these. Now we can set copy 2 just equal to fruits. And as you remember, if we had a variable equal to a string, and then we set var2 equal to var, it would equal string, right? Well, over here, we're doing that same type of thing. We're not referencing any index. We're just setting it equal to this list. And this is creating, these two are completely different. This one is copying the items in the list, and this one is creating a reference. And you'll see what I mean after I show you this example. So, as you can see, we're printing copy 1 and copy 2. And so that looks completely fine. They're both exactly the same. But now, if we were to change fruits, the first item, and we set this one equal to a watermelon, now this would just be watermelon. That's what it would be once we change that one. So once we set this, and now we can print the original list, and then we can print copy 1, and then copy 2. And these will be different. So, after we print this, I'm just going to put another print statement to separate them. Okay, so before we edited the first item, they were the same. Copy 1 was this, and this was copy 2. Now, after we edited it, obviously, this is the original list. The original list was changed. Copy 1 was not changed, and copy 2 was changed. This is because in copy 1, we copied all of the items just in place. We just took all the indices and copied them into here. But with copy 2, we actually created a reference. So when we edit the original list, the reference also gets edited as well, because it's just referencing back to this original list here. So if you want the kind of behavior where you want to copy every item in a list, and if you change the original one, it doesn't get edited, do what I have here. But if you want a reference that changes along with it, then copy this one. It all depends on what you're doing. Hello everyone. Today I'm going to teach you about string slicing. String slicing is a powerful technique that allows us to extract substrings from a string. A substring is just a smaller part or section of a string. String slicing enables us to extract specific substrings of a string based on their positions, providing us with more control over text manipulation. Before we explore string slicing, let's do a quick recap of indexing. So in Python, each character in a string is associated with an index, starting from 0 for the first character, 1 for the second, and so on. You might remember this from previous videos where we referenced list items by an index. Well, this can also be applied to strings as well. So meanwhile, over here, when we had our list, and the first item in the list was 0, second was 1, third was 2, the exact same thing applies for strings, except it's just for each character. Here's an example of string indexing. We can set message equal to hello Python, and we can print message and then the first character in that with index 0. And for example, we can also print message and then the 7th index. And so the output will be H and P because 0 is the first one, and then P is the 7th because we've got 0, 1, 2, 3, 4, 5, 6, 7. And so when we run this to prove this, we get H and P. Now that we've refreshed our memory on indexing, let's move on to string slicing. String slicing uses the same syntax as list slicing. It's string, and then in the brackets you've got the start point and the end point. This just extracts a substring from the original string. Just like with lists, you'd get a sublist. Here's an example of basic string slicing. We still have our string here, and we can set a new variable called substring, and that can be equal to message of 0 up to but not including 5. So remember, from list slicing, it starts with where you want to start, and then the endpoint does not include the endpoint. So it's going from 0 through 4, not 5. It just goes up to 5. And so if we print substring, we will get hello, because we've got 0, 1, 2, 3, 4, and then not including this fifth character. We can also use negative indices to slice strings from the end. Negative indices count from the end of the string, with -1 representing the last character, -2 for the second to last character, and so on. Here's an example of using negative indices in string slicing. We still have our message, hello Python, and now we can create a new string and set it to message -7 to -1. This basically references the 7th to last character up to but not including the last character. Lastly, we can create a new substring and set it to message colon and -9. And so remember, when you don't have a number on one side of the colon, it signifies onward or everything else. So in this case, we're setting it to everything up to -9. And so now we can just print these two. And as you can see, we get Python and hello. This is because the first substring we have, we start at -7. So we get -1, -2, -3, -4, -5, -6, and -7. So we start at -7, we go all the way up, but not including -1. And then for message, we get everything from the beginning, all the way up to, but not including, -9. And so this was just done with negative indexing. So we've got -1, 2, 3, 4, 5, 6, 7, 8, and then -9. So we're just not including this. So that's what this does. This actually is the exact same thing as doing this. Because in this example, we're just using positive indexing, and in this example, we're using negative indexing. So it really just depends on what you're doing. String slicing can also include the step parameter, which we learned in the list slicing video, and as you remember, this allows us to skip characters when we're extracting the substrings. So here's an example of this. Like before, we still have this variable, and we can set substring equal to message and then ::2. And so, as you remember, we're not putting anything in these, so we're just signifying everything, so the entire string, but we're going by a step of 2. So this would just print every other character. And as you can see, we get every other character because we've got this one, and then skip this one, get to this one, skip this one, we get the space, and In this example, we just used a step of 2 to skip every second character, creating a new string, HLOYHN, from the original string. This is every other character in the string since we use a step of 2. So a step of 3 would give us HLTN, HL space TN, just like that. And we could also just put numbers in the other parameter spots. So if we just change this back to 2, we could also do 1 and 12. And you know this from list slicing. And then we get EL:PTO. This just starts at index 1, which is E. It stops before index 12, and it goes by a step of 2. String slicing finds its application in various tasks, including data cleaning, parsing, and text analysis. Here's another example. We can have a sentence variable, and that's equal to Python is awesome. And now we can set word1 equal to sentence, and then everything up to 6. We can set word2 equal to sentence, and then 7 up to 9, word3 is equal to sentence 10 onward. And so when we print all of these, we get Python is awesome, and we've just extracted each individual word with our indices. Hey everyone, in this section, we're going to be talking about receiving user input. In Python, we use the input function to get input from the user in the terminal. The syntax for creating an input is you're most likely going to want to store it into a variable, so we'll do variable is equal to input, and then inside the parentheses is what the user will see right before they input. And don't worry, I'll go over some examples. So input actually just returns a string, and it's the string that the user types. So they can type anything in there, and we will get what they typed. Okay, so let's do an example. We can just type input first and see what that does. So it looks like our program is just like really slow or loading or something, but it's actually waiting for our input. So if we click down here, we can actually start typing stuff. Like say hello world and click enter. Now it didn't do anything with it because we didn't store in a variable or do anything with a variable. So we can actually just set this to something like answer equals input. But still, it's not going to do anything because we haven't done anything with answers. So if you wanted, we can just say you typed and then plus answer. This will just say you typed and then whatever they typed. So if we run this, we can say hi, you typed hi. If we run it again, hello, you typed hello. And now it's time to see what would happen if we type something inside here. So we could say enter something, and with a colon, so they know to type. And now it says hi, and it says you typed hi. And a lot of times it's a good idea to put a space right at the end of the string for input, because as you notice, it doesn't look that good right here. So if we put a space, now it looks like they're actually typing in an input field that just looks a little bit better. Okay, so that's the basic example of input. Now let's do a program that calculates the year someone was born in. We could say age is equal to input, enter your age. And now we can say year equal to, you'll do whatever year it is, but right now it's 2023, minus age. And down here we can just say, you were born in year, space, plus year. And then we'll do a period. So what this should do is it should say enter your age, and then right here is where the user will type, so maybe 25. And then it does some calculations. The user doesn't see those calculations, they're in the background. And then it says you were born in year 1998, because 2023 minus 25 is 1998. And this is what it should do, but it doesn't. We get an error. So as you can see, the error we get once we enter our age, let's say 25, is a type error. This is because it says line 2, so we can go look at line 2. Unsupported operand type for subtraction, int and str. What this is saying is you can't subtract ints and strs or strs and ints. They are not really compatible. So the reason for this is because input actually returns a string, and we're trying to subtract 2023 from a string. This is not ideal. So what we could do is we can just use the int function. This converts a string to an integer. If we do age is equal to int age, this is setting age equal to the integer version of age. Now note how we're not just doing this, because this doesn't actually change the value of age. This changes the value of age. And so now you might think it works, but it still doesn't. Let me show you. 25, it says you can only concatenate str, not int to str. And it's a different line now though. We did fix that previous error. But the reason for this is because year is an integer. And you might think that's good, right? But we can't concatenate strings to integers. So we can just use the str function to convert an integer to a string. And this time we're not actually changing the value of year. We're just using the string version of year for this print statement. And so now this should work perfectly. 25, and it says you were born in year 1998. But now we have the problem of what if the user enters something like just random letters. Now we get an error, the program crashes because this is not a number, so it can't possibly convert age to an integer. It just doesn't work. So for now, what we could do is before we do this, we can say if age.is numeric. If you remember this, this function checks to see if a string contains only numbers, meaning can age be converted to an integer. We can just do equals equals true, or we don't even have to do true, because if you remember in an if statement, this is the same thing as doing this. It's just implied. And so here we can just indent this. And so if age is numeric, then we convert it to an integer. And if it's not, so we'll do else, then we can say print you entered letters instead of numbers. Try again. And this actually will not work as much as you might expect. Because if we enter our age of letters, then it says it, still says it, right? But then we get that error. That's because after this entire if statement, then it continues on with the program. So we can, in Python, we can exit our programs easily by typing the exit function. And there we go. So this should work. You entered letters instead of numbers, try again. Try again, and now enter something correctly, and it works. But you might notice that this is kind of inefficient, because I think it's better to prompt the user again instead of make them rerun the whole program. Because if there's this big program with a lot of questions going on, it would not be very helpful to the user if it kept just quitting on them every single time they entered something wrong. So we can just comment out this if statement. If you're not familiar with commenting code, in Python it's any line that you put a hash in front of is skipped by Python. So you can even write notes like I used this code but not anymore, just anything random so that you remember in the future, or for people looking on your code can see what you're doing. Python will just skip over this for now. And now we can make a while loop, because you'll notice that down here you can prompt them again, age equals input, enter your age, but then if they enter this one wrong, then you'll have to check all of this again, and that would be a nested if statement, right? But then if this didn't work, oh, well, then why not just type this again, right? But we're not nesting if statements over and over forever. That just doesn't work, because you don't know how many times the user is going to enter something wrong. So we can use the while loop. So we'll go over here and we'll do while age.isNumeric is equal to false. So what this is saying is while, so it'll keep doing the while loop until age is numeric. So now we can say age equals input, enter your age. But this time we can actually say you entered letters. Enter your age in numbers. And this is because if age is numeric, it won't run this while loop at all. It will just skip over it because it doesn't need to, because it's not false. So if the first time it says enter your age, if they enter something wrong, then it goes in here and it says you entered letters. When this while loop is done, then we can actually get this this function over here. We just delete that code, and we can just have this here. So what this is doing is, first we are setting age equal to input, and then if it's not able to convert to an integer, then it prompts you again until it's able to. So it'll keep repeating this until it is numeric, because each time we're setting it to input again. Once it is numeric, then we're done with the while loop, so we go down here and convert age to an integer, and then we do our calculation, and then we print it. And so this should be pretty error-proof. So if we run this, we can say enter your age, a bunch of letters. You can keep doing this forever until eventually you type a number, and it says you were born in 1998. But what if the user just, for example, I'm just giving a bunch of other examples because this is just going to show to you that when you're programming, there are a lot of places for errors. So it's really hard to think of all of them. But what makes great programmers is the fact that they're able to think of them all. So what if the user puts a space before it or even after it, right? Then it says you entered letters. And they're like, what? I entered numbers, what are you talking about? They entered a space, and that's not numeric. So over here, we can just dot strip. If you remember, it removes white space from the beginning and end of the string. It's saying age is equal to input, so the string that they enter, and then we are just removing all of the white space with the dot strip after that. And make sure you add it to the other function as well, because we're doing it both times. We're doing it for this one and for the error one. So we ran this now, and it says we just put a bunch of spaces, 25, and now it works. And so this is pretty error-proof. You might find some other things. For example, the year 2023 will change. And most programs don't just have the year in there, because then the programmers will have to go in every single year and change all the times that says 2023. So there are ways to calculate the year, modules, and stuff like that that we'll learn in the future. But this is just a quick example of input, which just simply gets input from the user. Hello everyone, in this video we'll continue our exploration of string methods and dive into more advanced techniques for manipulating and transforming strings in Python. This video will have a bigger focus on string methods that have to do with lists, but we will learn another useful method at the end, which will go along nicely with the .replace method we learned before. Let's start by introducing the .split method, a versatile tool for splitting a string into a list of substrings based on a specified delimiter. By using .split, you can separate words, phrases, or any other elements in a string based on a defined separator. Here's an example to demonstrate the usage of .split. We can have sentence equal to hello, Python is amazing. And we can have words equal sentence dot split. And so .split actually returns a list, so words is equal to a list. And then we can print words, and we can see that it's a list because when we run it, you can now use this list of separated words to do many things, like removing a specific word with the .remove method, or adding a word in between them with the dot insert method, and a lot of other list methods we've learned in previous videos. By default, the dot split method splits a string by spaces, but you can actually split it by something else. So if I had something like this, if I had a string with ones in between it, right? So I said, hi, one, how are you, with ones, right? You'd put one in here. The argument you put in dot split is whatever you're splitting it by. And so here we get hi, how are you, and it doesn't include the delimiter. The delimiter is this argument where you can put what you're splitting it with. And these can be any string. You can have a v or something, right? Put a v like this, and it's just gonna split the string by these. So if we run this, we still get hi, how are you, because it's splitting the string. And so even if you just wanted to split the string, if it said hello world, like this, a lot of times you just do this with a comma and then a space. Or if there's not a space, you'd not do a space, but you do comma and a space, and then you get hello and world separate. The dot join method allows us to concatenate a list of strings into a single string using a specified delimiter. It's like the opposite of dot split. This method is especially useful when you have a list of strings that you want to combine into a coherent sentence or paragraph. For example, you might want to combine all the words in the previous examples list after adding or removing a word, so you have the string again. So here's an example. So we can set this as Python is amazing, and the dot split would just be a space, but by default it's a space, so we don't even need anything here. And now we get words, right? And so you can see that this is the list. But now, if we wanted sentence 2, right? We had sentence 2. This would be equal to space in a string dot join words. And this seems a little confusing, but what you're doing here is you're actually not doing words dot join like you might think, because you might expect it to be like this, right? Because that's how it was with dot split. But for this one, you put the delimiter as the string that's calling dot join, and then inside dot join, you put the list. And so what this is doing is it is joining each item in this list with a space. And so when we print sentence 2, now we get Python is amazing because we've added a space in between each of them. If we just did an empty string dot join, it would be Python is amazing with no spaces. We could do 1 like we did before, and it can be any character. Here's an example using both dot split and dot join for language processing. In this example, we will use a lot of the skills you learned in previous videos. We'll use strings, string methods, integers, while loops, if statements, indices, string concatenation, lists, list methods, and string formatting. I know it seems like a lot, but we'll go through it step by step so you can understand it. It's always good to have little refresher projects to sharpen your knowledge of Python. So let's say we have a string containing a list of programming languages separated by commas, and we wanted to display them nicely like some popular programming languages are Python, Java, etc., with correct grammar and everything. And there are some spaces we need to remove that are in between some words, along with the fact that some of the words are lowercase when they really should be capitalized. So we'll do Python, then a bunch of spaces, Java, and then JavaScript with no space in between here, Swift, all lowercase, Ruby, Go, and then we'll do C++. So as you can see, this is not good grammar at all. Correct English grammar would be like this. But this, let's say maybe like a user typed this in or something and they put a bunch of spaces, right? So they did a bunch of spaces that aren't supposed to be there. Over here they didn't put a space like they should have, and they didn't capitalize some of the words. So we need to fix that, and we want to display it like this. Some popular programming languages are, and then this list, but with good grammar. So I'll first split the string into individual language names using the comma as the delimiter. So we'll set language list equal to language's string dot split, and we'll use a comma as the delimiter. So we're splitting it by each comma because each one is separated by a comma. Next, we'll use a while loop to remove any leading or trailing white space from each language name. So we can set cleaned languages equal to an empty list. This list will get appended to in the following while loop we'll create. It'll contain each language without a comma or anything. So that's what I mean when I say cleaned. It just means that we've fixed it. We get Python, we get Java, JavaScript, no commas, no spaces. And then we can set index to 0. This index variable will be used in our while loop. It'll be the index of the list that we are currently on in the while loop. It's similar to the count variable we used in the while loop video, but we're using it actually for indices. So we'll say while index is less than the length of languages list. So we want it to stop once it reaches the end of the list. So we don't want this while loop to go longer than the list, because then it wouldn't make sense. And then we can set language equal to languages list, and then refer to index dot strip. We set a language variable, and when I say language, we're talking about the current language we're dealing with in this list, so the current word, and it will be the index of the languages list we are currently on. So every time we go through this while loop, we'll write the code in a second for this, but index will get incremented by 1. So for each new index, right, it gets incremented by 1, so we're dealing with another word. So we could put variables in this index section. We don't have to just put numbers. And then dot strip, if you remember, it removes all white space from the beginning of a string. And if it helps you, you could just do language equals language dot strip like this. This is just the same line of code, but in 2 different lines. This one's just setting it to the list index and then stripping it. This one, we just do it all in 1 line. Now we will append the new cleaned word that has no spaces around it to the cleaned languages list. So we'll do cleaned languages dot append language. Lastly, we will increment index by 1 so that the next iteration of the loop will deal with the next word, to avoid an infinite loop dealing with the same exact word. Alright, so let's go over this while loop again, because sometimes when beginners are dealing with loops, they get a little bit confused. So we have an empty list at the top that will contain each word without spaces or commas around them. And we have this index variable, which will tell the while loop which index of the languages list we are dealing with. Next, we start the while loop. While the index is less than the length of the list, we will use the dot strip method on every word in the list, and then append it to the cleaned languages list. It knows which word to edit because we're referencing each word by index, which is added by 1 each time. So instead of using straight up integers in our indexing, we just used a variable. Lastly, we increment index by 1, so it moves on to the next item in the list. Once the index is incremented to a number higher than the length of the list, the while loop will stop, since there are no more indices in the list. Next, we'll convert each language name to title case, so meaning we'll just capitalize the first letter of each word. So title case languages is equal to an empty list. So this is another list we're doing. And then we set index back to 0. And we'll do another while loop. This one is just like before. We will set a while loop based on the length of the words in the list. So while index is less than the length of clean languages, we will set language equal to the current word in the list, so clean languages index, and then this time we're capitalizing them. Next, we append the current word to the title case languages list, so dot append language, and then increment index by 1, just like last time. So now we can test to see if our program is working so far. It's always a good idea to test your program while you're writing it, so you can find errors quickly instead of dealing with them all at the end. So let's print out the title case languages list to see if everything worked out. Alright, everything worked perfectly. We have managed to capitalize every word. There are no spaces or commas, so everything's working. So now we can delete this print statement. Now that we know everything is working, we can combine the language names into a new sentence. So we can set index back to 0 again. New sentence will equal an empty string that we will add to during the while loop. And we'll say while index is less than the length of title case languages. This is because the first time we're using languages list. The second time we're using the new list, cleaned languages, that was created in this while loop. And this time we're using title case languages that we have created. And so each time we are doing a more improved list for this program. And for every item in the list, we will check to see if the index is not the last index by seeing if it's less than the length of the list minus 1. So if index is less than the length of title case languages, -1. So again, this is checking to see if it's not the last index yet by just subtracting it by 1. So if it's less than the length of title case languages -1, so 1 less than that. And the reason we're doing this is because when you're doing a list in English, you don't do apples, bananas, strawberries. You do apples, bananas, and strawberries. And so we want to check that so that we can put the and there. So if it's not the last item, we will concatenate or add the current word with a comma and a space. So title case languages, index, plus, and then this. The plus equal sign just adds something to a string, concatenates it, so we're adding this current item in the list to this. And we're doing a comma after it so that it turns into a list. Actually, we should put a space here. And then if it is, so else, so this means if it is the last item, we will add the word and to the last word. So we're to do the exact same thing, except we are adding and first with a space at the end, and then title case languages index. And then down here outside of the while loop, we just increment index again. This might look a bit intimidating at first, but it's essentially going through the list and creating a comma-separated string with correct grammar. The if statements check to see if it's the last item. That's all this if statement is doing. So down here, so you can see what happened, right? We can print a new sentence. And so when you saw the last list last time, it had each capitalized word in it. Now this just created a new version of the original string by taking each item, putting a space and a comma, and then for the last one, just putting and. So we're almost done. All we have to do is output the new sentence. We'll use f-string formatting to do this, so we will print some popular programming languages are, and then the sentence we created above. So we'll do print f, like this, some popular programming languages are. In the curly braces, we'll do new sentence, and then a period at the end. So after writing this string, we just put new sentence in the f-string formatting brackets. And remember to put the f before the quotation marks, not inside it. And so lastly, we run this, and it says some popular programming languages are Python, Java, JavaScript, Swift, Ruby, Go, and C++. So this is the biggest example I've ever done in this course. So I'll do another brief explanation. We basically start with a string containing a list of programming languages with bad grammar. Then we use the .split method to split the string into individual names based on the comma. And next we create a while loop to remove any leading or trailing white space. Then we use another while loop to convert each language name to title case. And then we create a third one to combine the title case languages into a new sentence, separated by commas, with the word and everything with good grammar. Now I know that you could technically do the work of these 3 while loops in one loop, but I wanted to get you familiar with while loops, writing while loops, and get used to the things that you can do inside of them. The .find method allows us to search for the first occurrence of a substring within a string and returns its index. It's helpful when you need to locate specific substrings or patterns within a larger text. As you know, the .replace method enables us to replace occurrences of a substring with a different value, allowing for efficient text manipulation and modification. Here's an example. We can set sentence equal to hello, Python is amazing. Then we can set index equal to sentence .find Python. And we can set new sentence equal to sentence .replace amazing and then incredible. Now we can just print, for example, index, and then we print new sentence. So here we get 7, and then here we get hello, Python is incredible. What .find does is it actually returns the index of the occurrence in the string. And that's actually really useful, because if we wanted to, for example, just remove that section or do something with this, with that index that it starts at, you can do that. So with .find, you can easily get the index of a section, and then as you know with .replace, you start with what you're replacing, and then you do what you're replacing it with. Congratulations, you've now expanded your knowledge of advanced string methods in Python. By mastering these techniques, you'll have a powerful toolkit at your disposal for manipulating and transforming strings in Python. Today we're going to be creating a simple text-based guess the number game in Python. In this game, the computer will randomly select a number between 1 and 100, and the task is to guess that number correctly. The video will contain refreshers on many data types, including booleans, strings, and integers. We'll also deal with some string formatting as well as if statements, a while loop, and type conversion, which is just a fancier way of saying converting something to a different data type. We'll also learn about importing modules. Before we dive into the code, let's take a moment to understand what importing means in Python, if you're not familiar with it yet. Python's a versatile programming language with a vast collection of built-in functions and modules. A module is a file containing Python functions and statements that can be used in other programs. Importing a module allows us to access its functions and features, extending Python's capabilities beyond its standard library. In our code, we use the import keyword followed by the name of the module we want to use. This gives us access to the functions and utilities provided by that module. In this mini project, we import the random module by using the line import random. Lucky for us, this Python module comes shipped with Python, so you don't have to download anything from the internet because it's already on your computer. All we have to do is type import random, and when you run your program, Python sees the import and gets the module ready. The random module allows us to generate random numbers, which is essential for creating our simple guessing game. Importing modules is a powerful way to expand the functionality of Python and enables us to build more advanced, feature-rich programs. Alright, let's dive into our code. So we can import random. In most programs, all the import statements are at the top. So here we have our import statement. Next, let's create a variable called number and set it to a random number between 1 and 100. We can do this by calling the random module and then its function randint by typing a dot and then randint. This function takes 2 arguments. We will set it to a number between 1 and 100. This function, as you know, generates a random number. So if we ran this and printed number, it could be 43, for example, and if we ran it again, it could be something like 67, so it's different every time. This is the number that the user will have to guess. Next, let's set a variable called guessed, and set that to false. This variable will be set to false at the beginning of the game, and it kind of acts like a flag, because we set it to false initially, meaning the user hasn't guessed the correct number yet. But once they guess it, this variable will be set to true, and the game will end. Next, we'll create a variable called tries, and set that to 0. This will keep track of how many attempts the user has made to guess the number. We started at 0 and increment it with each guess. Now we need some way to keep the game asking the user for their input until they guess the number. To do this, we can use a while loop. The following while loop will keep running as long as guessed is false. So type while guessed equals false. And so as long as guessed is false, the code that we will write inside this will execute. This is where we'll ask the user to input their guess. Inside the loop, we'll use the input function to prompt the user to enter their guess. We can store their answer in a variable called answer, and that'll be assigned to input, which will ask them to guess the number between 1 and 100. Now for every iteration of this while loop, we will check to see if their answer is not numeric. If answer.isNumeric is equal to false, then if it's not numeric, we will print please enter an actual number. And then we'll type continue. If you remember, the continue keyword will bring us right back to the start of the loop. Also, we will not add 1 to the tries variable yet, because this doesn't count as a real guess. It was just an invalid input, and therefore they'll just have to enter it again. And after this if statement, we will convert answer to the integer version of it. And this is safe to do without an error, because if the answer isn't numeric, it'll continue to the top of the loop. And if it's not, it'll just skip over the if statement and run this, because it's numeric, so it can convert it. So after obtaining the user's guess, we can compare it with the randomly selected number. If the user's guess matches the number, we will print a winning message and update the guessed variable to true, which will end the loop. If it's too high or low, we'll provide the feedback and continue to the next iteration. First, let's see if they guessed correctly. If answer is number, if they match, we'll print, and then we'll use some f-string formatting here and say you win, you guess number, like this. Next, we'll print using % formatting to say how many times it took the user. It took you %s tries, and then outside of here we do % and then tries. Using 2 different kinds of string formatting for 2 similar statements isn't really good practice in programming, but I wanted to refresh your memory on both types of these formatting. Lastly, since they guessed it, we will set guessed equal to true. And when the loop checks to see if guess is false, once it gets back to the top, it'll just stop. Now, if the user didn't guess it, we want to give them hints like guess higher or guess lower. So if they guessed higher than the number, so greater than number, then we can print guess lower. And then everything else, which would just be if they guessed lower than the number, then we'd say guess higher. And then lastly, since the elif and else are both part of this if statement, only one of these three will end up executing. So once one of them are done, it moves to the end of this entire block of code. And this means that we can now increment tries by 1, instead of putting it in all three of these if statements. So this is our final code. And so now if we run this, we can see that it says guess the number between 1 and 100. And if I were to type a bunch of random letters, it would say, please enter an actual number. And then I typed it again. No matter how many times I do this, it keeps telling me to enter an actual number. And so if I do that, like 50, it says guess lower. Okay, so we'll do 30, 40, 45, 44, and then I guessed it. It took me 4 tries. That is because over here, these ones don't count because they're just errors. They don't really, it wouldn't be fair to count these as tries if they're not even numbers. So we go down here, we do 50, 1, 2, 3, 4, and it took us 4 tries. This is because after every single iteration of this loop, tries is added by 1. And so while guessed is false, right, guessed is only true when you win, so that means that it ended. And it's still incremented by 1 because it still had to go to the end of the loop, and it only checks once it gets back to the top. Congratulations, you've just created a simple guessing game using Python. In this project, we used the random module to select a random number, and we learned how to use a while loop to create an interactive guessing experience. I hope you had fun with this mini project. Feel free to modify and expand upon it to make it even more exciting and challenging. Hey everyone, in this video we'll be exploring for loops in Python. For loops are an essential tool for automating repetitive tasks and iterating over collections of data. Let's start by understanding for loops and why they're so powerful in Python. For loops are different than while loops because a for loop allows us to repeat a block of code a specific number of times, or iterate through elements in a collection, like lists. This makes it an excellent choice when we want to execute the same code multiple times without writing it over and over. The basic syntax for a for loop in Python is quite straightforward. We use the for keyword followed by a variable that will represent each item in the collection being iterated over, and then we use the in keyword followed by the collection we want to loop through. Finally, we put a colon at the end of the line, and the code block that follows will be executed for each element in the collection. Note that the code block must be indented to indicate that it belongs to the for loop. Python uses indentation for code blocks, and consistent indentation is essential for avoiding errors. Let's dive into a practical example of a for loop using a list. We'll create a list of numbers and use a loop to print each element by iterating or moving through the list. So whenever I say iterating, it just means moving through whatever we're iterating. So our list numbers is equal to a list containing 1, 2, 3, 4, and 5. Now we'll say, hey Python, let's execute the following code for every number in numbers. So we'll do for num in numbers, for every num in numbers. Num is a variable we are creating just for this for loop. For every iteration, num will be set to the next item in the loop. So we'll print num, and so every time num will be the next item in the list for every iteration of the loop. And so when we run this, we get 1, 2, 3, 4, 5 because the first time num was 1, second time 2, 3, 4, and so on, and it printed all of them. So when we ran that code, it printed each number in the list on a separate line. This is a much better way to iterate through a list than with while loops like we've done before. Here's an example of a while loop doing the exact same thing. So I'm just going to put a separator here, unindented. We'll just put a separator so we can separate the two for loops. And now we can set index to 0, because remember we have to have a counter variable. And then we set while index is less than the length of numbers. We'll print numbers and then index. So we're getting the current item in the list by referencing the index of whatever the variable index is. And then we make sure to increment index by 1. And so this does the same exact thing. And so as you can see, it's clearly a better choice to use a for loop when iterating through items in a list. While loops are meant to repeat code until a statement is false, while for loops are meant to iterate through a collection. And it just makes more sense in readability too, because you're saying for every number in numbers, it makes sense. While over here we have this variable index, and it's while index is less than the length of numbers with using this function and stuff, and then we have to reference the actual index and then increment our thing, when all we have to do is write 2 lines of code, and over here we have to write 4. It's always a better choice to use a for loop when iterating through a list. For loops aren't limited to lists. We can use them with other data types, including strings. We can also use them with other data types that we will learn later in the course, like dictionaries and tuples. Let's explore how to iterate over characters in a string. So our message will equal hello world, and for every character in message, we will print char. And so char can be named whatever you want. You could even just name it X if you wanted. It's just not a good idea since it's hard to read it. But for every character in message, you could even do character like this, and it would still work. And so we're printing that character. So whenever you're using a for loop on a string, it will count each character as an iteration item instead of an item in a list, because this isn't a list, it's a string. Here we get hello world. Each letter is printed on a separate line, and there we go. For loops can be used for more than just printing elements. We can utilize them to perform various computations, like calculating the sum of a list of numbers. So we can have a list called numbers, and that's equal to a list 1, 2, 3, 4, and 5. And then we can have a variable sum of numbers, and that's 0 to start. And we can say for every number in numbers, and we'll say sum of numbers equals sum of numbers plus number. So this is adding whatever the current number is to the sum of numbers. And we're not getting the length of the list, we're just adding 1 plus 2 plus 3 plus 4 plus 5. And so when we print sum of numbers, we will get 15, because 1 plus 2 plus 3 plus 4 plus 5 is 15. Another useful tool for loops is the range function. The range function generates a sequence of numbers that we can use to control the number of iterations in the loop. This is useful when we want to repeat code a specified number of times. For example, we might want to print a certain code 5 times. So over here we could say for I in range, so this is for every I or whatever, for every item in range 5. And so range is just that function that I just talked about, and we print hello world. And so this will print it 5 times. When we extend this, it's 5 times. That's because range actually returns a sequence of numbers, which we can iterate through. So we've iterated through range, and it was 5 times. So if you ever want to repeat something a number of times, you just do range and then whatever number. The range function can take additional arguments to control the starting point and the step size. If we wanted to start our range at 1 instead of 0, we could do it like this. 1 and then 5, 2 arguments. This would print hello world only 4 times because we started at 1 and went up to 5. Just like indexing, we start at a number and we end before hitting the endpoint. So for this example, we repeat 4 times because we started at 1 and went up to, but not including 5. You could also change the step. If you remember, when indexing a string or list, you can control the step, or how many numbers it jumps. Well, you could do that with range as well. So we can just add another argument here, and let's actually change this to 10 so that there's more numbers, and we'll do 2. And let's actually change this to 2 over here, so we start at 2. So we're starting at 2, going up to, but not including 10, and going by a step of 2. And so it's the same order as when you're indexing. And so let's actually print I, so you can see what's going on under the hood. So you can see what number is actually being evaluated here. We get 2, 4, 6, 8 because we start at 2, so we got 2. Then we'll go up to, but not including 10. So if we did 11, it would include 10. And then we go by a step of 2, so that's why we get only 2, 4, 6, and 8, and not 2, 3, 4, 5, 6, 7, 8, 9. And so if we actually started at 1, we'd get 1, 3, 5, 7, 9. Like that. For loops can also be nested inside each other to perform more complex tasks. Let's see an example of a nested for loop. So we have for I in range 3, we'll do it 3 times, and then inside here we do another for loop for j in range 2, and we'll just print I, and actually we'll do print I plus a space and then j, and we'll actually have to convert these to strings as well. Sorry about all this code. It looks a little bit verbose, but we'll just write it down. So we're basically just printing I and j, and we actually get 6 print statements because we have nested for loops. So instead of doing it 3 times or doing it 2 times, we actually do it 6 times. 1, 2, 3, 4, 5, 6. They're both at 0. We go back to this loop, right? And for the second time, then it changes to 1. It'll only ever get to 1 because this is only executed 2 times, so it goes 0, 1. That's why we start at 0, but they're both 0, and then it goes back to the top of this loop right here, changes to 1. Then when this loop is done, it goes all the way back to the top here and does this thing again for the second time, and then the third time, and that's why we get 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. If it's confusing, I get it. Nobody completely understands nested for loops the second they learn it, so it's fine if you don't remember this specific thing. Hey everyone, in this tutorial, I'll talk about tuples in Python. Tuples, or sometimes pronounced tuples, are another essential data structure in Python, and they have some unique characteristics that make them different from lists. So tuples are similar to lists in that they can store multiple elements, but they have one crucial difference: they're immutable. This means that once you create a tuple, you cannot change its elements, add new items, or remove existing ones. Besides that, tuples and lists are almost the same. Tuples are represented using parentheses instead of straight brackets, and elements are separated by commas, just like in lists. Let's create a couple of examples to get a better sense of their syntax. So we can have fruits equal to the tuple, apple, banana, and orange. And we can have another one called dimensions, and that'll be equal to 10, 20, and 30. So these are both tuples, and we can print fruits, for example, and then dimensions, and you can see that it prints out the same way as lists. If you'll notice, you can't change one of the values, so if I try to reference fruits and the second item, which is banana, and I tried to set that equal to strawberry, I get an error because tuple doesn't support item assignment. That's because they're mutable, you can't change the values of them. Just like with lists, we can access individual elements in a tuple using indexing. Our fruits one again, and we can print fruits 0, which is the first item, and then we can also do slicing like we learned before, 0 to 2. In the first example, we got the first item. In the second example, we got from the first item up to but not including the third item. Now we're going to learn something new about both lists and tuples. A cool feature is that lists and tuples both support something called packing and unpacking. Packing is when you assign multiple values to a single tuple variable or list, so that's just when you're creating a list, and unpacking is when you extract those values back into separate variables. Here's an example of tuple packing and unpacking. So dimensions is equal to 10, 20, and 30. We can unpack this, so we just packed it like this. We can unpack it by setting length, width, and height to dimensions. If this looks strange, all it's doing is setting these 3 variables equal to each value in dimensions in the order we place the variables. And note that dimensions has to be the same exact length as how many variables you have and vice versa. The reason you don't really see this as much with lists is because tuples are immutable, so you're going to always know that there's 3 items. However, you can still do this with lists. It would still work. I could just change these to these brackets and it would still do the exact same thing. But you see this more often with tuples because it just makes more sense. And you'll learn later in this video the difference between why you would use tuples versus lists. But you commonly see unpacking and packing only with tuples because the length will never change, so this will never have an error. Print each variable to show you that it worked. Now I get 10, 20, 30. Since tuples are immutable, they have fewer built-in methods compared to lists, but there are still a few useful ones, including ones you already know that work with lists. The length function works with tuples as well, and it returns the number of elements in a tuple. Here we have fruits again, and length can be set to the length of fruits, and now we can print length. Now we get 3 because there's 3 items. Of course, like always, you don't have to set this to a separate variable. You could just do it like this, and it still works the same. The count method returns the number of occurrences of a specified element in the tuple. So let's create a tuple called numbers and set that equal to a tuple containing 1, 2, 2, 3, 2, and 4. So it's got 3 2s in it, and we'll use the count method to actually count how many of these are. So we'll have a variable called count 2s, and that's equal to numbers.count2, because we're counting how many occurrences of 2 there are. And now we'll just print that to C, and we get 3, because there is 1, 2, and 3 occurrences of 2 in the tuple. Now let's learn a new function called index. This one works with strings and lists as well, and it returns the index of the first occurrence of a specified element in the tuple. So here we have our fruits tuple again, and we can set index banana equal to fruits.index banana. So this is getting the index of a certain element in the list, and it'll get 1 because that's index 1. Now that we've learned about tuples and their features, you might be wondering why we need them when we already have lists. Isn't it better to have the ability to change the items anyway? Well, tuples have unique advantages over lists. First of all, they're immutable, which makes them useful for protecting data that should not be changed throughout the program. They are faster and consume less memory compared to lists, making them ideal for storing constant data. When should you use tuples, and when should you use lists? It depends on the situation. If you have a collection of items that should remain constant throughout the program, use a tuple. So if you're trying to protect the data, like I said before, or you just know that it's never going to change, which you will do because it improves performance to use a tuple instead of a list. But on the other hand, if you actually need to change the items, then use a list because they are mutable, not immutable. Hey everyone, in this tutorial, we're going to unfold the concept of dictionaries in Python and learn how to use dictionary methods effectively. Let's kick things off by understanding what dictionaries are. In Python, a dictionary is a collection of elements where each element is represented as a key-value pair. The key acts like an identifier for the value, allowing you to access, modify, or delete the value associated with that key. And also the word map is another word for dictionary, so if anyone ever says map, just remember it's another word for dictionary. Dictionaries are represented using curly braces, with each key value pair separated by a colon and individual pairs separated by commas. The keys can be of any immutable type like strings, numbers, or tuples, while the values can be of any data type. If you remember, immutable data types are types that cannot be edited directly. For example, you can't directly change a value in a tuple. Strings are also immutable, meaning you cannot directly change a character. You can use string methods which return new strings, but you can't directly edit the characters of strings. Instead, you usually just assign a variable to a new string every time you want to change it, even though you're not directly changing the exact string in the memory. So dictionary keys can only have immutable types, but the values can be of any data type. So let's create a dictionary in Python. Let's have a dictionary for student, and that's equal to a dictionary with these curly braces. And we'll say that their name is John, and their age is 20, and their course is computer science. And so if this looks confusing, essentially the colon is actually just representing something like this, where we had name John, age 20, course computer science. That's essentially what we're doing with dictionaries, but we're actually storing data. And so you could even just put the colon right next to the first one if you want, or have them both connected. It doesn't really matter. I prefer to have them separated like this, but some people prefer to have it like this for readability. When we print out student, we get just the entire dictionary just like this. So here we created a dictionary called student where name, age, and course are the keys, and John 20 and computer science are their respective values. When writing long dictionaries, it's actually a good idea to add new lines after every item, just like you can do with lists and tuples. So after you see this comma, we can actually just enter a new line, and then usually the last curly brace is actually at the end, just like this. Either way is fine, whatever you want to do. Now it actually looks more like that example we had before, where we actually just had it on each line, and it's still the same dictionary. It's just readability purposes. It's not evaluated in a different way. We can access a dictionary's value by using its key. Let's find out the name of our student. So we could print student and then index it with name. And so as you can see, by using the key name, we can actually access the value John from our student dictionary. This is similar to indexing in lists and tuples. But for dictionaries, you don't use index numbers. Instead, you use the name of the key. Updating a value in a dictionary is as simple as accessing it. Let's change the age of our student to 21. So we can go down here and set student age equal to 21. And now when we print their age, now it says 21, even though before it was 20. And so actually, if we printed age before changing this and also after it, we get two different results because we had a value and then we changed it. We can also add new key value pairs to our dictionary. Let's add the grade of our student. So if we already have a dictionary and we don't have a grade yet, we could actually just add more stuff to it. We could actually just say student and then refer to grade. Even though there is no grade yet, we're setting it to A. And then we convert student, and we see that they actually now have a grade section. To remove a key value pair from a dictionary, we can use the del statement. Let's remove the grade of our student. So after we've set this grade, we can now actually just remove it by doing delete or del student grade. And now if we were to print this, we don't get a grade key value pair. And if we try to refer to it, we would get a key error since it doesn't exist. The del keyword can also be used to delete variables, lists, items inside lists, and more. However, most of the time, to delete items inside lists, we use the .remove method, and the .pop method is actually also available for dictionaries like this. So actually, there's two different ways to actually do this. This one's directly removing it from the memory with the del statement, and this is just another way to do it, which is student.pop grade. And we will actually have to just remove this since it doesn't actually exist. And now if we were to print student, we don't get a grade anymore because we actually just popped it. So pop works the same way as with lists. You just do .pop and then you specify what you want to specify. Like lists and strings, dictionaries in Python also come with several built-in methods that make working with dictionaries easier. The keys method returns a view object that displays a list of all the keys in a dictionary. So essentially, it just shows you all of the keys in the dictionary. So if we get rid of all this and just print student.keys, we get this object here. You'll learn about objects later in the course, but we get this object containing a list of all of the keys, and that's how you get all of the keys. The values method returns a view object that displays a list of all the values in the dictionary. So instead of doing student.keys, we could just change this to values and print that. And now we only get the values, which is John 20 in computer science. The items method returns an object that displays a list of the dictionary's key value tuple pairs. Student.items would actually return a list of every item in a tuple. So the key value pairs are actually separated by tuples. They're no longer in dictionaries. It's a list containing tuples. The get method returns the value for the specified key if it exists. So we can print student.get and then name. So if we wanted to get the name of the student, so maybe we had a bunch of other students, so like we had student 1, that was this student, and we had another one named Jack, and this person was 22, and their course was something else. And so here we wanted to say, okay, well, I'm going to get student 1 and student 2. I don't know what student 1's name is or student 2's name is, but I want to know what student 1's name is, so I'm going to do student1.get and name, and there we go, we get John. And if we change this to student 2, remember I changed this one to Jack, we would save it and run it, and we get Jack. If we wanted to get their course, we would return something else, because it's something else. And if you'll notice, if you actually enter something that doesn't exist, you'll get none. And you can actually change what this returns. So if we added a second argument, this would be the default value. So I can say unknown value, for example, and we just get unknown value because it doesn't exist there. And so depending on where you are in your program, if you're writing a big program, you might have a dictionary with lots of different things. You're taking stuff out, putting stuff in, and at any given moment, you might want to get a certain value. If that value doesn't exist, you might want to actually return something else, like maybe your own error statement or something else that'll be displayed to the user, whatever the case is. The update method takes another dictionary as an argument and adds the key value pairs from it to the current dictionary. If the key already exists, the method updates its value. So here we can just update, actually I'll remove student 2, we'll just update student 1's age. So we can say student, let's actually change this shift back to student. So student.update, And then in here we actually enter a dictionary. So we're entering age and setting that to 22. And then we're setting there, let's actually set the grade as well to an A+. So with this, the update actually takes in a dictionary as its argument. You can actually have as many things inside this dictionary as you want. It doesn't have to just be one updated item. So this is a great way to edit multiple things. And so this dictionary will actually edit student. So it'll set age in the student dictionary to 22, and it'll set grade to an A+. Hey everyone, in this tutorial I'm going to be talking about comments in Python. I know we went a little bit over them in previous sections, but I think that they deserve their own video because they're this very useful feature in Python. Let's say we had our example from our dictionaries video, and we wanted to remember what this line did. And in the future, let's say we wanted to just figure out, okay, well, how do I change this? What do I do? And you just don't remember what it is. Now, this is a very small example, but when you get into more advanced projects in Python, you're going to be writing these complex statements, and you're going to have to remember what they do, so you don't have to figure it out every time you look at your code. So let's say this was a complicated example. Well, we could add a comment here. Comments in Python are started with a hash, and anything you write after the hash is not evaluated or ran by Python. Python completely skips over it. It's just for your notes or for someone looking on your code, or just to comment out code. So like, let's say we're not using this line anymore, so we can just comment this out. In most code editors, actually, if you go in a line and then you do /, it comments out that line. The other way to do it is obviously just put a hash here instead. Those are the ways that you can use comments. You can use them for anything. Python will skip over them, so you can use them for whatever you want. And so it's a good idea to comment out your code to make sure that you know what it does. So if I did a hash and said updates student dictionary, and then adds grade and last name, because as you can see over here we've got grade, it's adding to it. We don't have a grade here yet, and we have last name. We don't have a last name here yet, so we're updates the student, and then we make sure we say that it adds them because they don't exist. And so that's just an example, right? And so comments can actually also just, help you with pretty much anything. Let's say you had a different file and you just want to say what this file does. This file is the only file in the program, but if you had multiple files, you could say this file holds data for dictionary or something like that. Now, another way to write comments is, if you notice, for every new line, if you're writing a long comment, you'll have to put another hash. It's a little bit tedious. You can, of course, just start typing and doing all your stuff and then just highlight them and then do /. But another way to do this is you can actually just type strings into your file. So if you remember in our first video, triple quotes that I showed you about, it's pretty common to use these triple quotes when you are commenting big lines. Now, I don't see this very often because most code editors these days, like I said, just have this hash and nobody actually types these out, or at least not very often. And so what you could do, though, is Python will skip over strings, because if you have a string in your code, or even just a string like this, it will not evaluate it, it will not run it, it'll skip over it. So I can say this is a line, this is another line, and this is the third. And you can see here, if we run this file, we actually get no errors. We haven't printed anything, so that's why you don't see anything here. It still works, right? Print student, for example. And here we get everything, it works, we get no errors. And so that's what comments are. They are not evaluated at all. If anyone ever types a comment with a hash, that means it is a comment. So I hope this video has cleared everything up if you were confused on what the hash did and what comments are. In today's tutorial, we're stepping into an exciting Python topic, two-dimensional lists. By now you're well acquainted with Python lists, but did you know that you can nest lists inside lists, creating multi-dimensional data structures? A two-dimensional list, known as a 2D list or a matrix, is simply a list of lists. It's a powerful tool for representing structured data like a table or grid. So here's an example of this. So let's call two-dimensional list, and that'll be equal to a list containing another list that contains 1, 2, and 3. and then we separate this at the end of here and create another one. 4, 5, 6. Separate that. 7, 8, 9. And I'm just going to add these spaces here to show you. So this is a simple two-dimensional list. But most of the time you don't write them like this, because this is a little bit confusing. But first I'm going to show you it like this, and then I'll show you the way that you're usually going to write two-dimensional lists that makes more sense. And so accessing these elements, like I'll show you in the next section of this tutorial, you're actually going to use two indexing brackets. And so instead of using one like you're used to, you'll use two. And so what these essentially say is, okay, well the first one is the first item. So these are each items in the main list. And so let's say we're going to get this item, we'll do index 1 because it starts at 0. And then this next index is actually referring to the item inside index 1. And so this could be 5, so this would be another 1. And this is, we could also do 2 for 6 to make it different numbers so I could show you. So this is saying, okay, well, we're going to access the first item in the list, and then indexing from this item, we're actually going to index the second index, which is 6. And so this is actually how that works. But there's actually an easier way to write 2D lists. So you might actually use this to represent a table with columns. So instead of doing it like how I just did, actually, let's go and hit enter after every item. And so now, this is actually a grid, because now it actually makes sense, because when we are going to index this, we can actually do, okay, row 1, column 2, right? Obviously, we're still indexing, so it starts at 0, so row 0, column 1, and so we could actually treat this as a table with rows and columns. And so that's why most of the time you write two-dimensional lists like this. Of course, it's not evaluated any differently, but it does help you understand two-dimensional lists, because when you write them all out in one line, it can look a little confusing. So like I said, you can access elements in a 2D list by specifying two indices, one for the sublist and one for the element within that sublist. Here's how you'd access the number 5 in our previous 2D list. We would just say, we could just print it, for example, two-dimensional list, 1 and 1. So the first index accesses the second list, and the second index 1 accesses the second element inside that list. Or you could actually just think of it as row 1, column 1. Technically row 2, column 2, because we're indexing. And now when we run this, it says 5. Modifying elements in a 2D list is just as straightforward as modifying elements in a normal list. Just like regular lists, you can change an element by assigning a new value to the corresponding index. So let's replace the number 5 with the number 10. So we could say two-dimensional list 1, 1 is equal to 10. And now when we print our two-dimensional list, we get a new list with 10 in the middle. So when you have a 2D list, you actually don't have to use two indexes. So if you only wanted to access index 1, which is this, you could just change this entire thing. And so if you wanted to do that, you could say 10 if you wanted. So now we would get a list containing a list, then just an integer, and then another list. And that would look like this. That's all it would look like. You can also just do a list. So 10, 11, and 12. And so now when we print matrix, we get 1, 2, 3, 10, 11, 12, 7, 8, 9. Because we just changed the entire first element, which is this. You can apply many of the list methods you've already learned to the sublists in a 2D list. For example, let's append a new row to our matrix. So we can have a new list called new row, and that's equal to 10, 11, and 12. And now we can do two-dimensional list.append new row. And printing two-dimensional list would give us the new list with actually 4 lists inside of it because we've appended this one. And of course, I'm not going to show you every single list method because we've gone over them before. And they're pretty straightforward. It's just using two indices or not if you don't want to. And all of the list methods work on two-dimensional lists. Treat them just like normal lists, except for the fact that when you want to index a specific number inside another list, it's just another index. You can iterate over a 2D list using nested for loops. The outer loop will iterate over the rows, and the inner loop will iterate over each element in the row. Let's print all the elements of our matrix. So we could say for every row in two-dimensional list. And then for every row, then we will also say for every element in row. Then we will print element, and then end is equal to a space. And so this is actually, I want to show you what this means for a second before we do this, so let me just comment this out. When you do any print statement, hi, for example, and you put another argument in this, because print's just a function, just like any other function we've done. There's another parameter that we can do, which is end, and set that equal to anything we wanted. When you're using a print statement, you actually have to specify what the argument is. So you're used to doing functions like, you're used to doing them like this, right? Argument 1, 2, and 3. But sometimes you actually have to specify what you're actually deciding, because in Python, the order of arguments doesn't always have to be the same. So if the first one was called argument 1, or arg1, you can actually say arg1 is equal to 2. Now this seems a little confusing, but this is just saying that we wanted to set these arguments, and this will all make sense when we're creating functions. But all I'm saying here is that print has an argument called end, and you have to specify with end is equal to something. And so usually, the end of a print statement is a new line, so that's default. But if we wanted, we can set that to a space, and so if we did another print statement, you'll notice that it just says hi, space, hello. These are two different print statements, so that's all we're doing. We're making it so that we see all the elements printed all out next to each other. And so that's why we're doing that. And then in the main for loop, we'll just say print. This will just be a new line after each row. So the outer loop goes through each row, and the inner loop goes through each element in the row, which is this variable. And so we can just run this, and we actually get the grid. Because for every row, we actually printed each element with a space. And then once this was done, meaning we got to the bottom of this loop, we print a new line, and then it goes again, and the row has changed, and it does that again. In this tutorial, we're going to be talking about three-dimensional lists. Now, I know the last section was about two-dimensional lists, and I'm not going to go over every possible scenario. I'm not going to go over four-dimensional lists, five-dimensional lists, six-dimensional lists, but I wanted to make this video just to show you that two-dimensional lists isn't as far as you can go. You can also go farther, because lists can contain more lists. And so, in our code, we can have a let's call it 3D list, and this is equal to, first of all, we had our first list, which was 1, 2, and 3, 4, 5, 6, and 7, 8, 9. And so this is a 2D list, right? But a 3D list would be lists inside lists inside lists. And you can go further than that if you wanted. And so I just made this video to show you that you're not only limited to 2D lists, but you can't write this like how we did last time with the grid, because we don't have 3D screens, so we can't write that like that exactly. We could still actually do the enter, but you'd still have lists inside lists in that manner. And so here we will still have a list. This will be a list, this will be a list, this will be a list. And so let's create a list inside here. This is containing a list that has 1.0 and then 1.5. This will be a list containing 2.0 and 2.5. And just like that one, we'll do 3.0 and 3.5. And I'll do the same for this. And actually, I'm not going to do it for the last one, because you understand what I'm trying to show you. Okay, so here we have a 3D list. And if we wanted to refer to, let's say, 3.5, right here. Well, we would do 3D list, and we would index, okay, well, this is index 0, so we'll start with 0. And then we have to index the third item inside that list, so that's index 2, so we go index 2. And then we have another index, because there's indices inside these, so this time we'll do index 1, because this is the index 1 right there. And here, we will get 3.5. And this does have use. It's not only just for tutorial like I'm showing you right now. This has use in very complicated data structures, but this video, I'm not expecting you to remember exactly how to use 3D lists and always practice using 3D lists. 2D lists are enough. If you know how to access things in 2D lists, you know how to access things in 3D lists. But inside 3D lists, I just wanted to show you that however many lists you have, that'll be how many indices that you are referencing. And so now let's index 5.0. So we'll go into the index 1, and then inside there we have index 1 as well. And then this one has index 0. And then we get 5.0. So like I said, you don't have to learn about 3D lists and stuff like that, but I just wanted to show you. However, something I do want to show you is that when you have... Actually, let's just make this a 2D list because, like I said, that's enough. So we'll do a 2D list. This will be 1, 2, 1, 2, and 3. And this will be 4, 5, 6. And then in the next item... Actually, you know what? Let's do 5, 6, 7. Because what I'm trying to show you is we can actually have 4. And so now we have a list, a number, and then a list. And so when you have a 2D list, it doesn't have to be only lists. Lists in Python don't have to only have one data type. When you have a list inside a list, that doesn't mean all the rest of the items have to be like that. Unlike in Java, for example, you have to have the same data type in an array. But in this case, you don't really have to in Python. You don't have to have a list after this, right? And so when you want to index this, you actually don't need to have 2, right? So if we did 2D list, if you wanted to index 2 right here, for example, we'll just do 0, and then we'll index the second item, which is 1, and there we get 2. But if we wanted to index this would actually be 1, and if you actually try to index any of these, like 0, you'll get an error because there's nothing there. You don't have another index. There we go. This is only for indexing something inside a list, because whenever you even just have an index, it's saying, okay, well, whatever the list to the right of this is, we'll get the index of this. And so when you have another index, all that's saying is, let's look to the right of this. Oh, it looks like we have a list that's indexing 1, so let's do that. And so in this case, we would only just have 1 because there's nothing else. So if that was a little confusing, all I'm trying to say is you can have multiple data types in your list, but if you have a list and not a list, you just index it normally, and with a list, then you'd index it with 2. Hey everyone, in this tutorial, we're going to cover a unique and essential data type in Python called sets. If you recall our video on lists, we mentioned that a list is an ordered collection of elements. Now imagine a collection where the order does not matter, so meaning it's an unordered collection of elements, and that means that duplicates are not allowed. So that's exactly what a set is. So to create a set, they're actually defined by curly braces. So just like dictionaries, they use these curly braces. So just because you see curly braces doesn't mean it's a dictionary or a set until you actually look at what's inside it and see if there's only commas or if there's also colons. If you see colons, it's a dictionary. So if it looks like a list that has curly braces, then it's a set. So let's create a set. Let's set this to numbers 1, 2, 3, 4, 5. So this is our first set, and it contains 5 unique integers. So what happens if we try to include duplicate elements in a set? Let's find out. So if we actually add a 1 to this, because there's another 1 in here, so you see there's 2 now. Let's find out what happens. So actually originally, printing numbers would just print out the set just like this. And if we added another 1 here, and we printed it, it would still give us the same result, because sets don't have duplicate items. Of course, you could have a string containing 1, and that would be a different story. Sets are very handy when it comes to performing mathematical set operations like union, intersection, difference, and symmetric difference. The union operation combines all unique elements from 2 sets. In Python, we use the union method. So let's have a set called set1, and that's equal to 1, 2, 3. Set2 is equal to 3, 4, 5. And as you can see, there's 2 3s, so there's a 3 in this one and a 3 in this one. Now, union set is equal to set1.union set2. And if we print union set, we will get 1, 2, 3, 4, 5. The union of set1 and set2 gives us a new set, that includes all unique elements from both sets. So if I had another 3 here, it would still be the same result. And in this case, the order of this doesn't even matter. We could do set 1 just like this, and it would still work like that. Because like I said, the order doesn't actually matter. So if I had set2.union set1, so if I had set2 calling.union, it wouldn't do 3, 4, 5, 1, 2 because the order doesn't matter. So when you use the union method, you combine both of the sets, but only include the unique elements. Because of course, sets cannot contain duplicates, and if they do, it just gets rid of the duplicate. The intersection operation retrieves the common elements from 2 sets. We use the intersection method. So we have set 1 and set 2, and now we can have something called intersection set is equal to set1 dot intersection set2. And we can print intersection set, and this will give us a set containing 3. So it's a set with 1 value, and that value is 3. And by intersection, we mean the duplicated value if these sets were combined. And if we had another duplicate like 4, we would get 3 and 4, because all intersections are added. It's not like it's just the first occurrence or anything like that, because there is no first occurrence, because sets are unordered. So when you have an intersection, it's all of the duplicated values of the set 1 and the second set. The difference operation retrieves elements present in one set but not the other. We use the difference method. So over here we can have difference set is equal to set1 dot difference set2. And if we print difference set, we get 1 and 2. So in this case, set1 is calling dot difference, and so we're seeing the elements that are in set 1 but not set 2. So 1 and 2 are both in set 1 but they're not in set 2. So if we had a 6 in here, it would include 1, 2, and 6 because it's in set 1 but not set 2. And if we change this to a 4, for example, it would just be 1, 2 because 4 is in set 2. And if we reverse the order of this, it would be a completely different story. Here we get 5 because 5 is in set 2 but not set 1. All the other numbers, 3 and 4, are both in set 1, but 5 is only in set 2. The symmetric difference operation retrieves elements that are in one of the sets but not both. In Python, we use the symmetric difference method. So for set 1 and set 2, we can have symmetric difference set equal to set1 dot symmetric difference set2. And we can print this, and we get 1, 2, and 5. Because the symmetric difference of set 1 and set 2 gives us a new set that includes the elements found in either set 1 or set 2, but not both. That's because 1 is in set 1 but not set 2, 2 is in set 1 but not set 2, 4 is in both of them, so it's not including that, 3 is in both of them, so it's not including that. And then moving on to the second one, both of these are also in the others, and this one's not in the others. So it's kind of like a difference method, but we're checking for both of them. So with the difference method we had before, we're only checking for one of the sets, but for this one we're checking for both. Python provides several built-in methods to manipulate sets, such as add, remove, and clear. The add method adds an element to a set, the remove method removes a specific element from a set, and the clear method removes all elements from a set. So we could have numbers equal to 1, 2, 3, and we could say numbers.add 4. And this is no kind of index or anything, we're adding 4. This could be a string, whatever. Of course, there's no indices in sets because it's unordered. So we get numbers.add 4, we're going to add 4, and when we print numbers for the first time, we get 1, 2, 3, 4. Now, if we do numbers.remove, we can remove any of them. Let's remove 1, so that is just the number 1, and we can print numbers. Now, the first time we get 1, 2, 3, 4. The second time we removed 1, so now we get only 2, 3, 4. Now we can do numbers.clear and print numbers, and now we just get set. As we can see, we used add to add an element to the set, remove to remove an element, and clear to remove all elements. And this is just displaying set because if it showed an empty pair of curly braces, it would actually just look like a dictionary. So to separate these two, it just says set, and if you have an empty dictionary, it has the curly braces. So if you ever see empty curly braces, it's always a dictionary. Hello everyone, in this tutorial we're diving deeper into Python and exploring a fundamental aspect of programming, functions. So what are functions? A function in Python is a reusable block of code that performs a specific task. Think of a function as a machine in a factory. You give this machine some input, it does some work, and then it gives you some output. Functions can help us make our code more organized, more readable, and more reusable. They're also essential for reducing code duplication and improving the efficiency of our programs. The anatomy of a function consists of the def keyword, which is short for define, followed by the function name with parentheses and a colon. The function's code block, which is the specific task or tasks the function will carry out, is then indented on the next lines. The function can be called throughout your code after the function is defined. Remember, all the code that is indented under the def keyword is part of the function. Once your code stops being indented, it is no longer part of the function, and it's part of the global scope of your program. So the code inside of the function is called the function's local scope, and code outside of the function, which is where we used to write all of our code, is called the global scope. Let's create our first function. This function will simply print hello world when called. So let's just type def greet. It'll be a function that greets the user, 2 parentheses, and then a colon. Remember, when we add a colon at the end, it means that we're defining an indented block of code. And so when we hit enter, you should be indented now. If it doesn't automatically indent you, you'll just hit tab. Now inside this, we can just do something simple like print hello world. If we do another enter, it'll probably stay indented, but we're not trying to define our function anymore. So you can hit backspace to get outside of this function. You might notice that if we save this and run it, there is no output. Once a function is defined, we can call it using its name followed by parentheses. Let's call our greet function. Like I said, this doesn't do anything so far, but if we wanted to do something, we can type greet, and then the 2 parentheses. And now when we save this and run it, it prints out hello world. So when you run this code, Python defines the function, meaning it knows what to do with the function when it's called. But this print statement doesn't execute until we actually call the function. After the function is defined, then we called the function, resulting in hello world being printed to the console. We can run this as many times as we want. We can type greet again, and it'll print hello world 2 times. We could even do it 3 times if we wanted. You can do it as many times as you want. If you'll notice, this is similar to any other function we've used before, including the print function and the input function. And also, as you noticed, we used a function inside a function, the print function. And also, make sure you call all your functions after defining them. Otherwise, Python will not know what it is. For example, if I put greet above the definition, and we saved it and ran it, we would say name greet is not defined. This is because, like I said in the beginning, the code runs from top to bottom. It needs to define what this function does before actually running it. This is just like trying to print a variable before you created it. Always define your function first and then call it. A lot of times people define all their functions at the top of their file and then run them throughout the code below it. So we can make our greet function do even more. It doesn't have to just be 1 line of code. We could print a hi again. And now we get hello world and hi. And now let's just write a little simple program. We could just say number is equal to 10 and then do while number is greater than 8. We could say greet every time and then number minus equals 1. This will just decrement it by 1. And when we run this, we get it 2 times. And that's just because the first time it was 10, so it was still greater than 8, so it did this, it subtracted it, so now it's 9, and then it did it, right? And then it subtracted it again, and then it was 8 though, so it didn't do it the 3rd time, because 8 is not greater than 8. And so that was just a simple little program to show you how functions can be used, because instead of having to actually copy this code many times, and in fact, actually, if you had more of these, right, you had number 2 equal to 10, and we did that exact same thing, it would be very inefficient to repeat these 2 lines of code like this, because whenever you're repeating anything in programming, if you ever see repeated code, always think to yourself, is there a way I can fix this? And most of the time, the way to fix this is create a function and then just call that function multiple times. And by repeated code, I mean multiple lines of code. If you have 1 line of code, like a line where you're running a function, that's fine. You can repeat that, but don't repeat multiple lines of code unless there's no possible way for you to create it in a function or something like that. And I know that I'm kind of not even following my own rules here, considering the fact that I wrote these 2 while loops repeatedly, but it was just an example. Now, what if we want our function to perform its task with different values each time it's called? That's where parameters come in. Parameters are values that are declared in the function definition and get their values when the function is called. For example, the .split method takes in one parameter, and that's the string you're splitting it by. So in this case, it's just a space. Now let's create a function that takes in name as a parameter and prints a customized greeting message. We'll do def greet, and then inside the parentheses, we will type name, because we're specifying we want a variable passed in to this function. Inside the function, we can do some f-string formatting and just say hello name, just like this. And so what this is doing is when we actually run greet, we actually have to pass in a value now. So I can say Bob, and so it knows that since there's only one argument here, it knows that it's going to be name. And we are passing in name as Bob. And so now name is equal to Bob when we run this over here. And so it knows, okay, well, name was passed in, so I'm going to do hello, and then when we use this variable, it's going to be Bob because we passed it in here. And so we can run that, and it will print hello Bob. And we can run this again, Alice, for example, and then just run that again. Let me just expand this. We get hello Bob and hello Alice. Note that the name variable inside this function can only be accessed inside the function. It's private to this function, so if we created a variable called name outside of the function, there would be one variable called name and a different variable called name that's inside this greet function. In programming, we call these function variables that are local to the function. Variables that are available to the main scope of our program are called global variables. We've been using global variables the whole time before we started doing functions. When you want to modify a global variable while inside a function, we use the global keyword before the variable. So if we had a variable that was x and it was set to 10, and we wanted to set x equal to something like 2, we are not actually referencing this same variable. So if you want to actually edit a variable that is outside of our function, we actually have to use the global keyword at the top of our function and the variable name. And then we'll be editing this variable instead of a local variable. While it's sometimes necessary or convenient to use the global keyword, it's generally best to avoid using global variables inside functions where possible. Global variables can make your code harder to understand and debug because any part of the code can change their values, which can lead to unexpected behavior. Instead, it's often a better practice to just use function arguments like this and return values to pass data in and out of functions. So instead of just having greet like this, and then setting name equal to Bob, and then over here, name is equal to Alice, and removing this, just like that, it still works, but it's not a good idea. Because first of all, it's more code. We have to set name and then run greet, but also it's never a good idea to use global variables, because it can get confusing, and sometimes you might run the function when a global variable isn't existing yet. Of course, you could have a name variable that's equal to Bob, and then pass in name, just like this, and that could be okay too. So we could have a variable called Bob, and set that to the string Bob, and pass in the variable Bob as the name parameter, and that's fine. We can have as many parameters as we want, separated by commas. Let's create a function that takes in two parameters, first name and last name. So we'll do the same example before, but when we define greet, we'll actually have first name, and then a comma, and then last name. Now we can print hello, first name, and then last name. Now we can greet Bob Johnson, for example, Bob, and then a comma to pass in the next parameter, Johnson. Python knows the order of parameters, because up here we specified that first name is first, and so when we actually use these variables within our function, we know which one they are because they were passed in. So we're passing in first name, we passed in first name as Bob, so it goes up here, right? And then it uses it inside the function, so this will be Bob and this will be Johnson. And so the order does matter in this case. And now we can see that it says hello Bob Johnson. And I actually added a comma here for some reason. I don't know why I did that. Let's remove that. Okay, there we go. Hello Bob Johnson. And we can do it again. Alice Smith, I guess. Run that. And we get the two outputs, just like that, because we passed in two values. So now when we call the function with two arguments, it uses them both in the greeting message. So let's make a simple calculator that adds two numbers. Let's define add numbers, and we'll have number 1 and number 2. Inside this function, we will just print out the value of num1 plus num2. And down here we can actually just say add numbers and pass in 2 and 2. So this will output 4, just like that. And if we ran 10 and 300, we would get 310. And it's just adding these numbers together. We can do subtract numbers, and now we subtract the numbers together. Negative 290, we can do 10 minus 5 if we wanted as well. But the order matters, because if we wanted to do 10 minus 5, we wouldn't put 10 over here, and then 5 over here, because that would do 5 minus 10. And so the order does matter. But there is this thing called keyword arguments. Sometimes it's beneficial to specify arguments by their parameter name. So if you remember, arguments are when you're actually passing them into the function. Parameters are actually these values up here. Parameters are just the labels, or the variable names for the arguments. And so we can actually choose which one we access first and second and so on. And so with our previous example, where we greeted the first name and the last name, and we printed it, instead of having to do Bob first and then Johnson, we can actually specify which one we are accessing. We can actually choose the order. And you can also keep it in the same order when you do this as well. But keyword arguments are when you actually specify first name is equal to Bob and last name is equal to Johnson. These are the local variables for the greet function, and we're specifying which ones we're actually entering as the parameters. So if we actually had last name before first name, that is okay, because the function knows that the first item is actually last name and the second item is actually first name. So we're telling it which one each one is, instead of just having to go for the order. And so it could be any order, right? And we get the two outputs, and it still works, Bob Johnson and Alice Smith. With keyword arguments, the order of arguments, like I said, doesn't matter anymore, because we're explicitly telling Python which value belongs to which parameter. Functions can also return a value to the caller using the return keyword. This value can then be used or stored for later. Let's create a function that returns a greeting message instead of prints it. So when we have this, we can actually just say return, and then remove the parentheses. Now when we run this, we actually don't get any output at all. This is because return doesn't print. When you print, you're actually just printing to the console, and then you can't do anything with this anymore, unless you run it again and just keep printing it. And all this did before was just print. But what if we wanted to store this message in a variable? Well, like we did with other functions, we just do message is equal to greet, and then our function. And so it still doesn't do anything because we just have to print message if we want to see it. And so now we get hello Bob Johnson. So here we're capturing the returned value in a variable called message, and then printing that message. This goes to show that not all functions just print things. If you remember, the isNumeric function actually checks to see if a string is numeric, and it returns true or false, but it doesn't print it. The return value can be used, for example, in an if statement or something like that. This is far more useful than just printing something out of the shell. With the power of return statements, you can actually produce a result that can be stored in a variable or used in any manner. This result can be of any data type, and return statements are also a form of control flow. When the return statement's encountered, the function actually ends as well. So this means you can use a return statement prematurely to stop the function during its execution. Without a return statement, the function's result will be lost after the function is executed, and you won't be able to use that result anywhere in your code. But with the return statement, you can actually capture it in a variable, like I said, and use it for anything. So here's another example. We can do our add numbers example again, with num1 and num2. And the variable result will be a local variable that is equal to num1 plus num2, and we can just return result. And down here we can have a variable called sumResult is equal to the output of add numbers, or the returned value of it, 5 and 10. So this would be 15. And we can print sumResult, but we can also print sumResult plus 3 if we wanted. And we could even have another variable called another variable, and that could be equal to sumResult times 2, and this another var could be used for other things as well. And we didn't do anything with another var, but if we wanted, we could print another var, like that, and we get the 3 outputs. Beyond just regular parameters, Python also supports non-required or default parameters in functions. These are parameters that have a default value provided in the function definition. Default parameters allow the function to be called with fewer arguments than specified, using the default values for those that are not provided. For example, if you remember our greet example, we can just create a function that takes in a name and then an optional greeting message. So we can define greet, and in here, we'll make sure they enter their name, but message can be predefined as hello, and now we can just print f string formatting, message, and then name. We can greet Alice if we wanted, and we don't have to enter a message, because if we don't enter it, the function will set it to hello. But if we wanted, we can actually change that, and we can greet him with good morning instead of hello. And this would return hello Alice and good morning Bob. That's because the first time we didn't specify what message was. The second time we did. And so the second time we actually set message to good morning. If you remember, print statements are like this as well. For example, the print statements don't even have to have any arguments at all, and if there's no argument, the default is just to print a new line. Or if you did print something, there's another argument called end, and you can set that to something else. By default, it is a new line, but we don't have to enter this because Python already has that set as the default value. But if we wanted to change it for this case, we can set it as a space, and then do another print statement, and it would just say hi hi. So that's just like what these default arguments are. It's optional. You don't have to enter them, but if you want to change it, you can. In this tutorial, we're going to be making a simple calculator in Python. This is going to be a text-based calculator. You'll be able to enter any equation, you'll be able to do addition, subtraction, multiplication, division, and you'll be able to clear the screen, and this will teach you a lot about functions and stuff like that. So in our Python file, let's just start creating some functions for add, subtract, multiply, and divide. So we'll define add. You'll pass in num1 and num2, and then we can just return num1 plus num2. Next we will do define subtract, and they'll pass in num1 and num2. This is similar, we will also just return num1, but it's minus num2 instead of add, and then we'll define multiply, and we will return the multiplied value. Lastly, we will do divide 1 and num2, and this is going to be slightly different because we need this program to know that it can't divide by 0, because if we actually just comment this out and I try to print, let's just say, 3 divided by 0 or something, and when we try to run this, we get an error. And we don't want to get an error because the user will be confused and they'll stop using the program. We want no errors, obviously. So instead of doing that, instead of just giving it an error and making them rerun the program, we will check to see if it's 0. So we'll do if num2 is not 0, so we'll see if it's not 0, and we will return num1 divided by num2. So that's what would happen if it's not 0. And then if it is 0, meaning else, we will return error division by 0 is not allowed. Okay, so we have our functions ready, and now we can just scroll down and create a dictionary. So this dictionary will be a dictionary of operations. So we'll set this to operations, and the variable name is actually going to be all caps. So in programming languages, when there is a variable that is a final, meaning it is not changed throughout the entire program, it is all caps. Now in Python, there's no feature that allows us to actually make a variable uneditable further in the program, but it's still conventional in Python to make variables that are treated as constants all caps. Even though we're only treating it like a final variable, meaning we're never changing it throughout the program, we're still going to have an all caps just so that we know that it's a final, even though it doesn't exist in Python. If that doesn't make sense, all I'm saying is we're not going to change this, and so when you're not going to change a variable ever in the program, just make it all caps. Of course you don't have to, but it's conventional. So we'll do an addition sign, and we'll assign that to add. And so you might think, okay, well, what is add? What is that? We're actually referencing the function add up here. That's what that is. And so subtract will go to subtract, multiply will go to multiply, and lastly divide will go to divide. And so these are all the functions. And note that I'm not putting the parentheses here or anything like that. We're just putting the name. So now we have our basics done. So now it's time to actually create a loop that will allow us to keep asking them over and over. Because if you notice, a calculator allows you to keep asking it questions. It doesn't just stop working when you answer one question. So we don't want to have to keep making the user rerun the program. We want them to keep on asking it. And this will also help us make it so that if there's an error, we just ask them again. So this will actually be an infinite loop because they can just stop the program if they want. So we'll do while true, and we'll set equation to input, enter your equation. And we'll check first to see if the equation is clear. So I know that clear isn't actually an equation, but we are going to check if they want to clear the screen first. And we're actually going to pass on this. So if you know, pass is just a placeholder for when you're programming. If you don't want to enter what's in the if statement yet, if you just want to go to the next part of your code first. So we're not going to deal with this yet. So down here we will just process the user's equation. So for every operator, so an operator is just one of these if you're not familiar with that. So for every operator, that's just a variable we are just creating for this for loop in operations.keys. So if you remember, the .keys method for a dictionary gives you all of the keys, or the first values, of the dictionary. And so for every one of these, we're going to check to see if the operator is in the equation. So if operator is in the equation, then we will do stuff. And if you notice, you can use this operator variable because we're inside this for loop. For every iteration or movement through this for loop, operator is set to the next one. So the first time it's set to addition. The next time it's set to the string subtraction, and then the string multiplication, and then the string division. So this will run 4 times, always. If that is actually in the equation, then we will unpack num1 and num2 from equation.split operator. And so what this is doing is we are splitting the equation where the operator is. So we're not including that. We are splitting this. So if we had a string, right, and it was 1 plus 1, the .split method splits the string. So it takes this out and splits the string into a list. So this is a list of 2 items now. And so we're only assuming that the user will enter 2 numbers so far. If they entered more than 1, we would get an error here, but we're going to learn about try and accept in a minute or two, which is a feature that will let us check for an error, and if an error happens, then we'll do something else. But for now, we're just going to unpack num1 and num2. Because if you remember, you can unpack items in a list or tuple into variables. So when you split this, for example, if I gave the 1 plus 1 example, when we split this, we will put the first item into num1, and then the second item into num2. So that's what the unpacking is, if you remember. Then we'll set both of these to the float version of num1. And if you remember, we did this with int, but we want to actually set this to float so that the user can enter, for example, 2.3 plus 4.5, or something like that. Because if you put a dot here, when you're trying to convert this to an integer, you would get an error, because there's no decimal point in integers, so that's why we're setting these both to floats. And so here's where the confusion will come in with the error. So like I said, we're going to learn about a new feature in Python. 1 plus 1, it's working so far. We didn't actually do an operation with it yet, so it's working completely fine. But if we have multiple, this will split the string into 3 items. And here we get a value error. Too many values to unpack. And it expected 2 because there's only 2 variables here. So in this program, we're only going to allow them to enter 2 values. So we can easily fix this by doing a try and accept statement. If I comment all of this code out to show you what a try and accept statement is, let's just scroll all the way down, and we can say try. You can enter code in here, and if there's an error, meaning accept, then we'll do the error code. And so by try, we mean, okay, well, let's try it. Let's see if it'll give us an error. If it doesn't give us an error, meaning we run all the code that's in here, we'll skip the accept. So it's kind of like an if-else, but for errors. And so if we had, if we just tried to convert this into a float, right? If we try to convert this to a float, we would definitely get an error. And so, for example, instead of getting a big error, we could say something simple like an error occurred. Because instead, if we actually ran this code and just did x equals float and then a bunch of random letters, we'd get an actual big error, and the user would not want to see all this because they'd be really confused. But if we use the try and except statement, we can just tell them an error occurred, because we are customizing what happens when an error happens. And so this is also another form of control flow. And so we're doing this inside our program. There could be an error with this, right? Too many values to unpack if they did 1 plus 1 plus 1 instead of just 1 plus 1. Or with this, there could also be a value error if they entered something weird in between the numbers. So maybe we did 2 plus 2, right? It says you can't convert the string to a float because this isn't a float, so that doesn't make sense, right? So it gives us a value error. So all three of these lines are prone to value errors. To solve this, we'll just do try, and then indent this code block, and then except, and then we will do something else. Now there is a better way to do this. Instead of just saying accept, we can actually choose which kinds of errors to accept. So let's accept only value errors, because if there's a different kind of error while we're writing our program, we're not going to know what the error actually is, because if we just accepted all errors, we would just know that some kind of weird error occurred. But if we only accept value errors and make so that value errors are okay, then we'll know that all the other errors are our fault and not the user's fault. So here let's do something else, right? Let's tell them that they entered an invalid input. Please be sure to enter only one operation, like 1 plus 1 and not 1 plus 1 plus 1. And make sure we actually say continue after this, because we're going to be writing more code after this, but we don't want it to print this and then continue on with the operation, because that wouldn't work. It would just print this and not do anything about it. So we're going to continue back to the top of the loop and ask them again. Okay, so that's doing well. Next, let's actually just test this and see if it works. So we can enter 1 plus 1, that works. 1 space plus space 1 works. 1 plus space 1 works. All variants of spaces work. Let's try something that wouldn't work, like 1 plus 1 plus 1. Okay, that works. Good thing. Now let's test to see if the float conversion won't work with the value error as well. So we'll do 1 at or hash or anything really. 1 plus 1, right? Okay, there we go. So everything is working completely fine. So that's good. Now we actually have to calculate the answer using the correct operation from the dictionary. So this code that I'm about to write might seem really confusing, but don't worry. It'll actually make sense once I explain it. So we'll just type answer, and we'll set that to operations, and then we'll reference the operator. So what this means is we're setting answer so far to the operator of operations. And so we could just say operator of plus, right? But we are checking to see every single operator. So that's 4 of them. And so the first time this will be plus, the second time operator will be minus, the third time it'll be multiplication, and the fourth time it will be division. And so we don't know which one it is at this point in the loop, so we'll just say operator. And so what this is actually, this returns the function. So with this, we don't have to actually run the function again outside of this line, like, for example, add or something like that. We don't have to do all sorts of if statements. All we have to do is just treat it like a function, so pretend that this is add or subtract or multiply, right? And we'll just pass in num1 and num2. So if this still is confusing to you, what this is saying is we're just getting whichever one this is. So if operator happened to be minus, we would be referencing minus, which would end up giving us subtract. And so Python would evaluate this as just being replaced with subtract. And now this actually looks like the function we wrote. But we don't know which one we're at in the for loop, so we enter this. Now we will just print out the answer so that they can finally see their answer, and then we will break. So we will exit this for loop because we don't need to check for more operations because there's only supposed to be one and we already calculated it. So we can break out of this for loop. And so now we can actually just test out our code. 1 plus 1, okay. 1 plus 1 with spaces works. 3.4 plus 1 is 4.4. 3 times 3 is 9, okay. 2 divided by 2 is 1, all right. 4 times 4, 8 minus 3, all right. Everything is working very well. But now let's actually see what happens if we were to write an equation without either add, subtract, multiply, or divide. So this loop would go through it 4 times, and it wouldn't find any of these in our string. Well, what if we did that? We just typed 1, right? Okay, right now, it's actually pretty okay. We're just repeating the loop and asking us again. But we should actually display the user some information about why it did that, right? So before this for loop, let's create a variable called count and set that to 1. And after every iteration, it will add it by 1 to see which one this is currently on. And so after every iteration, of course, we will increment count by 1. And before this, we will check to see if the count is 4, meaning if the count is divide, but this if statement has clearly not executed because we didn't break out of the loop, so it moves down because this is false, so none of this was executed, so we move down to here. And now we can check if the count's 4, meaning it's divide. Then we will print invalid input, please enter a valid equation. This is because they entered none of these. Alright, so let's test this out. 1, okay, that's good, so it works now. Now our last bit we need to add is the clear feature, because right now it doesn't do anything, and we just pass, meaning we just don't do anything at all in this if statement. So how do you clear the screen in any terminal window? So let's just get out of this program for a second. If you are on a computer that is Unix-like, meaning you are macOS or any Linux distribution, typing clear in the terminal window will just clear the screen. And on Windows, it is CLS, but of course that's not working for me because I'm not using Windows. So I type clear, okay? And if we want to enter terminal commands, most of the time, if you haven't changed the shell of your computer, most of the time you're using either bash or ZSH. These are scripting languages that are used by the terminal window. If you don't understand this, that's completely fine. But the command in this language to clear the screen is clear. If we want to access this scripting language within Python, we will actually have to import a module called OS, stands for operating system. And so in here we can just say os.system, so this means we're ready to enter a command, and inside this we will pass in a string that contains the command we would like to enter. And so I'll type clear. And I'm pretty sure on Windows you'll type CLS, but I don't use Windows, so I can't be completely certain that that's how os.system will work on your computer. But for me, I'll do clear. Alright, so there we go. You might think that this works, but we actually just have to continue through the loop first, because otherwise it'll still go through here and it'll say invalid input. So we have to continue back to the top of the while true loop. Okay, so let's enter this. We can enter a bunch of random stuff, right, and then type clear, and it cleared our screen. Nice. Okay, so this is our simple calculator app, and it's very simple as you can see, but it taught you about functions and their parameters. You got a refresher on some basic mathematical operations. You used a lot of if statements, a dictionary. You learned about how constants are in Python, even though they technically don't exist, but we can treat them as constants. We learned that you can actually access functions through a dictionary by actually referencing the item and then just calling it with the parentheses here. And we learned about try and accept. So if you took anything away from this, I hope that you took try and accept, because try and accept is the newest thing we have learned about so far in this course. So if you're liking this Python course so far, please consider subscribing to my channel. It would really help me a lot, and it would motivate me to keep making more videos like this. In this tutorial, we're going to unpack the magic of *args in Python. Args is a special syntax in Python that lets us pass an undefined number of arguments into a function. This means that there can be any number of arguments passed in. For example, the print statement can receive any number of arguments. If you enter multiple things, like hello, separated by commas, it will print them all separated by spaces, and I could do as many of these as I wanted. And as you can see, it just does them all. There isn't a limit to how many arguments you can pass in. This is a prime example of args. To put args into context, let's first do a quick recap of how functions work. So if you remember, a function is a reusable piece of code, so we define it using the def keyword followed by the function name, parentheses, and then a colon. Inside these parentheses, we can typically specify our function parameters. So, for example, we can set name here, and we will just do an f-string formatting, hello, name. And you've seen this example in the previous videos. So in this example, the greet function just has one parameter, name. When we call this function, we provide an argument for that parameter. So if I say greet world, it'll say hello world. So how does args fit into this picture? It allows a function to accept more arguments than the number of formal parameters we have declared. So this means that we can call the function with any number of arguments, including 0. So when you use this star, the parameter doesn't have to be called args, so it's typically called args, but it doesn't have to. And it stands for arguments, but just like normal parameters, you can call it whatever you want. So I can call this names. But just remember that if you want the function to be able to have an undefined amount of arguments, you have to put the star in front of it. And also, it's good to note that it's conventional to say args, but for this example, I'm going to do names to make it more easy for you to understand. So here we have, we'll define greet star names, and so for every name in names, so this will iterate through names, since there's a possibility of infinite arguments really, the star names parameter will end up being a tuple. So we can iterate through that with a for loop. So for every name in names, we'll print f-string formatting, hello, and then the name. So name is equal to the current item in the tuple names. Here we'll just say, we can say world, and we can add another one, John, and then these two names from the previous example, John and Alice, and it'll do it 3 times because we entered 3 of these, and so for every name in names, it did this. And we didn't specify anywhere in here how many arguments it would take. We can have as many of these as we wanted, and it wouldn't even care. So as you can see, args, or star names, enables our function to handle any number of arguments gracefully. So usually you'll actually just see args, like I said, because it's conventional, and it would just look like this, and it does the exact same thing. It's just whenever you see args, that's what it means. It stands for arguments, so it's just for every name in all the arguments they passed in, then it's like that. And so I tried to explain this first by using names, and now I'm explaining it by using arguments. Because sometimes, at first, people are confused by what args actually means. And so I figured that if I explained it with names first, then it would make more sense, because it's for every name in names. And the user, or programmer, can just enter as many as they want. So we could even do this with a calculator. So if you remember our previous video where we made a whole calculator, we expected the user to enter 2. And there was no way to figure out how many they would enter, so we had to just make it only 2. But now we can actually do something like define add, and we'll do star numbers for this example, or you can do args. And we're going to have a variable here, a local variable called answer, and that can be set to 0 at the start. And then for every number in numbers, so for every item in this tuple, we will just add answer by number. And so if we return this, we can return answer. We can just print the value of add, and then 1, 2, 6, and 1, maybe. So this would equal 10, and if we ran this, it would say 10. And we never specified how many arguments. We could go even further. We can do 5, 5, 5, 5, 5, 5, 5, 5, 5, as many as we wanted, and it would add them all up for us, and it would work completely fine. And so this is how we would actually fix that program and make it work better. So why use args? As you've seen, it provides flexibility. With args, our functions become more dynamic and adaptable. This can be incredibly powerful, especially when we don't know ahead of time how many arguments a function needs to accept. Args can be used in combination with regular function parameters as well. When using both, we must put the star args after the normal parameters to avoid a syntax error. So let's go back to our greet example. We'll define greet, and we'll have a greeting, so they can choose if it says hello or good morning or whatever, and then we can just do args. And so for every name in args, we will print the f-string formatting of greeting. So there's only going to be one greeting. We're not having infinite arguments for greeting and args, so we'll just print the greeting and then print the name. And now we can greet with the greeting, so we have to specify the greeting first, because if we just did John, and Alice, and Paul, for example, right? If we did this, it would say John, Alice, John, Paul. If there's only 2 names, because John is the greeting, so we have to make sure that we're actually specifying the greeting. And so we'll do hello, and so this is the greeting because it's first. So as I said, Python knows the order. So since hello is first, it knows that that's the greeting. And now when we run this, we actually just get hello John, hello Alice, and hello Paul, because it's greeting and then all the arguments. So here greeting is a regular parameter, and args is the args parameter. So in this function, only one greeting can be used at once. So you can only have one star parameter or args parameter per function. Because if you tried to do multiple, you would get a syntax error, but the reason for this is because if you had multiple greetings, Python wouldn't know which arguments are for greetings and which ones are for args. So we're only allowed to have one of these. So when we call this function, the first argument is used for the greeting parameter, and the rest are passed as arguments to args. That's why you have to have args last, because Python will not know which one. And so it can see, okay, well, if we had another parameter called x, it would know that this is greeting, this is x, and all the rest are for args. The star in args is not part of the variable name. It's a special symbol in Python known as the unpacking operator. It allows us to take a collection of items and unpack them into individual elements. When placed in front of an iterable object, like a list or tuple, in a function call, it breaks them down into separate individual arguments. So that's why star args works in Python parameters, but it's also used in other places as well. We can use args to unpack sequences when calling functions. Let's say we had a function called add, and it added a, b, and c, and it just returned that, right? Return a plus b plus c, okay? We had a list. Maybe it was entered by the user or something that was using the program, and they're 1, 2, and 3. And so we can actually use add, but instead of having to go through every single one of these items, right? So instead of saying add numbers 1, and then the second item, and then the third item, right? Instead of doing this, there's actually a shorter way to do this. We can simply unpack numbers into this parameter. So we're doing this in a slightly different way than before. Instead of unpacking all of the arguments, we're unpacking the list into the arguments of this function. So we're going to unpack 1 into A, 2 into B, and 3 into C. And so to do this, we simply just type star numbers, because we're unpacking all the values, right? And so that's the same as when we had a function, right? We just had args, so for every argument. And so when we actually do this, this is unpacking all of the arguments, and now we can use it for every arg in args, then we can do stuff with it. And so this is just doing it in a different place, right? So we're unpacking numbers into every value. And so if I were to print star numbers, we would get 1, 2, and 3, because we're printing each item separately. So you can print each item in a list with a space in between it without having to use a for loop or anything. So this just simply takes each item and then puts it in whatever you're doing, right? So in this function, it puts it for every single argument. With the print statement, all it did was it unpacked this list and put it into the first argument in the print statement, the second argument, and the third argument. And so with add numbers, we actually have to surround this with a print statement because it just returns a value, doesn't print it. We get 6 because we added 1, 2, and 3. So in this example, the list numbers is unpacked by star numbers into separate arguments for the add function. The star made it so we didn't have to look at how many items were in the list. We just used the add function and unpacked all the values from numbers into each parameter. Args can only collect positional arguments, not keyword arguments. If you remember, positional arguments are when you have a function and you just enter the values. Keyword arguments are when you actually tell which one you're entering. arg1 and maybe arg3 is next, and then arg2, but args can't use keyword arguments. Because if we try to do this, maybe with our greet example, typing greet name is equal to John will just give us an error, because there's nothing named John, right? So if we run this, we get an error. And if we were to do names as well, this would still not make any sense, because it can't use keyword arguments for args. So if we try to use keyword arguments with a function, we will just get an error. And as you can see, trying to use a keyword argument here causes a type error, because our function only takes positional arguments. In the next section, we will learn about something called kwargs, which stands for keyword arguments, and it has 2 stars, which will help us fix this problem. let's talk about kwargs in Python. **kwargs is a special syntax in Python that allows us to pass an undefined number of keyword arguments into a function. So it's just like args, but for keyword arguments instead of positional arguments. And also, just like args, you can call the kwargs parameter whatever you want, but kwargs is conventional because kwargs stands for keyword arguments, while args stands for arguments, or positional arguments. So let's define our greet function, and it'll take kwargs as an argument. Inside the function, we'll iterate over kwargs.items, so for every name and greeting in kwargs.items, then we will do stuff. But first of all, I just want to say, kwargs.items, if you remember, returns a list of key value pairs. Kwargs is treated as a dictionary. Unlike args, which is treated as a tuple, this is a dictionary. Kwargs.items, the .items method for dictionaries, returns a list of key value pairs. So kwargs.items, for example, if we were calling greet and it was arg1 is equal to hello, and then arg2 is equal to world. If that's the case, then kwargs.items would actually return something similar to this. As you can see, this is a list containing tuples, and for every tuple in this list, the first item is the keyword arguments label, and the second item is the value. And so for every one of these items, we will get the personalized greeting. Okay, so to explain this a little bit more, like I said, this gives us a list of tuples, where each unique tuple contains a key value pair. So in this case, the key is the name, the value is the greeting. Printing kwargs.items will actually show you what I just showed you before. So if I just decided to greet John is equal to hello, and then Paul is equal to welcome, we get this list of tuples, and the first item is the label, the second item is the value. And so as you can see, in this for loop, we are iterating through a list that contains tuples. This section, that is called name, greeting, is actually a tuple, so you could write it like this, but it's just not conventional. But this is a tuple. And so every time we iterate to the next tuple in the list, name will equal the first item in the tuple, and greeting will equal the second item in the tuple. In this program, the keyword argument's name is the person's name, so that'll be this, and greeting is the second value. So now we can actually just test this out and try to greet John, and that'll be hello, so you'll say hello John. This one will be Paul, and that's equal to welcome. George is equal to hi. And now after calling greet, you can see that we get all of these desired results. Hello John, welcome Paul, and hi George. And we had no idea what these parameter values would actually be. They are just the name every time we go to the next value. If we ran this again but printed kwargs.items, we'll see that when we iterated through this, we got John and hello for the first one, so we printed hello John, just in that reverse order. The next time we got Paul and welcome, so we printed welcome Paul, and then hi George. Kwargs can be used in combination with regular function parameters and args. So when used together, these parameters must be in this order: regular parameters, args, and then kwargs. So let's pull up our exact example again, but let's change some things. So we'll define greet, and we can add args and kwargs, but in this case we'll name it names and greetings. And for every name in names, or args, so this is the args version, we will check to see if the name is in the greetings, or kwargs. And if it is, then we will greet the person normally. So here we're going to print greetings and the current name inside this dictionary, and then the name of the person. And if not, we will just print a default greeting, and hello will be the default greeting, and it'll just say hello name. And if this part's confusing to you, we are just referencing the name of the person in the greetings or kwargs dictionary. And now we can greet these people. I'm going to show you examples with people that do have their respective greetings and other people that don't, so that we can get this line to show up. So we'll greet John, Paul. So these are the asterisk names, George, and let's do Alice. And now we'll say John is equal to welcome, and Paul is equal to good day. And these other people, George and Alice, don't have specific customized greetings. And what this is going to end up doing is, once we run this, it'll say welcome John, good day Paul, and hello for both George and Alice. In this case, John and Paul have their respective kwargs, or keyword arguments. So if the name is in the kwargs, so we have for every name, so for every one of these, then we will check if one of these names is one of the dictionary's keys. The dictionary is called greetings. And so if that name was given, so over here, if it was given, then we print the customized greeting message for the person. And if we didn't give a respective kwarg, then we will just print the name instead of giving them a customized greeting. And so that's how that works. For a more simpler example, args is represented as names, and kwargs is represented by greetings. Each name is checked against the greetings dictionary. If a specific greeting is provided, it's used, otherwise a default greeting is given. We can use the double asterisk operator, or the dictionary unpacking operator, to unpack dictionaries when calling functions, just like we use the single star operator to unpack lists and tuples. So let's define a function that takes two arguments. It'll be introduce, and it'll take a name and age. No kwargs or args in this case. And let's print my name is name, and I am age years old. Now let's create a dictionary that matches the function's parameters. Person, that's the dictionary. It's equal to name, and that's John, and then their age is 30. Now let's unpack the dictionary into the function using the double asterisk from kwargs. So introduce, and then we will unpack person. And so here we get, my name is John and I'm 30 years old. In this example, the dictionary person is unpacked by asterisk asterisk person into separate keyword arguments for the introduce function. This shows that double asterisk is like the single asterisk, but instead of unpacking singular elements, like elements from lists or tuples, or elements meaning positional arguments from a function, the double asterisk unpacks key value pairs, like dictionary items or keyword arguments, treating the keyword argument as the key and the parameter value as the value in the pair. Now I know I'm trying to explain every time how the unpacking is working, but all you really have to know is when you're trying to unpack something, right, you just say, okay, we want to unpack person, so what I think in my head is unpack person, and that's it. Basically, we are just taking this packed dictionary and unpacking it, and as long as it works, then we have successfully unpacked them. But I explain what the unpacking actually does under the hood, just so that you can understand it first. Remember, kwargs only collect keyword arguments, not non-keyword arguments, meaning positional arguments. If we try to use positional arguments with a function that only accepts kwargs, we will get an error. Let's use our greet example with kwargs. If we were to just say greet John, we'd get an error, because kwargs requires keyword arguments, so you would have to have something here, like x is equal to John or something, but you have to have a keyword argument. And so if you wanted to just type something like this, with only positional arguments and no keyword arguments, then just use args. And if you're confused about which one you should actually use when creating your functions, if you don't know how many, so let's just pretend that this doesn't exist here, and pretend that we already have a function called greet, okay? If we wanted to make a function that had no idea what the keyword arguments would be labeled, so x, and we also had no idea how many, you would use kwargs. Because with kwargs, you can actually access the labels to each of these arguments. But if you're not going to have any use for actually looking at the label of these, then just use args. Because if you still have no idea how many there's going to be, you can still use args, just there's no need for kwargs. In this video, we're turning our attention towards an important aspect of writing robust and bug-free code, handling exceptions with try and except. Exception handling is a critical concept to grasp in any programming language, and Python is no exception. We did briefly go over try and except in the calculator project, but this video includes more information on it. So what exactly are exceptions? In programming, an exception is something that occurs during the execution of a program and disrupts the normal flow of its instructions. So that's just basically an error. This might occur when you're trying to read a file that doesn't exist, or trying to convert a string to an integer that can't be converted, for instance. And to deal with these unexpected events and prevent our programs from crashing, Python provides us with tools to handle exceptions gracefully. And that's what we're going to explore today. Now you might be thinking, well, why not just write bug-free code? If a user enters something that's not a number in a program where they're supposed to, you might get an error when trying to convert it to an integer from a string. So, to handle the error, you might just ask them again. The primary tool for handling exceptions in Python is the try except block. Here's how it works. You put the code you want to try executing inside a try block. If an exception is raised or an error occurs while the try block is executing, it immediately transfers to the except block. Let's demonstrate this concept with a simple example. So here we can say print x, which is a value that doesn't exist, right? We don't have this variable. And when I run this, it says name error, x is not defined. But what we could do is we could put this in a try and except block. So here I'll type try, and then the indented code will be the code that you'll try to execute. And then the except block will be what happens if an error happens. So we can say an error occurred. And when we run this, we get an error occurred. So in this example, we tried to print a variable x, which we haven't defined yet. Normally, this would raise name error and stop the execution of our program. However, because we've enclosed our code inside a try except block, when name error is raised over here, it immediately transfers to over here. So instead of crashing, our program prints out an error message and continues with everything else. So what would happen if I were to print end of file and we got rid of try and except, so we just commented out try, unindented this. Whenever there's an error in Python, it immediately stops and nothing else after the error is executed. But when we use this try and except block and we indent this code here, just like this, when you get an error, you can actually just use the except so that the error doesn't interrupt the program and continue to the end. So here we get an error occurred, end of file. So this allows our program to handle unexpected errors gracefully, providing useful feedback or even recovering from the error rather than simply crashing. Now, of course, this example doesn't really make sense because no matter what, x is not defined. But there are sometimes in your program where there are expected errors, mainly from things like users entering wrong values and things like that. Python has several built-in exceptions that you can catch and handle. For instance, when trying to divide by 0, raises a zero division error, and trying to access a non-existent element in a list raises an index error, and so on. In a try except block, you can catch specific exceptions and handle them differently. Here's an example. So let's try some things. And under this print statement, we'll set x equal to 1 divided by 0, which will raise a zero division error. And here we can print non-existent variable, because it doesn't exist. And then we will print this is the end of the try block. Now we can accept, but instead of just accepting all errors, we can only accept zero division errors if we wanted. And if we got a zero division error, we could print you can't divide by 0. And we can have another accept block, so we can have multiple. We can also accept name errors, which happen when you try to access a variable that doesn't exist. So we can say that variable doesn't exist. In this example, when the zero division error is raised, the execution immediately transfers to the first accept block, so that's the zero division error one, and you can't divide by 0 is printed. So when we run this, it only says you can't divide by 0. The name error that would have been raised by trying to print this non-existent variable is never reached because the zero division error was raised first by this line of code. So remember, once an exception is caught, the rest of the try block is skipped and Python moves on to the correct except block. So this name error will never get executed. Before this, we just typed except. So only typing except accepts all types of errors. But this isn't always a good thing. For example, if you have a program where the user is supposed to enter a number, but enters a letter, your program might crash because it'll try to convert the string to an integer but can't, so then you'd use a try and except block and ask the user again in the except block. But if you only typed except, it would fix the user problem, but if you accidentally created any unrelated errors in your try section, you wouldn't know what caused it. So it's always a good idea to accept expected or even intended errors, and all other errors should help you fix your program. So you can include multiple errors in one accept statement as well. So if we wanted to accept both name errors and zero division errors, so what you might think you'd do is you'd say name error and then also zero division error, but you have to put them in parentheses. Okay, so now we'll accept both of these errors, and if either one of these errors is raised, then we'll print an error occurred. So now this print statement will print if you encounter a zero division error or a name error, but nothing else. You might be wondering how you can actually find these errors and type them in your accept block. So if you're wondering this, let's just say we had a zero division error, but you didn't know what it was called, and you ran x is equal to 1 divided by 0, and let's say we ran this, right? So here we get an error, and you might think, okay, well, let's accept this because I want to use a try except block on here. So you might think, okay, well, how do I accept this? At the bottom here, it always will say the type of error, and then a colon, and then what caused the error. So here you can actually just copy this and put it over here. And so we can say try x is equal to 1 divided by 0, and then accept, and then paste that, and then do whatever you're trying to do. Most code editors highlight the color in a different color than most other things. In VS Code, with my current styling, it highlights all errors with this green color, but it's different for everybody, and just know that it changes the color. If it doesn't change the color, if it's like white or something like that, it's not a correct error. And so it actually auto-completes this here, so I can actually click that, and it works like that. Sometimes you have code that must be executed regardless of whether an exception was raised. That's where the finally block comes in. Code inside a finally block always runs, whether an exception was raised or not. Let's look at the code from our previous example. We can add a finally block after the accept block. So finally, we can print this line always runs. And so here we get an error occurred, and then this line always runs. This one will always run whether an exception was happened or not. So if we comment these out, these error-prone lines, it still runs because the try block was executed. So both times it can run. Every single time, no matter what, the finally block will run. This is useful for when you need to clean up resources or execute code that should run no matter what else happens in your program. And you might be wondering why this actually exists, because can't you just type code immediately after the accept block? Yes, you can. Typing code after the try and accept like this will do the exact same thing as putting it in a finally block in most cases. So here's an example of a case where this doesn't work. Let's say you're making a function that returns a value. Let's say we're dividing a and b, and we try to set result equal to a divided by b. And then we want to return result. Then we can accept a zero division error. So this is another way to write the code we wrote in our calculator app for the zero division. So we'll return can't divide by 0. And now we will say finally. We can just print something like this will still run. As you know, return statements automatically get out of the function. They terminate the function. But even though there's this return statement, the finally block still gets executed. So here let's print the value of divide, and then we'll just divide something like 6 divided by 3. And then down here we'll do the same thing, but we'll divide 6 divided by 0. And so both times we get this still runs. So what happens in this is it tries to do this, and if it works, then it returns it. And then if it doesn't, then it returns can't divide by 0. But what this finally block does is, first of all functions return as the last thing. Returning is the last thing all functions do. So this finally block actually executes before the value is actually returned to these callers here. But the line return result was actually ran, right? It was still run, but you saw this first because you actually get the returned value last. And here's another example of using the finally block in a good scenario. So we can try to set x equal to 1 divided by 0. And here we can just accept type errors. This isn't going to throw the exception type error, but we're just going to say a type error was caught. But then in this finally block, we can print this is the end of the try except. Okay, so that's the end. And then down here, we can print this might not run. So do you want to know what this is doing? In this try over here, x is set to 1 divided by 0, which will raise a zero division error, not a type error. So this except block is skipped, but since there's no except block actually accepting zero division errors, it stops the program. But remember, the finally block will always execute. So this finally block executes before the program is done. So here we get, this is the end of the try except, and then the last thing was ran, right? So this is always going to run, and this won't because the program stopped before here. So this is useful for catching errors that are not intended. Just like I told you before about how you should always type the right error that you expect. This is useful for if you're expecting errors that you don't know what they're going to be, or that you don't even expect at all. So the code at the bottom that I deleted will not be executed because of the zero division error, because it was unhandled. We didn't handle that error. The finally block is a powerful tool in exception handling for these reasons, and using it appropriately can make your code more robust and reliable. There's one more block you can use in exception handling, the else block. An else block associated with a try except block is executed if and only if no exceptions are raised. Here's an example that includes an else block. We can try to set x equal to 1 divided by 2, and then we can accept zero division errors. So this will not throw a zero division error. And then here we can type else and print everything went fine. And so we run this and it says everything went fine. That's because the zero division error was never thrown. So the else block runs. So remember, the else block only runs if none of the except statements or errors were thrown. Hey everyone, today we're going to be talking about reading error messages. So in Python, error messages can look a little bit intimidating. And when you encounter one, try not to get frustrated and just forget about what it says and just look through your code and frantically try to change things. Because in this video, I'm going to teach you about what the error messages actually mean. So let's say we just had a basic error that was saying, print x, and x doesn't exist yet, right? This first line doesn't really matter right now. But here we see that it's telling you where the error was found. So it was found in the file, and then this gives you the full file path to your file. So if you're not familiar with file paths, they are essentially where the file is located on your computer. And so at the end it tells you the name of the file, tutorial.py. That's what my file is called. And this is only useful if you have multiple files in your program, because then you'll be able to figure out which file the error came from. Then it tells you what line the error was found. So if we had multiple lines, and we just printed something like print start, and then we printed end, this would say line 2 in module, because it's line 2. So we go look, okay, line 2 is right over here. Okay, so let's see what we can do. And then in module, that's just saying that it's in your Python file. And the second to last line is essentially just the exact code that caused the problem. And then lastly, down here it tells you what type of error you encountered, and then it tells you what's wrong or how it caused this type of error. And now it says name x is not defined. A lot of times, if it's just a simple error, I just look at the last line. I only look at all this stuff if I actually need to, but this last line can really tell you, or at least the last two lines, can really tell you what happened. Now let's give an example where most recent call last actually makes a little bit more sense. So the most recent call last statement in a Python error typically refers to the order in which the calls or operations were performed. So with the most recent one being the most recent call last. And so in Python, when an error occurs, an exception is raised, and if this exception isn't handled using try or except, the program will terminate and print this traceback. So a traceback is the error message that helps you fix the error. So instead of just crashing, it gives you an error message or a traceback. And so this tries to break the sequence of events that led to the error, from the initial call to the line of code that finally resulted in the unhandled exception. So right now we only have one step in the whole program that was creating the error, but here's an example of more of them. So if we had a function and we defined function 1, and we just called function 2, and then we defined function 2, and then in this one we called function 3, and then in here we defined function 3, and here we just decided to raise an exception. So you can raise exceptions on your own. So actually, if I just show you this first, I do raise exception, and then in parentheses, whatever the exception is. So I could even create this as an error, right? And this says traceback, this is where the error was, and it's just called an exception because it doesn't know what it's called. So it's we're just raising an exception, and it's called just a bunch of random letters like I just typed. So you can create your own errors. You can raise your own errors. This is typically used if you're making a module that you can import, like for example, import random, if you remember. They can create their exceptions that will tell you what's wrong and things like that. But anyway, if we go back to our code, we can just raise an exception. An error occurred. And then now we can finally just call function 1. And here we get a bunch of other steps. So this entire thing is a traceback. So this is the most recent call. So the first time when we called function 1 at line 10 over here, then because of that, right? So the first time it says in module, that just means your Python file. But now the next step in the error was in function 1, the function 1. So we can look at here, and it was function 2 when function 2 was called. Then when function 2 was called, function 3 was called, and then in function 3, then we finally raised an error. And so this can actually be a little bit demonstrated better if I don't decide to raise an error. I could just say x is equal to 1 divided by 0 with our classic 0 division error. And so the reason I decided to make all these functions was simply because I wanted to show you how these can stack up. And so when you see this stacking up, most of the time, you're only going to look at the last line or the last section. The other parts are most likely not your fault, although sometimes they are, but the upper parts are sometimes lines that are even from modules like random or any module that you import. But the last line is typically the line that you wrote that caused the error. And so the error is division by 0. But the reason we get these is because we called function 1, which called function 2, which called function 3, and function 3 ran this. That's why it raised this error. And so all I'm trying to tell you here is when you get an error, look through it and look through which ones you see. For example, if you see module or a function that you created and not a different module was created when you imported something, look through them and look at what they did. And if all else fails, you can simply just copy this and search it on Google or something like that. In this tutorial, I'm going to talk to you about classes in Python. You can think of classes as blueprints that define new data types. As you know, there are data types like integers, strings, booleans, etc. All the data types you know are very useful, but classes make it so we can model more involved concepts. For example, think about a person. A person is not a dictionary or list, it's something else entirely. We can use classes to define these new types and model real concepts. To define a class, we use the class keyword followed by the name of the class. Classes typically use a different naming convention than variables and functions. In Python, classes don't use snake case like we're used to. Instead of being all lowercase and using underscores, they use the Pascal naming convention, which is like this. As you can see, each word's first letter is capitalized. Just like loops, if statements, and more, we add a colon at the end and then indent all the code inside of the class. Inside this indented code block, we can define all the functions that belong to the class. For example, let's model a human. So modeling a human with a class is a common way to teach classes in programming. Let's just type class human. And now let's define some of the functions that belong to the human class. Let's make a function that will be for moving a human, like walking. So we can do def, move, and then we'll type self. I'll go over what self means later in the course. And inside this, we could just do something simple like print I moved. Let's make another function called eat and pass in self as well. And then this time we'll just say I ate. Alright, so that was a very simple example of defining a new type, or defining a class. So with this we can create new objects. In programming, an object is an instance of a class. An instance, in Python, is an object created from this class blueprint. You can think of a class as a blueprint, and an instance of an individual object is built from this blueprint. In our program, we could create as many humans as we want. To create the object, let's type out the name of the class, and then call it with parentheses, almost as if it was a function. But this just creates the object and then returns it. We have to store this human somewhere. So let's type human1 is equal to a new human. So when we run this, we don't get anything, but that's because we haven't done anything or printed anything. With this new human object, we can type human1 and then a dot. As you can see, the methods we defined earlier, eat and move, both show up in the auto-completion in VS Code. This is just like any other data type, like strings for example. Strings have their own methods like .split and .upper. When we assigned the variable human1, we just created a new human, just like we would create a new string by assigning a variable to a string. We can now call our methods. You may notice that there are other methods in here that start and end with 2 underscores. These are called magic methods, and we'll deal with them later on in the course. For now, we can just call, let's say, the move method from our human object. So when we run this, we get I moved, because we called the move method that was in the human object. So this is just like calling a string .split or .upper or whatever. Now besides the fact that objects can have their own methods, they also have attributes, which are kind of like variables that belong to a particular object. So let's create an attribute. Let's just type the name of the variable. So we'll do human1, and then with a dot, and then type a variable name. Let's type x. This variable belongs to human1, so we could have a different global variable somewhere else in the program that's called x, so we could just say x is equal to 20 or something like that. But human1, its attribute x could be set to 5. Now we can create another one. Human1.age is 23. And now we can just print human1.age, and we get 23. Now here's where objects get useful. Let's create another separate human, human2. Here we created a different object, human2, and set it to a new human. This object is completely different from the first object. If we tried to print this person's age, I'm just going to remove some of this extra code here. Okay, so if we tried to print human2's age, we would get an error, because we didn't create an attribute called age for human2. Human1 and human2 are completely different instances of the human class. Let's set human2's age now. Human2.age is 25. Now when we print it, we get 23 and 25. Alright, that's the end of this section. If you're having some trouble understanding classes, go back to the start of the section and try to create some of your own classes, and make some of your own methods as well, and just get used to making classes. In the last video, you learned how to create a class in Python. You also learned that you can create attributes for those objects. Something bad about the current implementation that we have over here for the human class is that we can create a human without an age attribute. So we can set human1 equal to a new human. So here we just initialized a new human and we're storing it inside human1. And now let's try to print the person's age. As you can see, we didn't even create an age attribute for the human class, or even just for human1, and so we get an error. The problem with this is that in our human class, you can create a human without any attributes. This doesn't make any sense because all humans should have an age, and so this is where constructors come in. A constructor is a function that always gets called when you create an object instance, like how we did right here. This allows us to pass variables into these parentheses, like their age, name, and so on. So let's create a class constructor for the human class. All constructors are functions that are called underscore, underscore, init, underscore, underscore. In Python, it must be called this. Init stands for initialize, which means we are creating a new instance with all the correct data and attributes. This method will always get called when we create a new human object. In the parameter section, we will also type self, and after self, we can create any parameters we'd like. So let's give each human a name and an age. Now in this function, we are going to set self.name equal to name. So this name is the parameter that was passed in through the argument, and then we'll also set self.age equal to the parameter age. Okay, you've typed self a lot, and now it's time for you to know what it actually means. The self keywords that keep showing up in the human class are references to the current object. Down below, when we created human1, self references this object. But if we created another human, self references that one. It just depends on whichever one you're focusing on. In the class blueprint, self refers to whatever object is initialized. When we set self.name equal to name, we set the name attribute of the current object, or the object that is currently getting initialized, to the parameter name. which should be passed in through here, but we'll do that in a second. I know it's confusing to have parameters the same name as the attribute, but it's pretty common and it's also conventional to do this. In your code below the class, we can actually change certain values, but first we have to properly initialize human1. We can just set their name, John, and then also pass in their age, 23. So now we are actually required to enter their name or age, otherwise we'll get an error, because this init function is always ran when you create a new human. And the init function should be at the top of all the rest of your functions. So now if we save this and run it, we just printed out our human's age. We can also print out their name. There we go, John. So this init method we wrote is used to initialize every human object and create all variables necessary. It's a constructor which is used to construct or create an object. Now pause the video and add a method to this person class that lets them speak whatever is passed into the function. All I want you to do is make another function that lets them speak, so it'll essentially print out whatever you pass in. If you can't figure it out, just keep watching. Okay, to do this, let's just simply add another method. I'm just going to delete these print functions for now, and let's just add another method over here. Make sure it's indented, and we'll define speak. We'll pass in self, but then also words, because you always have to have self for the functions that belong to this. And words will be passed in, so we will just print words. And so here we can make human1 say, hello, and there we go, we got it to say hello, because we passed in hello to human1.speak, so that's this method right here, and we passed it into words. Note that you don't actually have to type anything for this self parameter because it's not really an argument that you type into. To add on to this, we could make it so that we know who's talking, because if we have multiple humans talking, we won't know who's saying what. Let's make it print out like this. If John was saying hello, it would look like this. And if we had another human called Alice, then it would say, whatever they're saying, hi, right? So it would say whichever human is talking. So as you can see, this will make it easier to see who's talking. So to do this, we can utilize the name variable that we've created for each human. So first, I'm just going to create human2, and that's going to be equal to a new human, but this person's name will be Alice, and this will be 25. Okay, so now let's change this speak function. So let's print out the person's name by using self.name, and then let's concatenate a colon with a space, and then just concatenate words. So if self.name was John, it would say John, and then this colon would make it have a colon with a space, since there's a space here, and then it would just concatenate words, so whatever they said. So now we can make them talk to each other. So if I said human2.speak, how are you? And then human1 can speak, I'm good, how are you? So when I print this, now it says who's talking, because it knows that since we called human1's speak method, human1 is John, so it printed out John, hello. Human2's name attribute is Alice, so its speak method printed out its name and then the colon and the words. And so you can actually see who's talking, and it's almost like a play script or however you want to think about it. Classes are extremely useful. They can be used in almost every field of programming. For example, if you had some kind of game with characters that you can interact with when you walk over to them, each of these characters would be an instance of a character class. And when you talk to them, you could make a speak method that is called so they speak to you. Each character is different, but they all follow the same blueprint. In addition, classes can be very big. For example, a character class could include their name, their clothes, their skills, etc. They could have various methods like move right, move left, pick up an item, and stuff like that. Just like with the last tutorial, if you're having trouble understanding classes, go back and create some of your own. But this time make sure to create a constructor, also called an init method, that sets all variables for you. In this tutorial, I'm going to talk to you about inheritance in Python classes. Just like classes and functions, class inheritance helps reuse code. So in this video, I'm going to use the traditional explanation that deals with different animals. As you can see, I have a class that models a cat. This cat class has two methods, one that meows and another that lets it walk. This print statement and this print statement, they're just examples. In real programs, you'd have like 15 lines of code or hundreds of lines of code for every method in a class. But this is just an example. So now, let's say we wanted to create a dog class. So here's the dog class, but what if I wanted the dog to be able to walk as well? Well, I would copy this function, right? I just copy walk over here and put it over here, right? No. Remember, repeating multiple lines of code is never good in programming, because as you know, if we change some code in the first version of the duplicated code, like if it was buggy or something, then we'll have to change it in all occurrences of the repeated line, so we'd have to change it here and here. So this is where inheritance comes in. This is when we make classes part of other classes, or make classes inherit functions from other classes. With inheritance, we would make it so that both cat and dog inherit from a different class that has the walk class, so they both can use the walk class. So let me show you what this actually means. So let's create an animal class up at the top. This will be a class that all the other classes will inherit from, because cats and dogs are both animals. So we will make them inherit from animal. All the animals in this program that we're writing are able to walk. So it's safe to say that we can just put walk in the animal class, because there's no fish or anything like swimming or something like that. They all walk. So now let's just put the walk method inside of it. Make sure it's indented correctly. Okay. And now we will remove it from the cat and dog. But how do we make it so that the cat and dog classes both inherit the animal class? Because right now the cat and dog can't access this walk method. So how do we do this? In the class definition, we add parentheses, and inside these parentheses we add the name of the parent class. Classes that inherit from other classes are called child classes, so the cat is going to be a child class of the animal class. And the classes that the children classes inherit from are called parent classes. So animal is the parent class of cat. It's just like how a child inherits certain qualities from their parents. So in this case, cat will inherit or be able to use all the methods from its parent animal class. We'll also do this with dog as well. Great. Now the cat and dog classes both inherit the walk method, but they still have their own methods that are private to themselves, meow and bark. When you put the name of a parent class in the parentheses of another class or child class, the child class will be able to inherit all of the methods from the parent class. So to reduce repetition, we added the animal class that both cats and dogs are a part of. So now let's create a dog class. Let's create one cat and one dog, so we'll do dog1 is equal to a new dog. And we'll make a cat as well. That's equal to a new cat. And as you can see, the walk method is available to both of them. There's no squiggly lines or anything, and there will be no errors when we run this, so we can do cat1.walk as well. And the dog class still has its bark method, and the cat class still has its meow method. But as you can see, the dog class doesn't have the meow method. The dog and the cat class technically don't have anything to do with each other, except for the fact that they share the same parent. But the dog class cannot access any methods from the cat class. So if I try to run dog1.meow, we get an error because dogs don't meow, so that's why we didn't add that method there. And so we get this error because, well, we don't have this method available to dogs. So now we can create as many of these as we want, and we can add names to these and stuff like that. Let's add a name as well, so we'll add an init function. And we'll make it so we can pass in the name of the cat, and we'll set self.name to name. And we will copy this for dog as well. And note that it's okay to copy init functions. It's okay if they look the same. These are different classes, but they just happen to have the exact same init function. But that doesn't mean that we're technically repeating code. This is fine. What we gotta do is when we create these classes, we can actually just say dog1 is equal to a new dog. And let's pass in the name John again, because I always use that name for these examples. And then dog2 will be a new dog, and this will be Alice, because I also always use that example. And we'll create a cat that's equal to a new cat, and let's do Derek. And then let's create another cat that's equal to Jack, okay? So now we have 4 objects in our program, 2 of which are from the dog class, and 2 of which are from the cat class. They all have individual names. And let's say we want to do something with these names. So as you know, we can make it just print the names. So we'll do self.name plus, and then a colon. This will just say who is meowing at this point. Actually, we don't need to do that. We just do this. All right, so let's also do that for bark as well. And now we can make different things bark or meow or whatever. So we can make dog2.bark. We can make cat1.meow. Cat2.meow. and then dog1 can now bark, but we can make dog1 bark multiple times. You know, you can do whatever. So when I run this, we get each of these just meowing and barking, and it's crazy now. That's how you would do that. I just decided to add more of the init functions so that you could understand what that does, but we did learn that in the last tutorial. So hopefully you're able to understand this. If you didn't, just like the last two tutorials, make your own inheritance classes, make your own init functions, do whatever you need to do to get used to this, because the only way to get really good at programming is to program. So make sure that you understand classes fully, because they're a very, very useful feature in programming. In this tutorial, I'm going to talk to you about modules in Python. A module is essentially a file with Python code. So just like our tutorial.py or whatever you called it, the file that you write all your Python code is a module. We can use these modules to organize our code into multiple files. Instead of writing code in one file, it's better to split it up into multiple files if your program is that big. Most tech companies use hundreds or even thousands of files. Each file is called a module. We could have lots of functions in one file, and by importing that file into your main file, you can have access to all of its functions. If you remember, we briefly touched on importing modules that we didn't write. Instead, we imported the random and the OS module, which were not written by us. But in this video, you'll learn how to write your own modules for your programs. In this file, we have 4 functions. We've got add, subtract, multiply, and divide. Each of these functions just divide all the arguments, or multiply all the arguments, or do whatever operation on the arguments, and then it returns it. We can put these functions in a separate file, or module, and we'll call that file operations, and then import that module so we can use these functions. To create these extra files, we're going to use our code editor. If you want to use your file manager, that's fine too. To do this, it can be slightly different for every code editor, but in VS Code, hit this button over here that looks like a paper with a folded corner, and it says folders when you hover over it. As you can see, I'm in a folder called tutorial, and there's one file in here, which is my Python file. Upon clicking this paper with the plus symbol, we are prompted to create a new file. Let's name it operations.py. So make sure you put .py at the end so it knows it's Python. Now we get a new file, so we can keep switching between these if we want. Alright, so now go back to tutorial.py and select all of these functions and do Control X to just cut them, and then do Control V to paste them in the new file. And now you can see that we don't actually have access to this function anymore since it's not in our file. At this point, I'll close this folders panel so you can see what I'm doing. I have VS Code zoomed in so you can see the code just for these videos, so the panel takes up a lot of space, but when programming, you usually not have it zoomed in like this, and with big projects, it's okay to have the panel open, but I'm going to close it. Okay, so as you can see, tutorial.py doesn't work because multiply is not defined. So now we need to import operations so that we can access its functions. So we'll go up here and simply type import, and then operations. This works because operations.py is in the same folder as this file. And you don't need to put .py at the end of operations. Most Python module files have the .py extension, but when importing them into Python, you don't need to type the .py. Python already knows. When you import a module in Python, it's treated as an object of the type module. So when using these modules, they're always treated as objects. So to access each function in a module, you call the functions the way you'd call them from an object. Can you guess how we can call the add function from operations.py? Since we have it imported, we're now treating it as an object, so we can just type operations and then a dot. Now VS Code suggests all 4 functions that are available. We can just call one of them now, so let's do add. And make sure to surround it in a print statement, but we'll do 10 plus 5, and then surround this in a print statement, so you can view the output. And when we run this, we get 15, because we have imported our operations module, so that means we have access to all of its functions, which are these, and we've passed in the value to operations.add. So this is treated as an object, and so that's why we're able to call the add method from it. And like I said, I mean, we can add as many numbers as we want in here because I have args, so 30. And yeah, so that's how you import modules. In the next video, we're going to learn about a different type of syntax for importing modules in a different way. Importing modules is very useful because we can organize our code into separate files. In this short tutorial, I'm going to show you another syntax for importing modules. So if you remember from our previous video, we had a file with 4 different functions that add, subtract, multiply, and divide. And we imported it into our main file by doing import operations. This works because this file is actually in the same folder as the current file that we're using. So as long as it's in here, then we can import it. And you might notice that after running this, you get PyCatch. This is fine, just don't worry about it. Just ignore this. So these are the 2 files, and tutorial.py is the file that we run when executing our program, although our program does consist of 2 files. So here's the other syntax I'm going to show you. Let's just delete all this code, and let's say we only wanted to import just a few functions from our operations module instead of the whole module. Let's make it so we can only import, add, and subtract. I'll type from operations, so this is the module we're importing, import, and let's do add and subtract. So with this, we're saying, I want to import, add, and subtract from operations. So it's from the operations module, import, add, and subtract. It reads kind of like English. We have a different way to actually run these functions. So when using the from keyword, you don't use the module name like this, .add. You don't do operations.add like we did last time. We actually don't need this whole entire thing. We just do add, because when we're importing functions from a module, only specific functions, those functions are treated like they're just functions that we just wrote up here, like add, and then, args, whatever. It treats it like we're writing it in this file. So instead of it being an object, we just get this function, so we can print add 10 and 5, and we'll do 2 and 3 and 4, and here we get 24. So the reason you don't actually have to add the operations is just because we usually import it as an object with functions inside of it, which was just import operations. But when we import specific functions, we're just treating each one as a function that's part of the current file, meaning we don't prefix it with a dot or anything. Modules are very useful for organizing our code, because instead of writing all the functions and classes in one file, it's better to break it up into separate modules, as long as it's a big enough program. This program is very small, so we actually don't need to do that for this program, but it's just an example. All functions and classes in one module should be related. For example, we called our operations module operations because it contained functions that did mathematic operations. If we had a different function that sent an email, we would definitely not put it in operations. We would have it in an email.py file, and it would not be in operations. In this tutorial, we're going to talk about packages in Python. Right now, we have the main file with nothing in it, and we have 2 other files. So from the previous example, I split up the operations file into 2 files. The first file is add and mul.py. Mul just stands for multiplication, and this file contains the add and multiply functions. The other file is sub and div.py. Sub means subtraction and div means division. And as you would guess, this contains the subtraction and division functions. So as you can see, we have all the files, all the modules in one folder or directory. In tutorial.py, we will import these files, right? So we can just do import add and mul, and then import sub and div. And what we also could do is we can just go like this, just like that, does the same thing, just do it in one line. But before we get into packages, something I want you to know first is the as keyword. So when we import both of these, let's do add and mul and import sub and div just on separate lines, the as keyword. So with the as keyword, after an import statement, you change the name of the object that is used when accessing a module's functions. So if you remember, we used to call add and mul.add, for example. This is an object now, but when you use the as keyword, you're changing the name of that object. You're not changing the name of the file, but you're just changing the name of the object that you're using, just the name of it, nothing else. With this, you can shorten the name or do whatever you want. And so in this example, I'm just going to do AM, so it's just the first letter of add, the first letter of mul, and then this one as SB, same thing over there. As you can see, this is an easy way to change the module object for your program. This isn't always used for modules that you write yourself, because you can just change the name of the file. But if there's a different module that you're importing, like the random module, you didn't create it. But just for your program, you might want to call it something short, like R, for example. So import random as R. You can do that. And so instead of saying random.randint, if you remember, like 1 to 100, this will get a random number from 1 to 200. you'd actually just do r.random. Okay, so I'm just going to delete these, and let's go back to packages. So when you make lots of modules, it's not best to put everything in one directory or folder. Since there can be so many files, it can be hard to maintain. So just like we put related functions inside modules, we put related modules inside packages. A package is just a container for multiple related modules. It's not that hard to make a package, because a package is literally just a folder with modules inside it. But in Python, we call it a package, since it has Python files in it. So inside our current project, you should open up your file panel with this button over here, and create a new directory by hitting this button. And let's call this operations. This is just like before when we had operations as one module. I just split them up so I can show you packages, but you really wouldn't separate just the 4 basic mathematical operations into 2 files, but this is just an example. But this isn't a package yet. You can move these files into here if you want, but it's not a package yet. So to make it a package, you have to actually put a special file inside of it. So with this special file, Python will know that it's a package. So let's create a new file and call it __init__.py. The name of this file is just like when we created init functions for our classes, but this time it means something completely different. When Python sees this init.py file inside a directory, it treats it as a package. You don't need to write anything inside this file. Python will just know that the folder is a package because it has this file name inside of it. Now, we could drag and drop our operations files into the operations folder. And there we go, we just moved it in there. So if you just followed along, you just created your first Python package. So let's get rid of all the code inside tutorial.py just to start from scratch. When we make a package, we type import, and then we need to type the name of the package, so operations, and then a dot. Because this isn't a module, this is just a package, we need to specify what we're importing from it. So after this dot, you type the name of the actual module. So like I said in the first video about modules, when you import them, you don't type the file name, instead you just type the module name, which is the name of the file without the .py extension. So this still applies here. We'll do add and mul first, and then we can import operations.sub and div. Okay, so we just imported these modules. To access these functions, we still need to type the operations dot and then the name. So if we wanted to do this, we would do operations.sub and div dot divide, for example, and we'll do 10 divided by 2. And this is kind of long to type, but there are shorter ways to do this. We can also use the as keyword with this as well. We could do import operations.add and mul as am, and we would just say am.add if we wanted 10 plus 3. You can also still import specific functions from a module inside a package. So you could still say from operations.add and mul if you want, but that is long. So what I'm going to show you is useful if you don't want to type out the whole operations dot and everything like that. So we will do from operations, so we'll remove all this and say from operations, and then we can just import add and mul, and then also sub and div. And so this is probably the best way to actually import specific modules from a package. And so we just imported these 2 modules. And now we can just do add and mul dot add if we wanted, and do 10 divided by 2. And actually we would have to print this though too, so we'll surround that with a print. And here we go. If we expand this, we will see that we got 12. Hey everyone, in today's video I'm going to show you how to use the random module in Python. So I'm going to show you some of the basics of random, because once you learn how to actually use the basics of random, the rest of it is just, you can just look at the random modules documentation on the internet or look these things up. Python comes with a standard library that contains many modules for tasks like working with date and time, the operating system, getting random values, passwords, and more. So we can reuse all these modules, so we can reuse the code from certain modules to be more productive and efficient. And if there's ever a module that does certain work for you, it's better to choose the module than to write your own code for the same task, because these modules are written by many people and are often contributed to, which makes them the best they can be. They're fast and reliable. If you ever want to see all the built-in modules, just search for Python 3 module index on the internet and go to the one that's at docs.python.org. And here you can see there's a lot of these modules. Nobody knows every single built-in module, so I can't show you every single one, but depending on what you specialize in, you'll have to learn about modules related to your niche. So while this is true, I'll still have videos on my channel about different Python modules, including this video, which is about the random module, so you should go check those other videos out if you want to learn about more. but some modules are very narrow, meaning they're only good for a specific niche, while others are broader scope, just like random, meaning they're used for many things. In this video, I'm going to talk to you about the random module, which is what most people learn first, one of the first modules that people learn, because it's easy and it's interesting and it's broad. So as you know, it's already on your computer since they come with Python, so let's import random. Now let's just do a random function, right? So we could just print the output of random.random. You can use random's random function, which will give us a random value between 0 and 1. And now note that these values are actually pseudo-random. If you don't know what that means, don't really worry about it, but I know there's going to be somebody who tells me that it's not actually true randomness, it's pseudo-randomness, but we get close enough. This is a value from 0 to 1, but if we wanted to get a value from, for example, 1 to 100, we could change this to rand_int and pass in 1 and 100. So this could be from 1 all the way to 100, but no more than 100. So if I save this and run it, 13, 86, 17, 25, 36, 92, you get the point. And we can change this to 10 if we wanted as well. So just remove that last 0. We get 8, 6, 5, 9, 5, 1, 10. Another thing I want you to know is how to pick a random item from a list. So let's just have a list called fruits, which is what I always do when I'm teaching lists. I always make a list of fruits. And I do apple, let's do banana, let's also do watermelon, strawberry, and then grape. So with this, we can now just print a random value from this, so random choice, and then we will pass in the list that we want to pick a random value from, so all the fruits. This also works with tuples as well, and sets, I believe, and so we get apple, strawberry, watermelon, apple, strawberry, apple, watermelon, and yeah, so that's how you do the list one. And lastly, I'm going to show you how to make a heads or tails program, so like a flip a coin type thing. For this program, there's many ways to do it. Just like many things in programming, there are lots of ways to do things. So for example, let's say we wanted to flip a coin. First, we can write a program that picks from 1 to 2, and if it's 1, then it's heads, and if it's 2, then it is tails. So let's just do if random.randint, so we will say if a random value between 1 and 2 is equal to 1, then it is heads, so we'll print heads. And then if it's not, so else, tails. And there's only 2 possible outcomes for this, 1 and 2, so that's why it's safe for us to say else. So we can run this, you get the point. But a shorter way to do this is to actually create a tuple called coin, set that to heads, and then also tails. The reason I'm not doing a list is because we're not going to edit the sides of a coin ever, so we'll just print random.choice and then coin. And this is a faster way to do it. It's only in 2 different lines of code besides the random import, and yeah, so that's a shorter way to do it, and there's a lot of different ways to do these types of things. As you can see, there's a lot of great things to use this module for, and if you're liking how much you can do with just this module, think about the hundreds of built-in modules, and there are also even more, thousands of modules that you can use that aren't built into Python, but you can still install them, and that'll be for a later video on how to install those and use those. In past videos, we learned how to create modules, make packages, and use one of Python's built-in modules. But sometimes there are tasks that you need to complete, but there is no built-in module for what you're trying to do. Built-in modules aren't the only modules you can use. There are also Python modules that aren't included with Python, but you can still install them manually. If every possible module was made built-in with Python, it would take up all your computer's storage space. That's why you can specifically install certain modules that you need. You can find all sorts of modules and packages at Python's package index, pypi.org. Here are thousands of packages that people have written and published here for us to use. For most functionalities, there is a good and reliable package for you here, so you don't have to waste your time writing code that has already been written before. You don't need to download anything directly from this website to use the programs. There is a program called pip, P-I-P, which is used to install these packages to your computer. To show you how to install packages, I'm going to be showing you how to install NumPy. That's a Python library just used for working with arrays, algebra, and more. If you search for that package on PyPi, you can see the command to install the package. To install any package, we use the pip command. Sometimes you might see pip3, and I don't know if one of the commands will become deprecated in the future, but as of recording this video, pip and pip3 do the same thing. It used to be that pip referred to Python 2, while pip3 referred to Python 3, but now both of them should do the same thing, which means that they should both refer to Python 3. So let's go back into VS Code. You can enter the command in any terminal window or command prompt, but you can also do it in your code editor if it has a terminal. So open up the terminal section, and instead of running the Python file, I'm actually just going to type the command that you can copy. So it's pip install numpy. And like I said, you might have to do pip3, and I'm actually just going to type pip3. So when I enter, it says that it's already installed on my computer, but for you, if it's not installed, you'll have to type Y. So now it's installed on my computer, which we can simply access it by saying import numpy. If you ever want to remove a package, you can type pip uninstall or pip3 uninstall, and then the package name, so numpy. And over here, you'd have to say Y or N, Y for yes, N for no. I'm going to say N because I don't want to uninstall that. In this video, I'm not going to show you how to use numpy. This video was just to demonstrate how to install packages with the pip command, since you'll have to do it at some point in your Python journey. Like I said with the built-in modules, it's impossible to show you every single module, so you'll have to pick certain modules for your field of expertise. For example, if you are building a website, you will have modules like Flask or Django, which are both website libraries for Python. But there are other things for other fields of expertise, and it's impossible to show you them all in one tutorial. However, you can look at my channel, and there will be videos on certain modules, but of course I can't make videos on every single one. In this tutorial, we're going to explore a fundamental concept in Python and programming: file handling. File handling is an essential part of any programming language. It allows us to interact with files on our computers, which is important for reading data, storing information, logging, and more. In Python, file handling is performed using the built-in open function. The open function is used to open a file, and it takes two arguments: the file name and the mode. The mode indicates how we want to interact with the file. The modes can be R for reading, W for writing, A for appending, and X for creating a new file. Let's look at an example. So as you can see, I have this text file example.txt. Any file that ends with txt is just a raw text file. So I can close this, and let's do an open. Let's open that file. So we set file equal to open, and then we say example.txt, so that's the file name. This works because we're in that directory, but if we were not in a directory, we would have to enter the file path. And then we will just type the mode in a string. So here we get R, and there are a lot of modes. So I just gave you a very, very short list of them. But if you look at all of these modes here. There are so many in here, and they all have to do with just how you're writing the file and things like that. And now we'll say content is equal to the returned value of file, because open returns an object for the file, and so now file is an object, so we can say file.read, because we're calling file's read method, so this will return all text inside the file. Then we can just print content if we wanted, and then we actually have to close the file, so we'll do file.close. We have to close the file always after we're done using it with the close method. This cleans up all resources. Try not to forget about this line. Okay, let's run this. And here we ran our program. We got, hello, this is a file I just created. This is line 2. That's exactly what I put in example.txt, which is the file we just read. To write a file, we use the W mode. Be careful, this will overwrite any existing content in the file. For this, instead of using .read, we use .write. So let's just redo this. Say file is equal to open, and then example.txt. And then we will use the W method, which is for write. Next, we will say file.write, and then we'll just say what we want to say. So hello world, instead of what we had before. And then now we'll say file.close. So we run this. We don't get any output. This that you see here is just part of the line that's used to run the Python file. Since it's zoomed in, it overflowed over there, but as you can see, we get no output. And if we were to look at example.txt, now it says hello world instead of what it said before, because we just wrote to that file. If we want to add content to the file without deleting the existing content, we can use append mode. So let's set file equal to open example.txt, and we'll use the append mode. Next we will write to the file, and we don't have to change this method because .write actually just reflects what mode we're in. So if we were in read mode, which is R that I showed you before, write wouldn't work. But with what write does when we're in append mode is it just appends stuff to the end of the file. So now I can say what we want to say. We can add a new line here and say hello world, I guess. Again, we'll add another one, but this time we'll have an exclamation point so you can see the difference. We can save this, and actually first we have to do file.close, and then we can do that. Alright, here we go. And let's check the file. Now it says hello world twice, one with an exclamation point, one without it. Now let's look at a safer way to handle files using the with keyword, which will automatically close the file even if exceptions occur. So when you're actually trying to open the file or stuff like that, and let's say that we had file is equal to open, and let's say we were writing some stuff, and somewhere in here an error happened before we were able to close the file. That's not very good because the file would stay open, which means that we didn't clean up the system resources for this file, and it's just very important to do this. So with the with keyword, it closes it no matter what, if we got an error or not. So we say with open example.txt, and then we can say comma r, and then we'll say as file. So this time we are saying we're gonna open this as the variable file, and we'll say content is equal to file.read, and then here we'll say print content. We run this, and it prints the content. We didn't need to close this file explicitly because Python took care of it for us with this with statement. When we are reading the file, we are only able to read it and we can't write to it. When we had the W mode, we were only able to write to it and we were not able to read to it. Now, if you wanted to be able to read and write to a file, what we could do is we could say with open, and then we will say example.txt, and we will set this to R+, which will make it so that we can allow both reading and writing operations on a file. If this file doesn't exist, it will raise a file not found error. So if I did example1.txt, right, I could say contents is equal to file.read, and then print contents. And so here we can run this, right? And it says file not found error. And so what this method does is, if it exists, it allows us to edit the file. But if we did W+, this allows the same thing except for the fact that if it doesn't exist, it'll create the file. And so if I run this, we don't get anything because the file has nothing inside it. And here's example1.txt that was just created from this, and there's nothing in it. So the difference between R+ and W+ is that R+ doesn't create a new file, and W+ does create a new file, but will overwrite the existing file, just like W did, like I showed you. So those are the most common modes for the open function in Python. In today's tutorial, we're going to dive into the magical world of Python's magic methods or special functions. Magic methods in Python are special methods that add some magic to your classes. They're distinguished by their double underscores at the start and end, like underscore underscore init underscore underscore, or underscore underscore str underscore underscore. So as you can see in the example on screen, when you normally print a class, you just get the representation as the address to where it is located in memory, because Python has no idea how to show you what this actually looks like, because Python knows what a string is, it knows how to represent an integer, it knows how to represent all these things, but we created the type person here, and Python doesn't know how to represent it as a string or an integer or whatever. And so the str method changes how a class is represented when you print it as a string. Magic methods grant us the power to override or customize some of the built-in behaviors of Python objects and simulate built-in types. They enable us to set our own rules for things like instantiation, representation, comparisons, arithmetic operations, and much more. Normally when you try to print an object, you get a weird string that shows the address to where it's located. With the str method, like I said, it changes out how it prints the object. The reason Python had no idea how to print it out was because we created the model ourselves. And so they're like their own new type. Python knows how to represent strings, but not the numbers, like I said. For a very basic explanation, magic methods tell Python how it should behave when you do certain things with classes, like try to convert a class to a string, use comparison operators like equal to or not equal to, and more. Probably the most familiar magic method you'll see is the init method, just like this. As you learned in one of the classes videos, this tells you what happens when you create a new object. So let's say we had class person, and we define the init method, which is run when you create an object. So we have to pass in self, and then we can pass in name and age, and we'll set self.name equal to name, and self.age equal to age. And when we create an object by saying, for example, John is equal to a new person, and his name is John, and his age is 30, that init function gets called when we create a new object. Another pair of commonly used magic methods are str and repr. They're used to provide human-friendly and unambiguous string representations of your object, respectively. Let's change our Python class and add these to it. So we'll define what happens when you try to convert to a string. So we'll do string and self. Then, so normally actually when I get rid of this first, right, and we create the John, right, like this, we do this, and let's say we wanted to try to print John. Normally this is what we get, and this doesn't really show us anything good. But if we actually added the str, so for example def str, we can return, and then we'll do an string formatting. We'll say self.name, and then self.age years old, which will then print out John 30 years old when we try to print out an object. And so that's useful when we're trying to, see our object. So when we try to print it out, it's just an easier way of saying, okay, well let's print John.age plus John.name, all this weird stuff. We just have to print it, and every time we want to print it, we do this. Next, let's do the repr. So we'll do def repr, and here we will return the string formatting of person, and then in parentheses we can just say we'll have quotes, and then in here we say self.name, and then self.age. And so what this is doing is we use a more detailed string representation used for debugging. So usually when you have the repr, this is for only debugging when you're making your program and you want to print it out and see everything about it. So if we had another value that was called like address or something, we can put address in here as well. So after these quotes, we would put an address, maybe like self.address or whatever. But then when actually printing it out and showing it to a different user, maybe, for example, maybe the program hid the address from a different person, I don't know, whatever it is, this one is used for debugging. So what's actually going on here is when we're printing John, it's actually under the hood doing this. It's doing str John. It's doing the same thing as the first one, but then when we do repr, and so this repr actually stands for string representation, so representation, that's why it's repr. And so when we print the repr version, we get person, John, and 30. And if you remember, that's actually kind of like when we had a dictionary and we did like dictionary.keys, and it returned an object that was dict keys, like this, and it was like that, and then it contained a list of all the keys in the dictionary. If you don't remember that, that's completely fine though. But it's kind of like that. So when we print John, Python automatically calls the str method, but the representation method, or repr method, is used when we need a detailed string representation, which is helpful for debugging. Now, arithmetic methods like add, subtract, multiply, and divide are not completely useful for this class yet. So if we had two people, we had John and Alice here, and we said person is equal to Alice, and then 29. If we try to print, for example, John and Alice, what we get here is unsupported operand types for person and person, because we're used to concatenating strings or adding numbers, but the type person, it doesn't know what to do when you actually add this, because it's not a string or a number, and like I said, Python doesn't know how to actually do it. And so here we can just say, we can define add self, and then other. These are magic methods, so they're actually very different from normal methods, because when you pass in multiple arguments to the add magic method, it's actually, these other arguments are the other things that are added to the thing. So if we had John, the add magic method would be called, and the argument would be whatever it's actually added to. So Alice would actually end up being other. We can call this whatever we want, but I'm calling it other. And we will just return self.age plus other.age. And so let's say we wanted to add their ages together when we add them together, right? Because Python didn't know what to do before that, right? Like, okay, it has no idea what to do. So we're choosing it to add their ages together. And so when we do this, we get 59. These also work with other magic methods. I'm not going to show you them each individually, but we also have subtract for sub, just like that. We also have mul. We have div. And so these are self-explanatory because I just showed you add. And so I am going to show you one more. I'm just going to show you subtract just so that you know that they exist. We'll do def sub and self. So like I said, you could just figure them out on your own since you already know how to use addition, subtraction. You'll obviously know how to do the division. So we'll do return self.age, and we'll just subtract the ages instead. So other.age. And we can change this to subtraction. And there we get 1, because, 30 minus 29 is 1. There we go. Comparison magic methods, like equal to, not equal to, that type of thing, lets us use these comparison operators like this, and stuff like that on our objects. If you know this, right, we had if statements that did this, but there's this way that you can print the Boolean value, so 1 is equal to 1, but if we said 1 is equal to 2, it would print out false, because that's just the Boolean value, it treats this as a Boolean. And so if we did A is equal to A, right, that would be true because they're equal to each other. And so it still works in if statements, but that's just another way to check that. And so if we did that with our classes here, John is equal to Alice, we would get false because no matter what, Python will treat these classes as false. Even if I had the person with the name the same and the age the same, it would still say false because they're in completely different memory locations and everything. And so that's just why they're completely different. And so Python will always say they're false unless we specify. We can just define EQ, which just stands for equal to. We can do self and then other. And then we'll just return the Boolean value of if their ages are the same, because this program is clearly just, as we're going, it's clearly based on their ages. So if I returned self.age is equal to other.age, so this is just seeing if they are equal to it, and here it'll still say false, but if we made Alice's age 30, then it would be the same, it would be true. There we go, because we changed how it behaves when we compare these two, and so this would still work in an if statement. If John is equal to Alice, then we can print they are the same age. And here we go, they're the same age. Now if I changed Alice to 10 years old, it would not say anything because we didn't have an else, so I can say else, which they are not. So there we go, yeah, they're not. So that's how you change the behavior that way. This works exactly the same with not equal to, all that other stuff. Okay, so I just wrote this table here. If you want to change how it behaves when you compare them with the equal to sign, use EQ. Not equal to is NE, less than is LT, greater than is GT, less than or equal to is LE, and GE is greater than or equal to. And so you can see they're just the initials of them. And just to show you that there's multiple, I'm just going to show you one more. Let's do greater than. We'll define what happens if we compare greater than. We'll pass itself, and then other. If we wanted, we could call other whatever we want, like I said. And this time, instead of returning only things with their age, let's just compare the length of their names. So John is 4 characters long, and Alice is 5. So Alice will clearly be the winner here. And so here we're going to return true only if self.name, and then we're going to surround this with len. So we're going to check the length of self.name is greater than the length of other.name. And so here what this means is we're returning true if self.name, so the current name, we're returning true if the person's name is greater than the other person's name. So to test this out, we'll say if John is greater than Alice, then we'll print John is greater than Alice, and then else print no. Okay, so here we get no. And if John, we just put a bunch of spaces here, right, just to add more characters, we say John is greater than Alice, and that's just because we compared these two. And the reason we need these, I know I'm explaining this again, but if you're a beginner and you're really confused, the reason we need this is because normally if we tried to compare John and Alice, like if John was greater than Alice, Python would be like, what are you talking about? What do you mean? What's greater than Alice? And we're specifying that we want it to compare their names. Otherwise, it wouldn't have known what we were trying to compare, because Python only knows that these objects are just objects located in the memory, but if we change the behavior, then the behavior is changed. So in this video, we went over init. I know we already went over that before. str changes the behavior when we try to print out a class, because normally it would print out the address to the location. Repr is the string representation for debugging, so it displays more information just to us programmers. We get add, which changes how additions behave, because normally if we added two objects together, Python would get mad and it would give us an error. Same goes for subtracting. Over here we changed how it behaves when we try to compare the two objects, because normally Python wouldn't know what to do when we compare these two. And so that's a glimpse into the many magic methods in Python. Each magic method offers unique capabilities, adding magic to your classes. As you master these magic methods, you'll find your code becoming more intuitive. If you have any questions about anything so far in this course, just leave them down in the comment section below. So the Python interpreter shell is actually an interactive environment for Python. So if you notice, when you're in a console window or terminal, you can enter commands, and these commands, the next time you enter it, a new prompt will pop back up. It's not like you're writing a file that contains a lot of commands and running it like we do with Python in this course. But what we can do is when we're in our terminal or command prompt, we can type Python 3, and this also works on just like normal terminal windows, so I can say Python 3 and hit enter. And so here we actually have a Python shell. And so what this is instead of writing files here, you can do quick and dirty testing to just test things. You're not going to do any important work here. You're not going to be scripting anything. You're not going to be saving real files here. This is mainly for testing. So for example, maybe you said, oh, I just learned about this new print function, and it prints text to the console. Let me just try it out real quick without having to choose the file name and save it and go open VS Code. You can just open up your terminal, type Python 3, and go in here and just say print hello world, and do something, and it'll print it on the next line. And so these three arrows here, what these do is that just tells you that you can type there. So whenever you see those angle brackets, that means you can type. In here, we can write, pretty much any Python code. We can do a for loop for x in range 10, and then it goes here. We have to actually hit tab to indent, and we can just say print hi, and we can exit it again, and here we get hi over and over 10 times. This is a very, very quick way to just test anything you're doing. You're not going to actually use this for anything in production, but it's very useful. The way to exit this is, as you know, most commands you do Control-C, but that's not how it works. You get the error keyboard interrupt, so you'll actually type the function exit, and then it'll exit for us. What that does is, right, instead of having to click new file, tutorial.py, and then save your file, and then start writing stuff in it, and then saving it and running it, you can just do the quick testing in there. And so that's just a quick way to test things. It's just a Python shell. You say Python 3, you're in it, you can do anything. And you can import modules, so import random. You can say print random.randint 0 to 100. And we get 22, do it again, 93. And in situations like this in the terminal, if you ever want to enter the most recent command, click the up arrow key, and you can hit it as many times, and it'll tell you all of the things that you have typed before. And so we can keep generating random numbers over and over and over. So this isn't meant for complex programs, but it is used for testing, and it's a very, very nice tool for testing. Hey everyone, in this tutorial, we're going to talk about Python's virtual environments. To start with, let's understand what virtual environments are. In Python, they're isolated environments where you can install packages for a particular project without affecting your global Python setup for your entire computer. You might wonder, why do we need these? Well, they're essential for maintaining project-level dependencies. Each of your Python projects may require a different version of a certain package. By using a virtual environment, you can have an isolated space in your system for each Python project, tailor-made with the specific packages that the project needs. In addition, it's also good to have your big projects in a virtual environment, because if you ever transport them to a different computer, then you'll have all of your modules that you need to import right there without even having to install them on the other computer. So Python comes with a built-in module to do this, called venv, V-E-N-V. It stands for virtual and then environment. Let's see how we can use this to make one. So to create a virtual environment, we have to navigate to our project's directory in the terminal. So as you can see, mine is in Documents, my Documents folder, and then inside this folder, I have a folder called Tutorial. That's where my tutorial.py is located, and so wherever this is located, this is where you're going to create your virtual environment. So let's type Python 3 -m venv, and then you can call this whatever you want. Let's call it my env. And so this will create a folder containing all of the packages. So this tells Python to run the venv module as a script, which will create our virtual environment. So first, before I do this, I want to show you, if I click on here, there's nothing in this folder besides tutorial.py. Now when I run this, we get this my env folder because we called it my env. And so in here, we've got our virtual environment. Now you don't need to actually look at what's inside this folder. You don't even have to worry about it at all. As long as you activate your virtual environment, you're fine. To activate this, or be part of the virtual environment so we can install packages to it, we're going to have to enter a certain command. Now if you didn't do this, and you did, for example, pip3 install requests, it's just a random module that we're going to be using in this example, it would install it just on your normal computer, not in the virtual environment itself. And so to make it in the virtual environment, we have to actually activate that. So there's two different ways depending on what kind of operating system you have. If you're on any Unix-like operating system, like macOS or any operating system based on the Linux kernel, you're going to type source env or my env /bin/activate. And if you want to know what this does, it's essentially saying, well, we are going to source the activate script, which is inside my env and then inside bin. So my env bin, we have activate here. This is, activate. So that's what we're running. We are sourcing that. And so when we hit enter, now you can see we actually get my env in parentheses here that tells us that we're in this virtual environment. And if you're on Windows, you're going to type this. You're going to do /my env /scripts and then activate. So that's what you'll type. Obviously, I'm not going to type that because I'm not on Windows. And so once this is active, we can install any Python packages using the pip command, or pip3. Let's install something to this virtual environment. Let's install requests. So pip install requests. And it has installed it to my env. And so it's only in my env. I don't think I have requests just on my computer itself. It's only in my env. So only Python files in this project can use my env. And now we can just say import requests. And you're only going to be able to run this Python file if you've activated the virtual environment. So if you run this when you're not in the virtual environment, if you just run your Python file normally, you're going to get an error. It's going to say requests is not defined or whatever. And so let me just deactivate this real quick. So you just type deactivate like I just did. And so if I were to run my Python file now, it wouldn't work unless requests was also installed globally on my system. So remember, every time that you go into your project, you'll have to activate this. And so it's going to stay activated. It's not like you enter one command and it deactivates. So I'm going to activate again. And so now it's activated. And now when we run this, it'll definitely work. And so after I import requests, we can just use it, for example. Here I could just say, for example, response is equal to requests.get https://www.youtube.com, and then let's just print response. And here we get the response. And if you don't know what requests is, it's just a module used for, as you can see, if I hover over it, it actually says what it does in VS Code, but as it says, it's an HTTP library, so that means it's for web development or building websites. And you can do all sorts of things with it, and we're not going to go through this. This is just an example. I just did a request to youtube.com, and it gave me a response, so that means it was valid. YouTube is up, it's running. And so, yeah, but we don't really need to worry about that right now. And one thing I do want to show you is that if I go into my env and I go to lib, in here you can see that we have pip. We've got all sorts of things related to Python. We've got pip installed here. We've got Python 3 inside this bin here. stands for binary. Our module is actually installed in here somewhere, right here, requests, because we just installed that. There's obviously some stuff that's already there from the virtual environment to make it work, but we installed requests, that's it. We get requests, here's the module, and yeah, that's pretty much it. When you are doing any kind of project, a lot of the projects on my channel actually will have virtual environments. Always just do Python 3 -m venv, and then I usually call it env, but I call it my env this time just so that you can see that you can change what it's called, and it doesn't have to be called env. But yeah, and then like I said, you can deactivate by doing this. And to remove the virtual environment, all you have to do is you just have to delete this folder, my env. So just say delete, and it's gone. You no longer have this, so you can't source my env activate anymore. You can't do that. Here it is. It doesn't know where it is because we don't have that virtual environment anymore. And if this wasn't installed on your actual system, like on your global system, it wouldn't work. It looks like I already have requests on there, but just pretend I didn't, I guess, for this video. And yeah, and a lot of times actually, even if you have it on your system, it's a good idea to install it here, because if you're working on a project, you can transport it to different computers with other people working on it. And also there can have different versions or specific packages. For example, if we were working on a Flask project, a lot of times, even though I have Flask installed on my actual computer, I always just install it to a virtual environment. It's just good practice. Flask is just a web development library, by the way. And so yeah, so that is how you do virtual environments in Python. They are just ways to containerize all your packages for one project, and so you can see all of them in your current folder, and they're not just installed on your system. Hey everyone, since we're pretty much done with our course so far, it's time for a refresher on almost everything we did in this course. I'm calling this a test, but you should think of it more as a refresher to see how much you learned about Python and see how much you know. And of course, it's okay if you don't remember everything. Nobody remembers everything the first time they do a Python course. You just have to practice a lot. In this video, you don't have to actually think about the answers if you don't want, and you don't actually have to type any code. This is just to refresh you, and so that you can see the answers and just get a really quick refresher course on how to do everything. It doesn't necessarily have to be a test where you write stuff out and then check your answer, but if you do, then just make sure you pause the video before I answer each question. Alright, so let's get on with this little refresher test. There will be multiple choice questions, there will be coding challenges, so you can actually just type code in your code editor if you want, or just think about it. And like I said, it's okay if you don't get every question right, so let's get started. So the first question is, what is a variable? Is it a sequence of characters, a container that holds a value, a data type, or another word for a Python module? It is a container that holds a value. It's not a data type. Data types are what variables hold. They hold values that are data types, but variables themselves are not data types. Which answers below are data types? Variables, lists, strings, functions, or all of the above? Lists and strings are data types. Functions and variables are not. So here I want you to create 4 variables. One is a string, one is an integer, one is a boolean, and one is a float. Alright, here I have my str is equal to hello world, my int is equal to 1234, my bool is equal to false, and my float is 12.34. Of course, these don't have to be the same values. As long as they are floats and booleans and strings, it is okay. Which of the following is string formatting, which is concatenation, and which is repetition? A is formatting with f-string formatting. B is string repetition using the multiplication operator. C is also formatting but using %string formatting. And D is concatenation using the plus operator. Which of the following are forms of control flow? Conditional statements, for loops, while loops, lists, function or method calls, exception handling, or with statements? All of them except for lists are forms of control flow. If you remember, we briefly went over with statements, which are just a safer way to open files. Write an if statement. If my bool is false, then print no, and if it's true, then print yes. There are many ways to write this. I said if my bool, then print yes, else print no. So you could have done if my bool is false, then print yes or else or whatever. As long as you get the job done, it is good, but this is probably the shortest and most readable way. Which of the following does not return a Boolean value? So assuming x is 10 and y is 20, which of these does not return a Boolean value? The answer would be B, because B does not return a Boolean value. Instead, you're just setting x to y. Remember, you have to use the double equal sign to actually compare things. So using a single equal sign would set a variable. What will print if x is 10 and y is 20 and I print x is equal to y? Would it be true, false, or an error? It would be false, because in the print statement, we are comparing x and y, and that statement is not true, so it's false. What does the dot capitalized string method do? A, does it make all letters uppercase? B, it makes the first letter of each word in the string uppercase? Or C, it makes the first letter in the string uppercase? The answer is C, the dot capitalized method only makes the first letter in the string uppercase. What does the dot upper string method do? Does it make the entire string uppercase? Does it make the first letter of each word uppercase? Or does it make the first letter in the entire string uppercase? It makes the entire string uppercase. Same for lower here. Does it make it all lower? Does it make every first letter lower? Or does it make the string's first letter lowercase? It makes the entire string lowercase. So what kinds of values do the three methods I just went over return? Do they return booleans, integers, strings, or floats? They all return strings. What does the isNumeric string method do? Assign a number to each letter, check if the string has any numbers, or checks if the string only has numbers. It checks if the string only has numbers. What does isAlpha do? Does it assign a letter to each number? Does it check if the string only has letters? Or does it check if the string has any letters? It checks if the string only has letters. What kinds of values do those two methods return? Do they return booleans, strings, integers, or floats? They return booleans, which means if the string is alpha, then it returns true. If it's not, it's false. Similarly with isNumeric, if it's only numbers, then it returns true. If not, it's false. What are loops? Here there are multiple correct answers. A form of control flow, a way to repeat code, a form of conditional statements, or a way to write better code. C is the only one we will not select. A, it is definitely a form of control flow. Loops just control the flow of our program very well. They can just repeat code or do whatever we're wanting them to do. With B, they're also a way to repeat code. And D, they are a way to write better code, because if you just repeat code and just keep copying and pasting code, that's not a good idea. So if you write a loop, you do write better code. What is a while loop? Is it a loop that iterates through something? Is it a loop that repeats 10 times? Is it a loop that stops when a statement is true? Or is it a loop that stops when a statement is false? It's a loop that stops when a statement becomes false. So for example, if I said while variable is equal to 1, and we went through the while loop, and then eventually it changed to 2, it would stop because that statement would be false. What is a for loop? Does it iterate through something? Does it repeat 10 times? Does it stop when a statement is true? Or does it stop when a statement is false? It's a loop that iterates through something, for example, a list or tuple, or anything that you can iterate through. Use a while loop to print hello world 10 times. You'll set a counter variable, mine is called x, and I say while x is not 10, we will print hello world, and each time we will increment x by 1. Now let's use a for loop to do the exact same thing. This is much easier with a for loop. We just simply repeat it 10 times by iterating through the range, so range 10. So it'll repeat 10 times, and we'll just print hello world each time. Print only the second item in my list. We'll index it with 1, since indices start at 0. Extract 2, 3, 4 from my list. We will index from index 1 up to, not including 4, so that would be 2, 3, and 4. Extract every item from my list except for the first item. Here we will index 1 onward, which is 2, and then everything else after that. Copy the contents of my list to a new list called mylist2. So just copy the contents of it into a new list. Here we'll just put a colon here to copy every single item and put it in list 2. extract 135, so every other item, from my list. Here we'll put 2 colons to add the parameter for the step of 2, so we will go by a step of 2 starting at 0 and just going until the list is over by a step of 2. Now only extract 2 and 4 from my list, which is still every other number but starting at a different point. Here we'll index starting at 1, go until the list is over with a step of 2. Extract world from my str. We'll index from index 7 up to but not including 12. So we'll start at w, which is index 7, and then we will stop before we get to 12, which is the exclamation point. Get a user's input and store it in a variable called answer. Here we'll just do answer is equal to the returned value of the input function. Check if the user entered yes or no with this input statement. We'll set answer equal to input, and we'll add the .lower method to make sure that they don't type yes with a capital Y or anything. Then we do if answer is yes. You could just say you said yes, for example. If it's no, you can say you said no. And if it's not, meaning else, then you said neither. Of course, you could have said anything in these print statements, and for a lot of these code examples, there could have been different ways to write these, and that's just how it is in programming. There's many different ways to do things. Split my str into 2 words, and each word will be an item in a list. We use the .split method to change it to a list, so we've assigned my str to the new splitted list. Now set x to the first word and y to the second word in my str. We'll just unpack x and y, because we know that there will only be 2 items in this list, so we will split it, and x will be the first one, y will be the second. Join each item in this list into one string. We will use the .join method, and we will pass in my list, and we will join them with a space. Print the index of world in my str. Remember, when indexing an entire word, it's just the first letter of that word that is the index. To do this, we'll just use the .find method, and we will find world, and this will print what the index of w. Replace hello with hi in my str. You can use the string method .replace, pass in what you're replacing, and then pass in what you're replacing it with. Print each letter in my str. We can use a for loop to do this. For every character in my str, we'll just print the character. Print each item in my list. Similarly, with the last example, we printed every item by using a for loop. Now I want you to tell me the similarity and difference between tuples and lists. You should choose the best answer out of these. Both are iterables, but lists are immutable, while tuples aren't. Both can contain any data type. Tuples can't be edited, but lists can. Or both are iterables that can contain any data type. While B and C are true, A is the best answer. Both are iterable, but lists are mutable, while tuples aren't, and they can both contain any data type. How are dictionaries different from lists? A. Dictionaries can't be edited. B. Dictionaries contain value key pairs. C. Dictionaries contain key value pairs. It's C. They contain key value pairs. Create a dictionary with the following criteria. Make a dictionary that has key value pairs, and the keys are string versions of numbers. So for example, 1 would be O-N-E, and the values would be the integer version. So 1 would be paired with the integer 1. This should go up to 4. Okay, here we are with 1, 2, 3, and 4 with their respective integers. Print 5 by indexing this 2D list. We'll use index 2 for the third item in the list, and then the first item inside that list. So 2 and then 0. What are functions? Are they blocks of repeated code, a type of list, blocks of reusable code, or any block of code in Python? They are a block of reusable code. Define a function that prints hello world. We'll use def, myfunc, and then we will just print hello world. Call your function 3 times. We'll just say myfunc 3 times and call it with the parentheses. Now define a function that greets a person by the name passed into a parameter. So there will be one parameter called name, and you'll use that to print the person's name when passed in. So just use the exact same example as before, but pass in name as a parameter, and then change the string to f-string formatting so you can say hello and then the name they pass in. Now add a parameter for the greeting instead of just hello, so make it so that you can choose what greeting it is, so maybe hi or hello or how are you doing. Just add another parameter and add another variable in the string. Now make it so you can greet as many people as specified. And here's a hint, use args. You're going to put a star in front of names, and for every name in the args, then you will print the greeting and then the name. So in this example, there can only be one kind of greeting, but there can be as many names as you want. So it'll print, for example, hello John, hello Alice, and however many people you've passed in. Unpack the numbers in numbers list into the add function's parameters. We'll just type add and then star numbers to unpack numbers into the function's parameters. Create a greet function with kwargs to match the function call below. So this greet function, John is equal to hi and Alice is hello, should return hi John and hello Alice. We'll define greet with kwargs. For every name in all of the keys of kwargs, we will print the greeting by referencing the greeting in the kwargs dictionary with name, since that's a key, and then we'll just print name after that in the same print statement. And we can just call it below like we did before. John is hi and Alice is hello, and that should say hi John and hello Alice. Define a divide function that divides two parameters. Handle a possible zero division error. So here we'll define divide, pass in two parameters. We'll try to return the divided value of num1 and num2, but if you get a zero division error, then just return can't divide by 0. Create a human class with the attributes name and age, and then use an init function to assign them when passed in during object creation. Class human, and then we'll define init. We'll pass in self, name, and age, and we'll just set self.age equal to age and self.name equal to name. Now add two functions to the human class that are move and eat, and they'll just print move and eat respectively. Def move self, print move, and then def eat self, print eat. Now make an animal parent class with a walk function. Then make dog and cat child classes that have private functions, bark and meow. So dog and cat should inherit animal and be able to use the walk method, but dog has its own bark method and cat has its own meow method. We'll define the parent class animal, we'll define walk, and print walked. Then in the dog class, we will make sure to put animal in parentheses so that it inherits from animal, and we can create the function, and same with cat. Initialize this class and then change their age after you initialize it. Below the code, we'll just say my human is equal to a new human, his name is John, and his age is 20. Then below that, we'll just change his age to 21 by saying my human.age is equal to 21. Import OS and then import random, but change random's object name to R. Importing OS is simple as just saying import OS, but then we'll use the as keyword to change the name of random for this program. What are Python modules? Choose two best answers. Another word for a Python file, code that you can reuse by importing it, a folder containing Python files, or another word for functions. They are both A and B. They are another word for a Python file, and they're also code you can reuse by importing it. What are Python packages? Another word for a Python module, code you can reuse by importing, a folder containing related Python modules, or another word for functions. B and C, it's code that you can reuse by importing, and it's also a folder containing related modules. What is pip? A place to find Python packages, Python's nickname, a program to install Python packages, or a Python module. It is a program that installs Python packages. What is PyPi? a place to find Python packages, Python's nickname, a program to install Python packages, or a Python module. It is a website that you can find Python packages. There is a file called example.txt. Open that file and print what's inside of it. With this, we'll just say with open example.txt, and we'll use the read mode. We'll set that to the variable file, and then we'll set contents equal to the return value of file.read, and then we'll just print contents after that. What are magic methods? A. Class functions that can change the way Python behaves when certain operations are done to an object. B. Functions that change the way Python behaves when you create a new Python object. Or C. Functions that change how Python behaves when you write a class. It is A. Class functions that change the way Python behaves when certain operations are done to an object, like when you try to add objects together, or subtract them, or compare them with comparison operators, and that type of thing. Start a Python virtual environment and install a module inside it. In our terminal, we will type python3-m venv and then whatever the name is. In this case, it's myenv. Then we will source myenv bin activate to activate the virtual environment, and then we can just install anything we want, and I'll install requests. Congratulations on completing my 6-hour Python course. I hope you learned a lot. In this course, we cover the basics of Python, including variables, data types, operators, control flow, functions, and objects. We also looked at some more advanced topics, such as modules, classes, and exceptions. I encourage you to keep practicing what you've learned in this course. There are many resources available online to help you do this, including more videos on my channel. The best way to get really good at programming is to simply code a lot. Build projects, explore your interests, and make whatever seems interesting. Keep exploring all the different fields of programming until you find your niche. On my channel are some projects for you to use as guides so you can learn even more. I hope you enjoyed the course, and I'll catch you next time.